First of all, thank you so much for enrolling in this course. And in this course, you're going to learn how to use Kotlin first of all. So we're going to go through all the language basics. We will then move on to functional programming concepts, which might be familiar to you if you've used Java 8 before. But otherwise, you're going to learn what functional programming is all about. You're going to learn about lambda expressions, how to use them. We're also going to take a look at some useful higher order functions from the Kotlin standard library. And once we're done with the functional programming part, we'll then go into object-oriented programming. So that, of course, you're very familiar with from Java. And we're going to go through all the concepts. You're going to see many similarities to Java. But we're also going to focus more on the differences and the features in Kotlin that don't exist in Java, like, for instance, data classes, extension functions, and so on. And those will prove very useful and very powerful also for Android app development and to write better code, to really work on some of the ceremony around Android APIs. We're going to see all that in the section on Android development at the end. So once we've actually gone through the Kotlin language itself, we're then going to move on to actually apply that knowledge to an Android app. But at that point, you will also be able to use Kotlin for anything you like. And Android is actually just one particularly useful use case for Kotlin. But you will also be able to use it to create desktop applications, web applications, maybe even, and so on, if you go deeper into those topics. So you're going to really have a strong foundation in the Kotlin language. We're then going to create an app which will actually help the user to stick to some habits that they want to follow. Like, for instance, going for a walk or running every day and things like that. So in this course, we'll then move on to create an app which actually helps the user to stick to some of the habits that they want to follow. Like, for instance, eating more healthy food or going for a run every 2 days. So that's the kind of app we want to create here. And we're actually going to improve that iteratively and apply more and more concepts. But this course is not an Android reference, as I mentioned. So we're really going to focus on how can we use Kotlin to really write cleaner code on Android and how to really also make it more robust, make it safer, avoid some of the errors that usually come with Android app development in Java, so that we really end up with more readable and more maintainable code. And that's unfortunately something that I really miss in other courses where they really use Kotlin in a very Java-like way, so that you don't really gain anything from using the language, except for maybe a little more conciseness. So that's really a focus in this course, to see how can we actually use those features that Kotlin provides to write better and cleaner code for our Android apps. Now, some of the things we're going to cover are a card view, implementing a recycler view, how to use SQLite databases, creating layouts and menus, and we're going to extend those later on iteratively based on your feedback and what you would like to see. But I'm also going to see if those fields or those use cases actually prove a nice way to show some of the benefits of Kotlin and prove some nice ways to make the code cleaner. SQLite databases, for instance, are a very good use case to really avoid much of the ceremony around database transactions using the concepts we're going to see in Kotlin. So those are really the situations where Kotlin proves really beneficial on Android, and we're really going to see many of those instances. There are many things in Android that require more work than they actually should. So at the end of this course, you're going to have a solid foundation in Kotlin. You're going to see how to use some of the concepts on Android, so that you'll also be able to understand the thinking behind it and be able to also apply it in any other instances, any other Android APIs, or even completely other projects that are not related to Android at all. So that's my goal in this course. I hope you're excited to learn about this, and I want to thank you again for enrolling in this course. If you have any questions, please let me know in the Q&A at any time. And with this, I'm going to say I'm going to see you again in the next lecture. So this is just a very quick video to just tell you how I think you can make the most of this course. I'm really thankful you enrolled in this course. I want to make sure you really get some learning and also some fun out of this course. So first of all, I would recommend you really do all the exercises, quizzes, and coding challenges, code-alongs that I have included in this course. And I would also try to add more along the way to really make sure you have lots of opportunities to really also apply what you learned in the lectures. Then next, of course, I really recommend, that's probably the most important thing, that you really code along with each of the lectures to really apply what you see in the lecture. If you only watch me doing something, you're not going to learn how to do it yourself. So really make sure you code along with each lecture and also do all the exercises, take the chances you have to apply what you learned. And with that, I think you're going to get at least 10 times the learning out of this course when compared to just watching the videos. Also make sure to always ask questions in the Q&A and to also give me feedback if you have any suggestions. You can also just let me know that in the discussions or via a private message. You have all the possibilities to reach me if there's anything you want to ask me or suggest me or anything like that. Of course, also feel free to share any of your solutions or tips that you find along the way. Maybe you even dive deeper into some of the topics and find something that's interesting, maybe a blog article. So feel free to share all those things you learn and that you find maybe that even go beyond the topics of this course. And the last thing I want to ask you here in this lecture is to just briefly go into the Q&A and just introduce yourself, where you're from, maybe why you took this course, what you would like to learn from this course, and maybe some of your background experience with Java, with Kotlin, with Android, if you have any experience with those. And I really just want to get to know what kind of students I have here in my course. And it's just more fun for you, I think, and also for me, also for students to know what other students are in this course. So I would really like it if you could introduce yourself just briefly in the Q&A. Of course, if you like your privacy, you can also just move on. But I think it would be nice to just get to know some of my students and to also understand what you're looking for in this course so that I know how I can best also deliver to you. So thanks a lot for watching, and without further ado, let's now move on to the next lecture. Now, before you invest a lot of your time into learning the Kotlin language, it might be interesting to take just a few minutes to learn who's actually using this language and why should you care to also use it. Now, first of all, many people say that Kotlin is a new language, and it's true that Kotlin is a quite modern language, but it has actually been around since the year 2011, or at least they started developing it then, and the first stable release then went out in February 2016. And I myself have been learning the language since the late 2015 or beginning of 2016, so even before the first stable release of version 1.0. And I've actually also taught this course, Kotlin for Beginners, and started, learning the language for that before it was in its stable release. And by now, actually, many companies have already adopted Kotlin for the development process and have also seen that it really does improve their productivity and the quality of their code. And among those companies are names like Uber, you have Pinterest, you have Gradle themselves, you have Evernote, the Spring Framework, you also have Atlassian and Coursera. So there are many companies that are already using them. And for Android specifically, the Android apps for Evernote, for Pinterest also, and for the Trello Android app. So they're also developed in Kotlin, at least partly, or sometimes even they have completely shifted to using Kotlin. So this proves that this language really is ready for production, and many companies are already getting all the benefits from this modern language and can increase their productivity. So really it's time for more people to learn the language and to see if they can also adopt it in their company for their Android apps. And with this, you made a great decision to learn the language and to see or to evaluate the language for yourself, to see what kind of benefits this might prove for your Android app development. And you can then see whether you want to use that instead of Java. There are definitely many benefits to it. So all in all, I think it's a great opportunity to learn Kotlin now. So I think you made a great decision to take this course. There are also more jobs coming out for Android developers using Kotlin and also for Kotlin positions in general. So it's just a very interesting topic to see and to really stay on top of current trends and to really also dive into some of the concepts behind modern programming languages, dive more into functional programming if you're not as familiar with that. So I'm sure you're going to take something away from this course and hope it's going to be a lot of learning for you in this course. So let's move on now and get started with the actual course. Alright, so in this first section we're going to start off by getting our whole development environment set up. I know it's always a bit boring to set up the environment first, but we just have to do it. So of course, if you already have the Java JDK or Android Studio 2 or 3 already installed, you can just skip the corresponding lectures. And if you don't have them installed yet, you can just follow along the lectures. There should be everything explained in detail. Otherwise, just let me know in the Q&A. Now, if you have Android Studio 2 installed and you don't yet have the Kotlin plugin, you're going to have to install that plugin, and there's an article for you with the process. It's very easy, it takes just a minute. And on the other hand, if you're on Android Studio 3, it actually comes pre-installed. So starting with Android Studio 3, Google decided to actually include the Kotlin plugin by default. So you can also see that, well, it's going to be more and more important. You don't have to install anything by yourself anymore. It's just going to be there by default. So I will also be using the early access version of Android Studio 3 in this course, just so when you watch this course, it's probably also already going to be the stable version. So I want this to be a little bit future-proof. So I'm also going to be using Android Studio 3, where Kotlin already comes pre-installed. So with this, let's now dive into the setup to get Java installed, to get Android Studio installed, the very powerful text editor or IDE that we can use for Android app development. And then you're really ready to dive into the actual language and to learn all the ins and outs of the Kotlin programming language. So without further ado, let's now dive into the actual setup. Welcome back. Now, the first thing we need for Android app development is the Java JDK. And we're actually just going to download the latest version. So for me currently, that would be version, 8 first of all. So for Java 8 and update 131. Now for you, this might be another version. So just feel free to download the latest one that you see on this page. Now this is required in order to actually use Java for Android app development. And since Kotlin also runs on the Java virtual machine, the JVM, we're going to need the Java development kit. So you can go to this page here, which is also linked in the resources for this video. You can just click on there and you're going to get to this page. And then you're going to come down here, click on Accept License Agreement, which is required by Oracle. And then you're going to have to download the appropriate version for your operating system. So there's Linux here with 32-bit, Linux for 64-bit. You have Mac OS X, and in my case, we have Windows down here. There's 32-bit and 64-bit. So in my case, I would go ahead and download Windows, Java JDK 8, and for a 64-bit machine. So just click on that and it's going to come up with the download. And of course, you're going to have to wait for it to finish and then just click on it to install. All right, so now once this is finished here, we have this downloaded. And if this doesn't show up directly, you can in Firefox also press Ctrl J in order to show the downloads, or just go into your downloads folder. And then in my case, I'm just going to double click here and execute this file. So now it's going to come up here with the warning, as always, when I try to install something on Windows. I'm going to hit OK to accept that, and then just follow the installation wizard as normally. So I'm going to hit next, next. I'm going to keep the defaults there. All right, and this takes a while, but once this finishes, we can then move on to the next step. All right, so after a while, it's going to come up with this window here to ask you for the destination folder for the installation. And this is the normal one, and I'm just going to go ahead with that. That's also where other versions of the Java JDK are lying on my machine. So I'm going to hit OK, and then it's going to start actually installing the Java JDK. And you can see here that it says that 3 billion devices actually run Java. And of course, Android is one of the major parts of that, because there are just so many Android devices out there and it's become really large. So yeah, that's exactly also what we're going to do in this lecture, on this course, but of course using Kotlin. And maybe at some point in the future, there are actually going to be 3 billion devices running Kotlin. Who knows? Alright, so after that, we can just hit close here. And with that, we have our Java JDK set up. So that's the first step we have to do. And in the next lecture, we're going to take a look at how to install the Android Studio IDE. Alright, now the next step here is to install the awesome Android Studio, which is the IDE, the integrated development environment for Android app development. Now this IDE here is developed and maintained by Google, and it's actually based on IntelliJ, which is developed by JetBrains, just like Kotlin. So this is also one of the reasons why it was easy for Android Studio to add really great support for the Kotlin language as well, because IntelliJ, the IDE that it's based on, of course has the best support for Kotlin since it's made by the same company that created Kotlin itself. And this is a really powerful tool here because it not only lets you write your code very productively if you know how to use it, it also lets you emulate Android devices, for example, in order to run your applications without actually having a physical Android device. But we're going to see all those great features later, so for now let's see how we can actually install and get this Android Studio set up. Now again, you can take a look at the resources for this video in order to find this link that goes to the Android Studio installation page, and you can install Android Studio from here or download. And it's automatically going to show the download link for your operating system. Now for me at the time of recording, this would be version 2.3.3, which is the latest stable version, but for you it may already be Android Studio 3, where Kotlin is actually integrated from the start. If this isn't the case yet, you may also want to go to the preview page here, which is also linked in the resources, in order to get an early version of Android Studio version 3, in which, as I said, Kotlin is baked in from the start, but you can also use version 2.3 if you want, and you can easily install Kotlin there as a plugin as well. But for me, to make this course also a bit more future-proof, I'm going to actually go for the preview version of Android Studio 3. So what I'm going to do here is I'm going to click on the download link, I'm going to say I agree, and download the Android Studio installer. Now it's going to come up here with a zip file that you can then save to your downloads folder, for example, in order to then unzip it and install Android Studio. So I'm now going to skip the actual download, and I'm going to skip to where you actually have finished the download and where we're going to actually start and use Android Studio. Alright, so once the download has finished, you can simply use the archive, unzip it in order to get the actual Android Studio folder here. And once this has finished, we can already start Android Studio, and I'm going to guide you through how to actually set it up once this unzipping here has finished. Alright, so after unzipping, you can go into the Android Studio folder here, and you're going to see we have a bin directory where you have actually the executable to start Android Studio or to start Android Studio for 64 bits. Now what I'm going to do here is I'm going to say pin this to the taskbar so that I don't have to actually go into this folder every time I want to start Android Studio, because instead it's just going to be down here and I can just use or launch it from here. So now we can close this up and start Android Studio. And it's going to take a short while to start up because it's quite a heavy software. And it also does take a bit of resources. So you should have a machine that can actually also handle Android Studio, but it should work fine on most machines. So now it's going to also start downloading some files already. And when you're starting this, the very first time, it's actually going to have another screen in front of this, which if you've never had Android Studio before, you can just go and say, I didn't have Android Studio before, so just go without any previous setup. And then you're going to get to this screen here, which is going to guide you through the process of just getting Android Studio ready to go. So here you can see what you can use Android for. So you're going to just click next, and you're just going to go with the standard installation, and you can do the same thing. So for me, you can see what it's going to download here, so what extra dependencies it needs. Most significantly, there's the Android SDK, the standard development kit that we're going to need in order to actually well, develop any Android apps. So this SDK here contains all the files and all the dependencies for all those Android components that we want to use from our code. And also it's going to download the Android emulator, which is going to allow us to actually run or simulate, or emulate to be precise, an Android device on our machine without actually having a physical Android phone. Another thing to notice here is the Hexam installer, and this is only for Intel-based machines, and it's going to make the Android emulator, so the emulated Android device, run a lot faster. Now, if you're not on an Intel-based machine, this won't work, but what you can do in order to, well, make this more performant is to use a physical device if you do have one. So that's also possible. If you are using an Intel processor, it's gonna just use this emulator accelerator here, this Hexam installer. And if not, you're gonna have to see if, well, the performance of the Android emulator is still okay or not. And if it's not, you do still have the opportunity or the possibility to use a physical device if you have one. So that's just to give you a quick overview of some of the things that are also downloaded now additionally to the Android Studio IDE in order to actually be able to develop any Android apps. So now we can just hit finish here, and it's going to start downloading a lot of stuff. So it's going to, well, really use your internet bandwidth a bit. But once this has downloaded, we can already start actually using this and try to also integrate Kotlin into our first Android app. So let's now have a bit of patience and just try to wait until this has finished. Alright, so now after all the downloads and unzipping and the installations have finished, you're gonna see something like this if you show the details. And you can also see that this Intel Hexam installer has also finished for me because I'm using an Intel processor. And hopefully it's going to work for you too. So now I'm going to click finish, and it's going to come up here with the start screen for Android Studio. So you're now all set up. You have the Java JDK, you have Android Studio with the Android SDK, the Android emulator and everything ready to go. So in the next lecture, we're going to create our first Android Studio project and already integrate Kotlin and start it. So I hope you look forward to that, and I'm going to see you again in the next lecture. Alright, let's dive right in and create our first Android project using Kotlin. So I'm going to go ahead and say start a new Android Studio project, and I'm going to call this one just learning Kotlin. And my company domain here is going to be petersommerhoff.com. So it's already going to automatically change the package name to com.petersommerhoff.learningkotlin. And if you don't have a domain yourself, you can just also use example.com if you don't want to publish anything, and this is just for learning Kotlin, so this is not something you're going to publish. So feel free to just use example.com here or your own domain name if you have one. Now you can already click here include Kotlin support, so let's go ahead and do that, and then click next. And I'm going to go ahead here with the default settings for now, so just targeting phone and tablet and API level 15, which refers to Android version 4.03. So I'm going to hit next again, and I'm going to use the empty activity as a default. And also I'm going to generate the layout file for that screen automatically. Alright, so now you can see there was some things that Android Studio had to install for this, and it's going to do that automatically. So no worries about that. And I'm going to go ahead and say finish. And you can see it also sets up the project info for Gradle. And Gradle is the dependency manager and also the build tool for Android. We're going to talk about that in a bit more detail later on in the course, but for now you already need to know that this is also the place where you can say that you want to use Kotlin in your Android app. Now, since we already said include Kotlin support, it should do that automatically. But we're going to see what it actually changes in the Gradle file so that you can also do this yourself if you ever have to. Alright, you might get a message here from your firewall that you want to allow Java to make changes or to have access. So I'm going to allow access for Java here. Alright, and now once this finishes, it's by default going to come up with a tip of the day. You can use those tips if you've never used IntelliJ or Android Studio before. They might be quite helpful, and you might actually want to go ahead and look through some of these tips and maybe remember one or two every day until you really know many of the really useful and powerful features and keyboard shortcuts that you can use. But for now, I'm going to say I don't want to show those anymore. I already have some experience with IntelliJ and Android Studio, and I'm going to close this. So let's put this into full screen here and also remove some of the, well, overhead that we have in this user interface. So if you've never used this before, this can be quite overwhelming. So first thing I'm going to do is I'm going to hide all these items on the borders. So you can click here in the bottom left corner to toggle those, and I'm going to actually remove them for now. Next, you can see on the left side here, you have your project structure, and actually there's a problem at the moment because Android 25 or the SDK doesn't seem to be installed, or you can't find it. But Android Studio is always going to come up with a suggestion as well. So here it's going to say install missing platforms and then try to sync the project again. So I'm going to hit OK or hit on that message in order to let it do what it suggests. And I'm going to accept the license agreement for SDK 25. And then it's going to go ahead and download and install all the required dependencies that it needs for this project. Alright, so after downloading and installing, can hit finish again, and it's going to try to sync the project again, which basically means it tries to see if it can find all the dependencies that it needs in order to build this project and then also run it. And you can see up here in the status bar what IntelliJ or Gradle is currently doing, and sometimes also going to come up with suggestions on top here if there are any problems. So for now, let's wait to see if the project syncing now works for Gradle. So basically, if we have all the dependencies we need. Alright, so this looks good. The message is now gone. And you can see down here that it says that it's currently running the build, which means it's compiling all the files and trying to create an APK file that can then be run on an Android device. Alright, so that seems to be also finished by now. So now let's take a look at what we actually have here. You can see we have our main activity, but you can also see that it's already Kotlin code. So you can see it's main activity.kt and not .java. And you can also see that, well, the syntax is a bit different, right? And we're going to talk about all this in detail, of course, in the upcoming sections. We're going to learn about all the Kotlin basics, about functional programming in Kotlin, and object-oriented concepts in Kotlin, and you're really going to be able to apply all those to your apps in Android, and it can really make your code not just much more productive, but also much more robust and safe, and also much more concise, as you're going to see in many points along the course. Alright, so this is now basically our first Android app with Kotlin already, even though it's just the empty template. So let's actually try to run this one and see how it looks in the emulated device. Alright, so you can see when you click on run at the top here, it's going to say there are no devices yet because we haven't set up any emulated devices yet. The thing is, you can actually emulate a lot of Android devices, and you know there are many different ones, and you can see here a list of devices you could possibly, well, emulate with this. So there are phones, there are tablets, there's also Android Wear, and even TVs. So for now, I'm going to go ahead with a phone, and more specifically, I'm going to use a Nexus 5X. This is one of the Google phones, so I'm going to select that, hit next, and then it's going to ask us what kind of Android version basically we want to have on that emulated device. So I'm just going to go here for the recommended, the latest one, so Android O. And I'm going to, well, let's say install that on this emulated device. So install that. And you can see, yes, you do need some time to really get everything set up at the start. But once you have everything set up, now the next time we want to create an app, of course, you don't have to create or set up the emulated device anymore. You won't have to download this SDK anymore. But only if you ever want to have, let's say, or test on another device, of course, you're going to have to set that up again. But the work that we're doing here is something we don't have to do every time. So don't worry too much about all the installations we have to do now. Once you have this all set up, it's going to be a lot easier next time. You can just use this device for all the apps you want to use or create in the future. And if you think about it, it's also actually quite easy here to just be able to install all this right from Android Studio. So it's, I think, really made in a very comfortable way in order to get all this done. So let's now have some patience again and wait until all the downloads and installations have finished. Alright, so again, once this has finished, just click Finish and we have this installed. So now we can select this Android O here, hit Next. You can give this a name, but the default name is actually very useful. So it's a Nexus 5X running API 26, so Android O. And that's basically all you have to do. So hit Finish. And then it's going to come up here and we can just select this device in order to run our app and view our app on this virtual device. So hit OK. And then it's going to start up the Android device on your machine, on your PC. So you can really test this on many devices if you want, if you just install all of them. Now, of course, it takes a while for this emulator to start. Just like if you have an Android device, it also takes a while for Android to boot up. So just give this a minute to really start Android here. And then we can actually see our app and it's actually going to start automatically. Especially when starting this for the first time, it takes a bit longer. But the next times you want to start this, it's also not going to take quite as long as the first time. So you can see now how Android is booting up here. You can also see it's a quite new version of Android. I have to admit I've actually never seen this boot up screen yet because I don't have an Android O device. So it's interesting to see also. Alright, so now you can see Android has booted up and is ready to go. And you can also see that our app will be started automatically. So that's how it works when you click on Run. So you can see we have our app with the title learning Kotlin, and it has a text field showing Hello World. So yeah, that's already our first app that uses Kotlin. Of course, we haven't actually done anything ourselves yet, but you can see how strong the support is here for Kotlin in Android Studio. Especially in Android Studio 3, you don't actually have to install the Kotlin plugin separately, but instead you can simply use it as you go. You can just click include Kotlin support. Otherwise, you can also use Kotlin or include Kotlin later on. And actually, when you go and use Kotlin code or create a Kotlin file in your project, it's automatically come up with a suggestion to enable Kotlin support. And also, if you have an existing Java project, you can just go to any Java file, go to code, and then convert Java file to Kotlin file to see how the Java to Kotlin converter will then convert this file and how this would look in Kotlin. So this is an interesting way to see how your Java files or your Java code would translate to Kotlin. Of course, it's not perfect, it's just an automated generator, but it's still very useful to also get started with the language and see how concepts map. Alright, so that's all for this lecture. It looks like we're good to go. We have Android SDK, we have a virtual device that we can use in order to run our apps on. In this case, we chose a Nexus 5X running Android O. So now we're actually ready to go. So first thing we're going to do in this course is in the next couple sections, we're going to look in a lot of detail at Kotlin first and then apply those concepts to Android apps. And this way you're going to see first how powerful Kotlin is and also learn how to use it in general, not just on Android. You can also use it in basically any other place, for example, anywhere Java is used. But then of course we're going to focus on Android and go into the details of how Kotlin can be used to enhance your development workflow when creating Android apps. So that's all for this lecture and congratulations on your first Android app using Kotlin. Alright, congratulations! You now have all the setup ready that you need for developing Android apps in Kotlin. You have Java installed, you have Android Studio installed with the Kotlin plugin, either pre-installed in Android Studio 3 or you've installed it yourself on Android Studio 2. So you now have all the tools you need to really dive into Kotlin. So that's exactly what we're going to start doing in the next section. So I hope you're excited about that, and I'm going to see you again in the next lecture. Alright, so in this section we're finally going to dive into Kotlin by first of all, of course, starting with the basics like conditionals, loops, variables, and so on. For those of you who've taken my Kotlin for Beginners course, you might want to skip some of the lectures, but it's also a great refresher, and it's also introduced in a slightly faster way because this course here is not for beginners. So it's really interesting for you maybe also to see whether you can follow along these courses. And for those of you with just Android or Java experience, this is really going to be interesting now. So you're really going to dive into the new language that you haven't heard of before. And we're going to compare this also in many instances to how it works in Java, where the differences are, where the similarities are. So it's going to be a lot of learning for you. And of course, we're going to start off with just the basics. Please do remember that this is not a beginner course. So if you don't have any programming experience at all, you might want to better start off with a beginner course like my Kotlin for Beginners or a Java beginner course or some Android beginner course. But if you do have some programming experience, you're perfectly fine. So we can now move on into the actual basics of the Kotlin language. So this is going to be really interesting, and I hope you're excited for this. So let's dive right in. Alright, so let's start off with variables and data types in Kotlin. Now I'm still in the same project here learning Kotlin, but I removed some of the distracting elements of the UI because in the next few lectures we're actually going to spend our time in the Kotlin REPL. Now REPL refers to read, evaluate, print loop. So it's like a console that allows you to write expressions in Kotlin or commands and then just run them one by one to see what the result is. So to do that, we're going to go to Tools, Kotlin, and then to the Kotlin REPL. So this is where we're going to spend our time in the next few lectures. So get yourself comfortable, and we're going to choose context module, just the whole project. Doesn't really matter in our case because we're only interested in Kotlin itself. So now I'm going to increase the size of this because this is really what we want to focus on now. And let me also increase the font size here in this screen. I'm not sure if there's a better way to do this in this console. Well, let me just go ahead and do it like this so that you can all see what I'm typing. So let's talk now about variables and data types in Kotlin. And remember that every line of code that you write in here, you could also write in an actual Kotlin file, like for example inside a function in the main activity. So it's still the same kind of code, but this just allows us to run each line by itself and just see what it does. Now, first of all, there are two basic ways to create a variable in Kotlin. The first one is to use the var keyword and then just say, for example, var age equals 24. And as it mentioned before, so when there's nothing here, Control plus Enter to execute. So when we have this, I can press Control Enter and it's going to create this variable. So basically it's going to execute this line of code. So in this case, it's going to create the variable, and I can verify that by just typing in age here. And it's also going to actually suggest that because now this variable exists. And now pressing Control Enter again will actually evaluate that expression. So it's going to come back with 24 here. So if the line of code that we use has a return type or a value, in other words, if it's an expression, then it's going to print out the value of the expression. But if it's just a statement like here, which doesn't have a value, it's not going to print anything. Now there are several things to notice here already. First of all, we didn't have to specify the type of the variable age explicitly, even though we could. And also there's no semicolon here. And this is not just in the Kotlin REPL, but we just don't need any semicolon in Kotlin, as you might have seen from the main activity code. But now let's go back to the type here. It looks a bit like Python code or JavaScript code, but it's very different because it's still strictly typed. Kotlin is a strictly typed language, even though you can write code like that, which is allowed because Kotlin can actually infer the type. If you write age is 24, then Kotlin will automatically infer that the variable age here should have a type of int, and it should be assigned to 24. So that's completely equivalent to the line above. But if you want to give an explicit type, you can do it like this, by using it as a suffix to the variable name, then writing a colon, and then the type of the variable. Now here you can also see that in contrast to Java, this is an object and not a primitive type. So in Kotlin there are only objects, so this also goes for doubles, booleans, and so on. But before we go into all the different data types, let's actually first look at the second way that we can create variables in Kotlin. And it's actually also the more important way, to be honest, because the second way is to use val and then say, for example, name equals Peter. And this way we now have created an immutable variable. So in contrast to age, where I can say age is suddenly 25, let's say, because someone had a birthday, I cannot do that with the name. So I cannot say name equals, let's say, Peter S, because name, and it's already going to mark this in red here, is a val. So it's an immutable variable, and I can make this fixed to make the variable mutable, but I don't want to do that. Instead, I'm going to try to do this, and it's going to say illegal access error, because this with val cannot be overwritten. This is the exact same thing as in Java when you add the final modifier to a variable. And in Kotlin, you should always prefer val over var when it's possible. That's one of the main concepts in Kotlin, and we're actually going to talk about that in more detail later on. Immutability is a core concept in Kotlin, so we're going to discuss that in more detail in the next lecture. But for now, let's take a look at all the data types. So we can also say, for example, val is developer, and we could explicitly say that this is of type boolean equals true, and that's going to create a boolean variable. We also have the type double for double values, float for float values. They're all mapped to Java in the exact same way. You also have char, and you can also see every time that this starts with an uppercase letter, so it's always a class, and you're also always creating an object of it when you create a variable. So this is one of the differences from Java. And similarly, you have short and long. And what's left, there's also byte. But basically every type that you have in Java, you're just going to have that in Kotlin as well, but you're going to have to write an uppercase letter at the beginning. So what you should take away from this lecture is to prefer val over var. So val is greater than var, which of course not a valid expression here, but you should use val whenever possible, and maybe even redesign your code if you can't make a variable a value or immutable, and only use var if it's really necessary or just given by your use case or domain. And also, just like in Java, you should try to avoid using float and instead use double because of machine precision and the trouble you can run into with floats not being exact enough to really compare them securely. Next thing to take away is that you can make use of Kotlin's type inference so that you don't have to specify the type of a variable explicitly. So for example, title equals Kotlin for beginners. And this is just the exact same thing as writing val title of type string equals some string. So in many cases, this is clear from the context. So Kotlin can easily infer the type, and anyone reading your code is also going to be sure what the type of the variable is going to be. Like here, for example, of course, title is going to be a string. And here, of course, age is going to be an integer. And remember that it's not like JavaScript or Python, but once you have this line, age has the fixed type of integer, and you can only assign integers to it. So type safety in Kotlin is a given, just like in Java, maybe even more in Kotlin. So there's no need to worry about that, even though you can write code like this, which might look to a beginner as if there's no type safety or no static typing in Kotlin. Alright, so those are the main takeaways for variables in Kotlin and also what data types are available. So let's move on now to the next lecture to discuss the concept of immutability in more detail. Alright, now in this lecture we're going to take a look at one of the major differences in Kotlin when compared to Java. Now more specifically, we're going to talk about nullable types and explicit nullable types. So in Kotlin, by default, every type is not nullable, which means you cannot assign null to it. So let's say we want to create a variable, or let's say a value string, and we want this to be of type string. Then in Java, you could just assign null to it, which would be fine and would actually be valid for the type string. But you can already see here that we have a red mark, and if I try to run this line, so it's going to have these squiggly red lines here, and if I hover over the mark here, over the red mark, it says that null cannot be a value of non-null type string. So this means whenever you have a variable of type string, you can be sure that you never have a null in there. So as long as you're working with normal data types like this, you also can never have a null pointer exception unless you're interfacing with Java code, which can of course throw null pointer exceptions. So now of course the question is, what if you do want to use null in your code because, well, let's say for some reason you can't avoid it? Well, what you can do then is you can say val string, and this should be of type string, but this time nullable. And to do this, you put a question mark behind the data type that you want to use, and then you can also assign null to it. So string question mark is basically the data type, the nullable string data type, which can be any string or null. Now notice that this holds for every data type in Kotlin. So remember that even integers and doubles are also objects in Kotlin. So you can assign null to this one, but if you do put a question mark behind the int data type, you can assign null to it. Now, of course, the problem with having nulls in your code is that maybe at some point in your code where you're not even sure anymore that an object is null, you try to access a property or a method on that object. So let's say you want to have the length of the string, but that's not going to work because there's actually no string stored in that object. So you cannot call or you cannot get the length of the string. So here in this case, Kotlin is not actually going to give you a null pointer exception, but what it's going to do is the compiler is already going to see that this is invalid. So already at compile time, which is very important, Kotlin is going to tell you that this is not valid because you have a nullable type here. So it's unsafe to call any method or property on this object. Now there are two things you can do. So to do it the Java way, which is the bad way in this case, is to put 2 exclamation marks here and then just call length or whatever else you want to have, and that's going to give you a Kotlin null pointer exception. Now what string exclamation mark does is it tells the compiler that you're sure that the string object is not going to be null, and it's your fault if it is indeed null and you are just wrong at this point. And notice that the double exclamation mark here basically looks like you're screaming at the compiler, and this is intentional because you shouldn't use this unless you're really sure about this or it's really necessary, but it's normally not. So let's look at the better way to do this, which is the so-called safe call operator. And this is, by the way, the unsafe call operator. So to safely call any method or property on this object here, what we're going to do is we're going to put a question mark here and then access, well, for example, the length. Now in this case, when the object here is null, this is just going to return null. But in the other case where, let's say, string is of type string nullable, but it is indeed not null, but contains some kind of string, so let's say Peter, then when you call safely the length here using the question mark, then it's just going to return the length of the string. So basically, this is like an if then else. So if the object here is null, then any call you do here is just going to return null. But if the object is actually not null and has a valid value, then it's just going to execute the method or get the value of the property that you specify. Now, I think this is a great feature in Kotlin because you have null safety at compile time already, which is very different from having the optional or something like that in Java, where you can still at runtime run into the problem of not having an object there. But here, as you saw before, if you have nullable type and you try to just call a method on it, it's already not going to compile. So you have to kind of think about whether you want to use a safe call or maybe even unsafe call. And there are many other things in which, or many other ways in which Kotlin makes it much easier to work with such nullable types. One of which I'm going to show you right now, and others of which we're going to see later on. So in Kotlin, there's the so-called Elvis operator. And this actually looks like this, which is why it's called Elvis operator, because if you, tilt your head to the left, it looks a bit like an Elvis with the special haircut. And the way you're going to use this is you're going to say, for example, val string length equals, and then you want to have the length of the string. So string.length using the safe call operator. And if this is null, you can also easily define now a default value. In this case, let's say if the string is null, we want to store 0 as the length of the string. Or you could also store -1 in order to say that this string was actually not even an empty string, and just to differentiate this. And using the Elvis operator here is basically a shortcut for checking whether the argument here at the beginning is null, and if it is null, assigning the value at the back here and just having this conditional code. So it's a very concise way to do this. So whenever you have a null here, then using the Elvis operator, you can define a default value you want to use in case you have null in the front. So in this case, we have by now actually defined string. So string length is now going to be 5. But if I go back to assigning the string here, like at the top, so as null, and then do this again. So I'm going to set string length again to this Elvis expression. Then in this case, string length is then just going to be -1, which is the default value we wanted to have if the string is null. So this way also we accomplish that even though string can be null here, string length is always an integer and not a nullable integer. So we're going to get rid of null at this point in our code, which is of course always a good thing to have. So all in all, in theory, you could use Kotlin without any nulls at all, without any null pointer exceptions at all as well. But of course, in many cases, you're going to be interoperating with Java code. And in those cases, you always have to specify at which points you want to assume a nullable value and at which points you don't want to assume a nullable value. So for example, when you call a method that's defined in Java, you can define whether the return value should be nullable or not. And if you're wrong, you're going to have trouble, of course, if you say it's not nullable, but then a null is returned. So this is one of the things you have to be aware of when interoperating with Java. And we're going to talk about that later in this course as well. But for now, the main takeaways are that every type in Kotlin is not nullable by default. You can add a question mark after the type to specify that it should be nullable. And if you have a nullable type, you should use the safe call operator using the question mark, and you should avoid the unsafe call operator using the 2 exclamation marks. And you can use the Elvis operator to work with nullable values more effectively and to specify default values, for example. Alright, so that was one of the first really different aspects when looking at Kotlin when compared to Java. And I hope you found this helpful. If you have any questions about this, of course, let me know in the Q&A. And otherwise, I'm going to see you again in the next lecture. Alright, so in this lecture, we're going to take a look at conditionals in Kotlin. So we're going to talk about the if expression as well as the when expression. And we're going to see also that there really are expressions in Kotlin and not statements. So let's first of all go ahead and look at the if expression, which works pretty much the same way as in Java, except that it's an expression and not a statement. So let's go ahead and create an integer variable here and set this to 17. And then you can go ahead and check, for example, if I is less than 15, you want to, let's say, print line I is pretty small. And let's actually go ahead and make this greater than so that we actually get the message as well. And you can see that when we run this, it's going to come back and print out I is pretty small. I'm gonna just use the arrow up key in order to go back to the last command. And what you can also do, of course, just like in Java, is to have an else block and say, well, in this case, else would be if I is greater or equal to 15, you're gonna say, let's say it's pretty large. And of course, in this case, now that I've actually changed the condition to less than 15 in the if block, it's going to print out it's pretty large. And of course, just like in any other language, you can also have an arbitrary amount of else if blocks. Let's say else if I is greater or equal 15 and I is less than or equal to 25. I'm going to say it's okay. And you can have an else block at the end, just like in Java again, and say print line, it's pretty large. So you can also see that the AND operator here to combine two conditional expressions looks the same way as in Java. And you also have the OR operator here, also with the same syntax. And you can also use the exclamation mark to negate an expression. So let's go ahead and press Ctrl Enter to run this, and it's gonna say it's okay because 17 is somewhere between 15 and 25. Alright, so far everything exactly as in Java, but as I already mentioned, the if blocks and also the when blocks that we're gonna look at are actually expressions. So what you can do is you can go ahead and say val x equals and set this to the if block because, well, it's an expression, so you can assign it to a variable. Now, in this case, if we run this, this doesn't actually have a return value. So it's like assigning a void value to x. So if I go ahead and just put in x, Control Enter to get the value of it, it's not going to come back with anything because there's no actual return value for this if block. Now, in order to define a return value, you can add a value to the end of, or to the last line of each block in here. So the last line in each block, so inside the if block here, inside the else if block, and inside the else block, will then define the return value. So let's say in this case, we want x to be set to small. Here we want x to be set to medium. And here we want x to be set to large. Now in this case, if I go ahead and run this, and then try to print out x, it's going to come back with medium in this case. Well, there's not actually anything coming back. I think I went a bit too fast there for the Kotlin REPL. So let's actually go ahead and run this block here again and wait for the print line statement to finish. Alright, so it looks like the Kotlin REPL crashed on me there. Unfortunately, it seems like the preview version of Android Studio isn't too stable. But I recreated the variable I with the value of 17. And now let's go ahead and run this same block of code again to set the variable x using an if expression. Now you can see first that it's going to print out it's okay, which comes from the actual print line statement in here. And now if I try to get the value of x, you can see that it has been set to medium. So this was the return type in this case of this whole block, which means that x was set to this value. You can put anything you want into this last line to define the return value. So it doesn't have to be a string. You can put any return value you like in each of the last lines in each block. Now, one question you might have is what kind of return value does the if expression have if there's no return value in the last line? So for example, before when we had print line, what's actually the return value of that? And the answer is that it's a Kotlin unit type. So you could basically define a value of this and say value is unit. But this is no use because, well, unit is basically what in other languages is referred to by void. So it's like no return type at all, but it's just interesting to know that if you have a function also later on that doesn't define a return type, then the return type is implicitly unit, which is basically void. So you can of course feel free to ignore this possibility to have a return type for if statements and use them just like in Java. But remember that you do have this possibility, and it's actually quite useful in order to avoid that x here has to be initialized with null before the if statement, just in order to then set it inside, which is how you often have to do it in Java. So this is also, again, another way to avoid nulls in Kotlin by just returning them directly from if expression here. Because this way you don't have to initialize the value x here, but instead you can just directly set it to the return value of the if statement or if expression. Now, one last thing I want to mention here for ifs is that the Kotlin compiler is quite clever in this regard when using nullable values. So let's say we have again a string, which can be a nullable string. And I'm going to set this to, let's say, Kotlin in this case. So when you have this, remember you can't just call string.length, for example, because string could be null. But if you go ahead and say if string is not null, and then go into the if block here, you can actually do things like print line string.length. And this in this case is going to come back with 6 and without any compiler errors, because inside the if block here, what Kotlin or the Kotlin compiler is going to do is it's going to automatically cast the string here to a non-nullable string type. So you can use this here without the save or the unsafe call operator, because Kotlin already knows that string can never be null inside here. So this is one of the ways that Kotlin handles nullable types really intelligently and really helps you to avoid any unnecessary, complexity in your code. So generally, in many cases where you have an object that is nullable by its declaration, but cannot be null at a certain point in the code, the Kotlin compiler will already notice this and then allow you to work with the object as a non-nullable type. And when we talk about object orientation later on, we're also going to see how the Kotlin compiler handles many more things intelligently like this for also types of objects. But for now, this is all about the if expression in Kotlin. So let's now go ahead and move on to the when expression. Now that you know how to use if expressions in Kotlin, the only logical thing to look at next are when expressions. And of course, they're the equivalent of the switch statement in Java and other languages, but they're more powerful. So let's take a closer look at how to use them in Kotlin. So let's first go ahead and create a new variable here again. In this case, of course, immutable, because we don't need it to be mutable. And I'm just going to say the price is, let's say, 29. So I'm just going for an integer here, first of all, just for simplicity and just to show you how the when construct actually works. So now we can go ahead and say when price in parentheses and then open up a block using curly braces. So far pretty much the same as using switch here in Java. But now the syntax is very different. There's no case keyword or something like that. You just put the expression that you want to check for against the price variable on the left hand side. So let's say, for example, when price is 0, then we want to print line for free today. So you just use this arrow notation here to define the right hand side, or in other words, what's supposed to happen if the price variable is 0. And similarly, you could go and check for specific values like, let's say, 19, and that would be on sale, for example. But a more interesting and also more useful way to use this in this case is to check for ranges. So let's say if the price is somewhere in 1 to 19, we want to say it's on sale. And that's exactly how you write this in Kotlin. So you can just use in and then simply create a range from 1 to 19 using the ... notation here. So this means now that this branch will be executed for any value between 1 and 19, both included. And similarly, you could go ahead and say when it's in somewhere between 20 to 29, you're going to say, normal price. And then next, what you can also do is you can define a default case, just like in Java, but you use the else keyword for this. So you can say else, print line, overpriced in this case. And we can also go ahead and run this for now to just check out what's going to happen. In this case, when the price is set to 29, it's going to come back and say normal price. But there are also some other things you can do that I want to show you. So one thing is you can also have a function call on the left-hand side. So one very simple function call would be just an addition, which is basically a function call on the plus operator. So you could say if it's 10 plus 20, you can say, well, slightly overpriced maybe, because it's going to be 30. But you could also call any custom function here on the left-hand side, as long as the return value matches the data type of the variable you're working with. And then also you can check whether a variable is not in a range by simply using an exclamation mark like you would do in logical expressions. So when price is not in 1 to 19, well, let's go ahead and just write not on sale. And if I go ahead and run this now, then that's going to be the first block in this when expression or when statement that's going to be executed, or that's going to match, because price is set to 29. So it's not in 1 to 19, and it's going to print not on sale. And notice very importantly here that it's only going to print this, even though it would also match the left-hand side here. So what's important to notice is that in contrast to Java, we don't need to use a break statement explicitly, because each of those right-hand sides or branches here breaks automatically at the end. So you're only ever going to run into one of these blocks and not multiple of them, even if multiple left-hand sides here would match the variable that you're checking against. And that's because in other programming languages like Java, forgetting to use a break at the end of every branch is actually a common source of defects in your code. So this is a design decision here for safety in your code. And I think it's a good choice because there are really not many cases where you really want to have this behavior to really skip into the next branches as well in a when statement. Alright, so moving on now to another syntax where you can just use the when expression or when statement without actually having any variable in there. And in this case, all the left-hand sides before the arrow must be a Boolean expression. So what we could do now is we could say if price is less than or equal to 19, we could again go ahead and say sale. Then next, if the price is less than or equal to 29, and notice that it's only ever going to come into here if the price is greater or equal to 20, then we're going to say, well, normal price, and then we can use else. We're going to say print line overpriced. So in this case now we have Boolean expressions on every left-hand side, and of course we can still use else for the default case, and then it's going to come back and print normal price. Now later when we talk about object orientation, we can also check for types on the left-hand side using something like instance of in Java, but that's something we can take a look at once we actually have object orientation. For now, there's one more important thing again to know about the when expressions in Kotlin, which is just that it's an expression again. So same as with the if expression, we can have a return value for the when statement, or when expression I should say. So we could go ahead and say val, or let me actually go back with arrow up to our expression before. And I'm going to go ahead and say val x is equal to this when expression. And instead of printing out the strings, I'm actually going to make them the return type. So now this way, they're going to define what the value of x should be, because now each of the branches here returns a string, meaning that the whole when expression here is also going to be of type string, and that's going to be assigned to x. So let's go ahead and try to run this, and then let's go ahead and print out x. And you can see, well, in this case, it should come back with normal price, but I suppose that the IDE crashed on me again because it also showed IDE error occurred. So let me quickly go ahead and just copy this part of the code, then restart a new Kotlin REPL. Alright, so unfortunately the Kotlin REPL again crashed on me here in the Android Studio preview, but I just set this up again. So what I did was copy the code here that assigns x to the when expression, and I actually set the price to 39 in this case, just to get a different result for a change. So let's go ahead and run this block here again to assign x to the value of the when expression. And then let's go ahead and just say x to get the value of it, and it's going to come back with overpriced. So again, this is often helpful to avoid having to set x to null first in order to then initialize it in a if then else block, or in a when block like this, just to find out what kind of value you want to set it to. And this when expression here without actually having a variable in parentheses is just a good way to avoid having long chains of if and else if chains, and instead using the when expression can make it more concise, but it's just a matter of taste. So you're gonna have to see whether you prefer to have this when expression or just if, else if, else if, else if, and so on. Alright, so that's it about the when expression in Kotlin. So again, notice it's an expression, not just a statement as in Java. You can check for specific values or ranges, or also check if it's not in a range. You can have function calls on the left-hand side, and you use the else keyword for the default cases. And in contrast to Java, you can also have a when expression here without actually having a variable in parentheses, and then all of the left-hand sides must be Boolean expressions. Alright, thanks for watching, and I'll see you again in the next lecture. When learning a new programming language, one of the crucial points is always to learn about their standard library and how to use it. Now, one of the most important parts of that is always the collections API, like in Java. And the great thing is, of course, when you come from Java and you want to learn Kotlin, there's not much of a transition cost because, well, also the collections API is based on the Java collections API, and generally you can use all the libraries and classes from Java in Kotlin. So coming from a Java background, it's really easy to get started. And in this lecture, we're going to take a look at exactly the collections API so that we have a good understanding of also the differences in Kotlin and what Kotlin actually extends when compared to the Java collections. Let's go ahead and dive in. So as I mentioned, the Kotlin collections API builds upon the Java collections, and it adds many useful library functions. And another very important benefit is that in Kotlin, there is a clear distinction between mutable collections and immutable collections, which of course is again aligned with the principle of preferring immutability in Kotlin. So for instance, in Kotlin, there's a type list, which is generic, so you can have a list of int, for example. And this type here is only there to represent immutable lists. And the same also goes for a set or map and so on. And if you do actually want to have a mutable list, there's another interface, mutable list, which adds all the methods which can actually, well, mutate a list, like adding an element, removing an element, and so on. And in contrast, the list interface only provides methods like get an element at index I and things like those, which cannot change the list. So the interface list of t only has the read-only attributes, and the interface mutable list of t has all the methods that can actually mutate a list. But now let's take a look at how to actually use them and create arrays, lists, sets, maps, and so on in Kotlin. And the great thing is that in Kotlin there are many helper functions to let you create any type of collection very easily. So let's, for example, go ahead and create an array and just set that equal to array of, which is the helper function to create an array. And you can see it takes a var arg of elements that you want to have inside the array. So let's just go ahead and say 2, 3, 5, 7, 11, and 13. And if you run this, you're going to have the array variable here containing exactly that array of integers. So internally it's going to be an array of int. And you can see that arrays, just like in Java, don't have a useful toString method defined. So they're just going to give you the address of the array in the memory. Now, if you do want to print an array, you can still use join toString. And let's try to use that without any parameters or arguments, to just use the default ones. And you can see that's going to have a nicer result in the command line. Alright, so next, when you want to have an array like this, you can actually also use specific helper functions, like in this case int array of, which will then internally use a primitive int type, just like in Java. So on the JVM, they're going to map this to Java's primitive int type, so you can also use int array of to use that. And there are also helper functions like double array of and so on. So very easy to create arrays. And the same also goes for lists. So there's list of, and you can simply create a list here let's say the Fibonacci sequence or the beginning of the Fibonacci sequence, just create a list like this. And as you may already assume, this is actually going to create an immutable list. So this is again, of course, in line with preferring immutability in Kotlin. If you do want to have a mutable list, so let's say mutable list, you can use the helper function mutable list of, and that's going to create a mutable list that you can still modify. So you could go ahead and say mutable list at index 0 should be 99. And then if I go ahead and print this, you can see that the first element in the list is now 99 instead of 1. And of course, just to demonstrate, you can't do that with a list. So if I want to set this to 99, you can see we have an error, which basically states that you cannot set any new element on this immutable list. And you can use this the exact same way as lists. So again, there's a helper function set of, and if I put in multiples there, then as you know, with a set, you cannot have multiple instances of the same element in the set. So if I do this with 2 ones in the set of arguments, then the set here is actually going to come back with only 1, 2, 3. So the duplicates have all been removed. And of course, you can again say mutable and use the mutable set of helper function in order to create such a set where you can still add elements later on. So this is then also going to use the interface mutable set, which also lets you add new elements, for example, or remove elements from the set. But let's first go ahead and just print this out, and that's going to come back with 1, 2, 3. But in contrast to the set above, you could now use functions like add or remove in order to change the set later on. Alright, so lastly, let's take a look at maps in Kotlin. So you can go ahead and say map is equal to map of, and then the map of function actually takes a var arg of pairs. So you could go ahead here and say pair of 1 to Kotlin, pair of 2 to Android, or whatever type you want. You don't have to have an integer as the key. You don't have to have strings as the values. You can use any types you want. In this case, of course, this variable here would be of type map of int to string, but Kotlin can infer that for us, so we don't need to do that here. So let's just go ahead for now and run this line to create this map with 2 entries in it, and then just try to print out the map. And this should normally come back with an output where it says 1 equals Kotlin and 2 equals Android. But the preview version here, or the REPL in the preview version, has some issues with printing out the results of the statements. So let's just go on and move on for now to see how to also create mutable maps, and also a nice syntax in Kotlin to create maps like this. So first of all, to create a mutable map, you can maybe already guess this, you can use the helper function mutable map of, and then just use the exact same kind of arguments. But to create a pair like that, you can actually use the to function in Kotlin, which is a very nice feature for this. So to make clear what's happening here, let's actually call it like this. To is just a helper function, just like mutable map of, that's available in your namespace or in your scope or automatically. So to is just a helper function that's available just like mutable map of or array of. And you could say here that you want to map 1 to Kotlin and 2 to Android. But what's great about this function here is that it's actually declared as an infix function, which we're going to take a look at later on in the course. So what you can actually do is you can use to as an infix function, so you can put it between the 2 arguments, saying mutable map of 1 to Kotlin and 2 to Android, and that's going to work just fine. And it's the same thing as calling the to function on the arguments 2 and Android. But it's just a very nice and readable and expressive syntax using the infix function notation. And of course, you're also going to learn later on how you can create your own infix functions. But for now, it's just a nice tool to create maps in a more readable way. One last thing I want to mention about collections in general is you can easily create copies using the toList function. So let's say we want to create a list that has the same elements as our set variable. Then we can just say list is set.toList, But be aware that this only creates a shallow copy. So if you have objects in there, those objects will not be copied recursively. But for collections of integers, doubles, and so on, this is no problem, and you can easily create a copy using toList. Alright, so that's all about arrays, lists, sets, and maps in Kotlin. And what's important to take away here is that we have the clear distinction between mutable and immutable collections, and you should always prefer immutable collections unless you really do need to change the collection later on. And also remember that there are those very useful helper functions you can use to create any kind of collection in Kotlin. That's all for this lecture, so I look forward to seeing you again in the next one. So now that we know about conditionals and also collections, it's now time to talk about loops in Kotlin. Now, especially when working with collections, oftentimes you want to iterate over that collection in order to do something with each of the items, for instance. So in this lecture, we're going to start off by going into the for loop and see how we can use that in Kotlin. Now, the first most simple example might be a loop that's just going to be executed 10 times. So we could go ahead and say for I in 1 to 10. And then we could go ahead and, for instance, print out I. And maybe add a space to this. So we're going to print out I plus a space so that we can actually differentiate each of the outputs. And now when I press Control Enter, it's going to come back with the numbers 1, 2, 3, 4, 5, and so on. It's going to print out all the numbers from 1 to 10. So there are several things to notice here. First of all, this is more like a for in loop in Java, where you have something like for, let's say, int I in, for instance, some list of ints. This is also a syntax that can be used in Java, but most of the time in Java, you might also use a syntax where you have actually 3 parts to the for loop, where you define a variable, then define some kind of condition, and then increase the variable here, for instance. And this kind of syntax does not exist in Kotlin. The only thing, so to speak, you can do in Kotlin is to iterate any objects that provide an iterator in Kotlin. So this might be, for instance, a range, and a range can be very easily created using this syntax with the 2 dots. So this here is the integer range from 1 to 10. Similarly, you could also, for instance, iterate over a string. So for C in Kotlin, you could print out the character C. So this will now go through the string character by character and print out each of those. So you can see we have Kotlin, which in other words means that the string provides an iterator, which allows you to go through the string character by character. Now another prime example is when we use some kind of collection. So let's say we have languages, which is a list of Kotlin, Java, and Swift. Then you can go ahead and say for lang in languages, and let's say print line lang is great. And this way you will iterate through all the items in the list, and it's going to print out Kotlin is great, Java is great, and Swift is great. And apparently in the Kotlin REPL, it doesn't actually print a new line when you use print line. So it's just going to still print out everything in just this one line. Now, one more thing I want to mention here is that you can also use another function that's not directly related to the for loop, but you might use this in a for loop most of the time, which is the down to function you can use as an infix. So you could say for I in 10 down to 1. And this is just an infix function, so it's the same as calling a function down to on the 2 parameters 10 and 1. But it's more readable to put this in between. So you can say for I in 10 down to 1, print I. And I think I forgot to actually make this an uppercase T. So let's try to do it this way. And now you can see we have all the numbers from 10 down to 1. Alright, so I think this is fairly easy to use if you already have some experience with Java and other languages. Just remember that you don't have this syntax where you have actually 3 different parts inside the header for the for loop. Instead, you basically use a for in loop, which is not really less expressive. So if you want to do steps by 2, for instance, you can also use for I in 1 down to You can also use for I in 10 down to 1, step 2, and that's gonna do exactly what you think. So it's gonna go down in steps of 2. You could of course also do this for the example where you go up from 1 to 10. So all those things you can do with for loops in Java, you can also do with for loops in Kotlin. It's just a bit of a different syntax. And with this, you already have most you're gonna have to learn about loops when migrating from Java to Kotlin. Because next, when we're going to take a look at while loops, they're not going to be very different from Java. So let's move on now to the next lecture to look at the while and the do while loop. Alright, so while and do while loops are really the same as in Java. So when you go ahead and create a variable, let's say I, assign 1 to this, and then create a while loop. So let's say while I is less than or equal to 10. You're going to go ahead and open up curly braces, and inside here let's just increase I by 1. Well, for that I'm actually going to have to make this a variable. So let's go back. I'm just going to cut this, and I'm going to say var I equals 1. And now I'm going to copy this back in here, and I'm going to say I++. So I'm just going to increment I by 1 each time. And I'm actually also, well, let's first print out I. And again, just add a space in between so that we can see all the different numbers. And you can see we get the same result as with the for loop. It's just that in this case, the for loop would of course be the better choice. It's easier to use in this case. But the while loop you will normally use when the number of iterations isn't really clear beforehand. So whenever you want to iterate something as long as some condition holds, you will normally use the while loop in order to just go on and on until, for instance, until the user enters a valid number, or let's say a valid email address. You just stay inside a while loop to ask the user for an email address, and only once there's a valid email address that's entered, you can skip out of the while loop. So in those kinds of cases, you don't know how many iterations you're going to need. So in how many iterations the user will finally enter a valid email address. And those are the kinds of cases where you would use a while loop instead of a for loop. Now last, just like in Java and other languages, there's also the do while loop. So you could also go ahead and say do print line I, for instance, and increase I by 1 while, and then the condition only comes after the block. Let's say while I is less than or equal to 20. So you can see we now move on from 11 to 12 and so on. And the only difference to the normal while loop is that the block of code inside here will always be executed at least once. And only after this, it's going to check the condition here and go ahead and repeat this block of code until the condition is true. So this is actually the better way if you want to use, or if you want to ask the user to input a valid email address. You normally want to do this at least once to give the user a chance to input an email address. So you can use a do while block, and in the do block you're going to ask the user to put in an email address, and then you're going to check whether it was valid. And if it's not valid, you're just going to skip back into the do block, do this again, and do this over and over again until you finally have a valid email address. Now I think the while loop is very familiar to you from Java and also from other programming languages. And when compared to Java, there's also no new syntax really. So only the for loop is somewhat different, and you're going to have to get used to another syntax. But I don't want to talk too much about the while loop. First of all, it's not used as much, and it's just the exact same as in Java. So with this, I'm going to end this here. And if you have any questions left, of course, just let me know in the Q&A, and I will answer all the questions you might have. So thanks a lot for watching, and I will see you again in the next lecture. Alright, in this lecture we're going to take a look at a very fundamental concept in Kotlin and pretty much any programming language, which are functions. And we're going to look at functions in much more detail in the next section, where we're going to also look at functional programming concepts and how to use them in Kotlin. But in this lecture, we're only going to look at how to actually create a function, at the syntax, and how to use it. Now, the syntax is very different from Java, so it might take a bit getting used to, but let's just go ahead and see what it actually looks like. So let's go ahead and use the fun keyword to create a function. So kind of similar to Python, where you have the def keyword to create a function. And in this case, it's just called fun. And then I'm going to call the function permit entrance. And that's just going to take in as a parameter an age, which is of type int. So again, just like when declaring variables, the type always comes after the identifier. And that also goes for function arguments and also for the function itself. So the return value of the function is defined after its identifier or its name, permit entrance. So I'm going to say colon, and the return type of the function is a boolean. And then in curly braces, we can define the function body. Whereas this at the top here, as you might know, is just referred to as the function signature, which must uniquely identify the function. So inside the function body here, we can now define the logic of the function, which in this case should just be that the entrance is permitted to anyone whose age is at least 18. So let's return age greater or equal to 18, and then entrance is permitted, so we're going to return true, and in other cases we're going to return false. So let's go ahead and run this to create this function. So now we have this function defined called permit entrance. So we can now also use it or call it, pass in an argument. So in this case, let's try with age 7, hit Control Enter to run the function, and it's going to come back with false. If on the other hand, we call it with age 18 or something larger than that, then it's going to come back with true. And of course, you can only pass in integers because you defined the argument to be of type int, and the return value is always going to be a boolean. Now let's go ahead and look at a shorthand syntax in Kotlin, which is used very frequently in idiomatic Kotlin code, which is used to create functions like this in a more concise way. More specifically, what I mean by functions like this are functions that only contain basically one expression in the function body. And what we can do here is we can actually get rid of the curly braces and just say the function is equal to, and then use the expression here to define the function, get rid of all curly braces. So this means now that the value of the function is always going to be the right hand side here of the equal sign. And we can also define it like this, and it's still going to work the exact same way. Also notice that of course Kotlin again, or the Kotlin compiler, can again infer the type here if we say, or we save this to a variable. So granted is permit entrance of 11. Then it can also infer the type granted very easily, of course, from the return type of the function. So that's no problem at all. We can still make use of Kotlin's type inference. This is basically the exact same thing that was also working when we said list is list of something. Then of course Kotlin is able to infer the type. Alright, now starting again here from the top in the REPL, next thing you can do is you can use var arguments just like in Java. So let's say we want to actually be able to pass in as many ages as we want, for example for a group of people, and we want to permit entrance if any one of them has at least age 18. So what we can do is we can use the var keyword, then say ages of type int, which means that each of the arguments must be of type int, and the return value is still going to be a boolean. And we can just return here ages.any, and then we can go through each of the ages. So let's say age goes to age greater equal or 18. So the any function here is just going to return true if any of the ages in this variable here is greater or equal to 18, because that's what we defined in this lambda here. But we're going to take a much closer look at this later on. For now, it's just important to know we can use the var keyword to define var arguments in Kotlin, and that will allow us to then call this function and pass in as many arguments as we like. So let's say 11, 20, and 7. And then if I go ahead and run this, it's going to return true because we have one age that is above or equal to 18. But if that's not the case, it's going to be false. Alright, so that's all about functions for now in Kotlin. You can create them using the fun keyword, and be aware that the type, just like always, is at the end of the identifier or this. Alright, so that's all about functions or the basics of functions in Kotlin. We're going to take a much closer look at what we can all do with functions in Kotlin and higher order functions, lambda functions, extension functions, and so on. But for now, just notice that you have the fun keyword to declare a function. You can have var arguments, and you must put the return type at the end of the argument list. And you can also use the shorthand syntax if a function only contains one expression by just setting it equal to that expression. But now with this knowledge, we can actually go ahead in the next lecture and create our first main function and our first real Kotlin script that we can then run and save in a file instead of using the Kotlin REPL here. So let's move on now to the next lecture to do exactly that. Alright, welcome back. So we're now at the point where we don't actually want to use the Kotlin REPL anymore, but write actual Kotlin files and write our code in there to be able to also write more complex code in a more structured and organized way. Now, unfortunately, Android Studio isn't really designed to handle those use cases or those kinds of projects where you have just, for example, one file with a main function that you just want to execute, because Android Studio is really designed to build a whole project with Gradle, to generate the APK file, and to deploy that on a virtual device, for example, or an actual device to then run your app. So unfortunately, it's really hard to get this set up in Android Studio in a way that it really just runs one Kotlin file. So instead, it's much easier to install the IntelliJ IDE on which Android Studio is based. But of course, it's a more general IDE where you can really write Kotlin code and just play around with it in a much better way than in Android Studio, with less overhead, and it's just better designed for those use cases. So let's go ahead and go away from Android Studio here and instead go into the browser to install IntelliJ. Of course, if you already have this installed, you can completely skip this step and already move on with the next lecture. If you don't have IntelliJ installed yet, you can go to jetbrains.com/idea or just use the link in the lecture resources. So that's going to take you to this page where you're going to just click on download. And this is then going to take you to the download page here. And you can just choose the free community edition here, which is free to download and is more than enough what we need for this course. So it's going to start the download here. And once it has finished, you can just run the executable to start the installation process and just follow through like you did with installing Android Studio. Now, if you have Eclipse installed, you can also install the Kotlin plugin, but you're going to have to somehow map what I do in IntelliJ to Eclipse. So I would recommend using IntelliJ instead so that it's easier for you to follow along in the course. But it's completely possible to do everything we're going to do in Eclipse or any other IDE that offers a Kotlin plugin. Alright, so with this we're now all set up to really dive into creating some more serious Kotlin files and write some serious Kotlin code. And we're going to go back to using Android Studio later on in the course when we do actually want to create Android apps with Kotlin. Alright, so that's already all for the setup in between, which is unfortunately necessary due to the limitations in Android Studio. But using IntelliJ will really be much more productive than using Android Studio. And also remember again that Android Studio is actually based on IntelliJ. So it's not going to look very different. It's going to be very, very similar, but just more useful for these kinds of cases where you don't really have an Android app that you're developing. Now, after the installation, you can start up IntelliJ and it's going to take you to this start screen here. Now, the first thing you want to do is want to go to configure plugins, then just search for Kotlin here and update the plugin if it's not at the newest version. So this way we're making sure we have the latest version of Kotlin and also that it's compatible with your build of the IntelliJ IDE. Alright, so after this it's going to come up with the recommendation to restart IntelliJ. So let's go ahead and do that now. Okay, so here we're back in IntelliJ. Now let's go ahead and create a new project here. And then you can either go to Java and select Kotlin Java, or you can directly go to Kotlin here and choose the JVM version, which is going to compile down to the Java virtual machine. So let me just resize this window, which has a weird format. And then I'm going to hit next here. And I'm going to go ahead and call this one Kotlin Android because it belongs to the Kotlin for Android course for me. And you can choose your Java version that you want to use with this, which should be the one you had installed in the installation at the beginning of the course. And it's also going to come with a Kotlin Java runtime that's already inside the plugin. So we're going to just go ahead and click finish here, and that's going to create our first project. So now you can already see this looks very familiar. So pretty much the same as Android Studio, but with just some less of the buttons you can have here for Gradle and so on and for Android specific things. Instead, you have your project here, for example, where you're going to put your files later on. And this is also exactly what we're going to do now and in the following lectures and sections to really dive into the Kotlin language. So thanks for watching, and I'll see you again in the next lecture. Alright, so now in this lecture, let's finally go ahead and create our first complete Kotlin file with a main function to execute it. Now, first of all, what I'm going to do again for the sake of this course is to remove all the clutter in the UI here. And then I'm going to go ahead into the sidebar here, which if it doesn't show up, you can just use Alt-1 in order to toggle this. And then here you can just use Alt-Insert to create a new package. And I'm just going to go ahead and call this one Basics. And then inside there again with Alt-Insert, you can create a new Kotlin file. And I'm just going to go ahead and call that main. So with this, we now have our first self-created Kotlin file, main.kt, and inside here we can use all the things that we've learned in the Kotlin REPL, which first of all means we can also create a function called main, and it's going to take as arguments an array of string, which is just like in Java, but with a bit of a different syntax, of course. But notice that in contrast to Java, in Kotlin we don't need to wrap this inside a class. We can just create a top-level function, and we can also create top-level variables right inside our file. So you could also go ahead and just create a value here. Let's say, for example, some constant pi is 31415. And you can do that also without wrapping this inside a class. So inside our main function here, we can now use any of the things that we learned in the beginning in the Kotlin REPL. For example, create a list, which is a list of strings with Kotlin and Android. And then you can go ahead and print this out, for example, print list, or you could print the constant pi up there, and then just use Ctrl-Shift-F10 to run the file that you're currently using. Alright, so after this has compiled and run your code, you can see this comes back with a kind of console here or output, where you can see first the list and then the constant printed. Alright, so this is the kind of structure that we're going to use. Just having a main function where we can put our code just to try out different language features and to see what they do. And this will also allow us to create a little bit more complex examples than with just the Kotlin REPL. So that's what we're going to use from now on. So I'm going to see you again in the next lecture. Welcome back. So after we've taken a look at functions in Kotlin and then used that to create our first main function, I want to talk now about two great features for functions in Kotlin that are unfortunately still not available in Java, but in many other programming languages. And those are default parameter values and named arguments. So let's go ahead and create a new file in our basics package here. And I'm just going to abbreviate that as parameters. And then I'm going to go ahead and create our new main function again. So you can have a new main function in every file if you want, so that you can execute each of your files just to try things out. So to demonstrate this, I'm going to go ahead and create a new function here called concat. And that's going to take in a list of strings as text that you want to concatenate into just one string. And I'm also going to give in a separator that can be used in order to define what kind of characters you want to have between each of the concatenated strings. So this would be a function signature like we saw it. We can also say that this is going to return a string, but I'm actually going to use the shorthand notation later on so that Kotlin can again make use of type inference to find out that this is actually a string. But now let me actually go ahead and create a default parameter value for the separator parameter. And I'm going to go ahead and just say equals, and I'm going to put in here comma and a space. So now this is the default value for the parameter, which means that you don't actually need to pass in anything for the separator, but can only pass in a list of strings. So let me just go ahead and implement this one as texts dot. And I'm going to make use of the join to string method here. And I'm going to pass in the separator. So now if I go ahead in our main function and say val together equals concat of, let's say, the list of Kotlin, Java, and Scala, then I can go ahead and print out together to see what the result of that is. But notice already that I only passed in a list here, but not a separator. So I don't need to do that because I have a default value set for that parameter, and this would only be achievable in Java using overloading of the methods, which you don't need in Kotlin, and would of course make the code much more lengthy and include a lot of boilerplate. So here you can see it's going to come back with the expected result of Kotlin, Java, Scala. Of course, you can go ahead and pass in a separator as well. Let's say a colon surrounded by spaces. And then when you run this, it's going to come back with the 2 or the 3 strings concatenated with a colon in between. So this is how you can use default parameter values. So let's now take a look at named arguments. So you may already have noticed actually that IntelliJ and Android Studio have actually started adding this parameter value or this parameter name in front of arguments where you otherwise wouldn't know what this might mean. So it's going to display actually here a separator just in order to make the code more readable and more understandable. But in other IDEs you wouldn't see this, and you might wonder what this second parameter actually means. Now in Kotlin you can go ahead and also explicitly say you want to set the separator equal to this specific string, and then of course IntelliJ is also not going to display that anymore. But this doesn't only make your code more readable, you can also use this to change the order of any arguments you have to pass into a function by just using the explicit names. So here for example you can change the order of the arguments by using the parameter names, because well, Kotlin is then of course still able to pass in the values here to the correct arguments of the function. And we can still go ahead and give this a run to try this out. And as you can see, it's going to come back again with the same kind of output. So the named arguments here can not only be used to make your code more understandable or readable, but also give you more freedom as to in which order to pass in the arguments. But I think a larger benefit when coming from Java is to have these default parameter values, because it prevents you from having to overload the methods multiple times, and in the worst case even with exponentially many overloaded methods, and instead just use a very readable syntax, as I think, and also a very concise one. So there's no need anymore for all this boilerplate code and for telescoping patterns, as you would say in Java, but instead just use the default values. You can do this for multiple arguments or parameters, as many as you want, of course. So it's a really powerful way to make your code very concise and readable. And also this is one of the features that I think has no drawback and just benefits. So I think it's a really good decision to have this, and I'm actually not sure why this isn't included in Java yet, but maybe it's gonna come in a future version like Java 10. Alright, so that's it about named arguments and default parameter values. So let's go ahead now and move on to the next lecture. Alright, so now before we move on into the next section to really dive into functional programming in Kotlin, let's take a quick look at exception handling in Kotlin and how you can use exceptions. And syntactically, exceptions are very similar to Java, but on a conceptual level, there's one major difference, which we're going to talk about in detail in the next lecture. For now, let's go ahead and create a new file again in our basics package, and I'm going to call that exceptions. So let me first go ahead and create a new main function again, and then I'm going to create another function, which in this case is going to throw an exception. So let's say I want to get some external input, and this should then return that external input as a string normally. But for now, we're just going to say that this is going to throw an IO exception, meaning that the external input could not be read for some reason. So let's say could not read external input. So here you can see that we have the throw keyword, just like in Java, just that we don't have actually the new keyword, which doesn't exist in Kotlin at all. So also later when we talk about object orientation, there's going to be no new keyword. You just create an object by referring to the name of the class and just calling the constructor like that. Alright, so that's how you can throw an exception. So now let's take a look what happens if we actually try to get the external input in this case, store that into a variable, and then try to print out what we got. So you can see it's going to come back, of course, with an IO exception that was thrown in our function here. That also says could not read external input, and you can see the stack trace below. So let's now go ahead and take a look at how to actually catch an exception on the other side by using a try catch block, which is also very similar to Java. So for now, let me just comment out this line and then wrap this input or the function call in a try block. And then you can use catch, call that variable e for example, and it's going to be of type IO exception. Then inside the catch block you can perform whatever you want, like for example now let's just print the stack trace. And then also you have a finally block, just like in Java and other programming languages, that will always be run no matter what kind of block, whether you run into the catch block or not, whether you finish the try block. You can be sure that the finally block here will always be called. So let's say, for example, finish processing external input, or rather, let's say trying to read external input. So now this way we have safely called our function here, get external input, and we've also stored this into our input variable. But now the problem is, since this is happening in a try block, this variable isn't visible here anymore. So from Java, you may be used to just declaring that variable above the try catch block. So for example, val input, and then just using input here. And let's say this is supposed to be normally of type string. That's what we want. But now, first of all, we'll have to initialize this now with some value. And also we can't make this a val anymore. We have to make this mutable in order to assign it in the try block. And actually, if this wasn't a string, but some other object for which we don't have a useful default value like this one, you normally actually have to go ahead and make this a nullable as well, assign this to null at first, in order to then be able to read the input into it. So this is bad in two ways. We have a nullable now, so we've introduced null into our program, and we weren't able to keep this variable immutable. But that's just because we didn't actually do this the Kotlin way. This is more like the Java way, where you have to initialize the variable beforehand. But in Kotlin, again, the try catch block as well is actually an expression. So you can go ahead and create a val input and assign this to this try catch block. And then again, the last line in the try block here is going to be the return value. So you just want this to be get external input. And then in the catch block as well, you can include a last line that's going to define the value for input if you run into this catch block. So this could be null, then you introduce nullable again. But if you can use a more useful default value, like in this case, let's say an empty string. And then this way you have defined the return values for both cases where either the try block runs through or we have to go into the catch block. And this way now we have an immutable variable input, and in this case we could also prevent this to be nullable. And now we can go ahead and run this again to see what this gives us. And you can see it's going to come back again with the IO exception, of course. We still haven't done anything else in get external input. You can see we get this print out from the finally block here. And also you can see this empty line here, which is probably because input is just an empty string. So printing out input here with print line will just create an empty line. Alright, so that's it about the basics of exceptions in Kotlin. You have the throw keyword just like in Java. You have try, catch, and finally just like in Java. But you can again use this as an expression in order to store the value of the try catch block to a variable without having to initialize this beforehand. So syntactically, as I mentioned, it's very similar to Java, but the main difference is there are no checked exceptions in Kotlin, and that's exactly what we're going to talk about in the next lecture. So now that you know about the basics of exceptions in Kotlin, let's take a closer look at checked exceptions in Java, which do not exist in Kotlin, and the reasons behind the decision in language design to not include checked exceptions in Kotlin. So first of all, let's talk about what checked exceptions are and what unchecked exceptions are. And for that, I'm actually going to go ahead and open up the exception class in Java. So you can see this is from java.lang. And if I open this up, you can see in the documentation here above, it says the class exception and any subclasses that are not also subclasses of runtime exception, which we're going to look at in a moment, are checked exceptions. So anything or any exception that extends the exception class here and does not extend runtime exception is a so-called checked exception. And what that means is also explained here. So it says checked exceptions need to be declared in a method or constructor's throws clause if they can be thrown by the execution. So let's go ahead and take a look at an example of this. So let me go back to my main here. And this is just a Java main class with a main method that calls this one function here, can throw an exception. And now if I go ahead inside here and say throw new IO exception, which is a checked exception, so it inherits from the exception class, but not from runtime exception, then you can see here that the compiler is going to go ahead and give me an error, because what I'm going to have to do is I'm going to have to say that this method here throws this checked exception. So that's what it was meant by when it said checked exceptions need to be declared in a method or constructor's throws clause. So in other words, I cannot throw an IO exception here without saying in my signature for the function or method that it does actually throw an IO exception. And then when it's called somewhere else, like in this example in the main function here, you always have two choices. You can decide to surround this with a try and catch statement, like we just saw in Kotlin as well. So you can see it looks very similar in Java. Or you can go ahead and propagate that exception by adding it to the method signature again, and then letting other functions that call that function or method again perform the same kind of decision to either use a try catch block or again propagate the exception. And this is, and oftentimes in larger architectures or larger software, exceptions are then propagated along many levels, which first of all decreases traceability, but also means that higher layers in the architecture have to know about many of the exceptions that can occur in levels further down below. And that's why in practice, the experience was made that checked exceptions actually inherit more problems than they solve problems. And this is also why Kotlin, just like Ruby, C#, and other languages that are inspired by Java, decided not to include checked exceptions in the language. Especially for Kotlin, which is really targeted at enterprise scale software, this is of course an important argument because, as I mentioned, for larger systems this can often prove to be problematic, but for smaller systems checked exceptions are actually a good idea in many cases because they can't propagate too far. So it's really a matter of what your language focus is, and so Kotlin and the Kotlin team made the decision in their case, just like C# and Ruby, not to include checked exceptions. And now just for the sake of completeness, you can also go ahead and do this for, let's say, the illegal state exception. So I'm going to get rid of this and throw a new illegal state exception here. And then you can see this is actually a subclass of runtime exception. So it's an unchecked exception. And you can see I don't have to add a throws clause here. And also the function call here doesn't have to actually use try catch or anything, because an unchecked exception doesn't have to be caught. And this is exactly the way that any exception in Kotlin works, because, well, there are no checked exceptions, there are only unchecked exceptions. So this means you are never forced to try or catch an exception, but of course you're going to have to make sure that you do catch exceptions where it's useful. Alright, so that was just a quick excursion into Java and exception handling, talking more about checked exceptions, just to make you understand why this important difference between Java and Kotlin exists. And hopefully this will also be useful for you when you go ahead and try to use exceptions in Kotlin, just in order to understand how they work, basically the same way that unchecked exceptions work in Java. Of course, if you still have any questions about this, just let me know in the Q&A, and otherwise I'm going to see you again in the next lecture. Alright, congratulations! You now finished with the basics section on the Kotlin language. And you've seen also how many of the language features provide benefits when compared to Java. Like, for instance, you can write more concise code that's more expressive, more understandable, and you also have a clear focus on immutability in your code using, for instance, val, or using clearly immutable collections, where you have this clear differentiation between mutable and immutable collections, which doesn't exist in Java by itself. You've also seen how to make your code null safe using some of the great features of Kotlin, like, well, by default, all the types are non-nullable. You can try to avoid using nullable types. And if you do, you still have lots of support by the compiler using safe call operators and just warnings. You can't even access an object that might be null in Kotlin. So there are really many ways in which you can avoid the dreaded null pointer exception that you often come across in Java. And then also you've seen how to use name parameters and default values for parameters, which is a great feature that can greatly, make your code more concise. And it's something that's unfortunately still missing in Java, whereas it exists in languages like Python, for example. So I think it's a great feature. It doesn't have any disadvantages basically, and you now know how to use it in Kotlin. So in the next section, we'll now move on to functional programming and object-oriented programming. So those are basically the two paradigms that Kotlin is really based on as a language, similar to many of the modern programming languages like Swift or Scala. All right, in this section, we're finally able to look into functional programming in Kotlin. Functional programming is great. It avoids having side effects in your code. It makes many development tasks much easier and much more concise to solve. And it often helps you to just write more understandable, more readable code. And it's just one of the major concepts in many modern languages, not only Kotlin. So it's a really important topic to master nowadays and to just, have an idea of and know how to use. So what you're going to learn in this section, you will not only be able to apply in Kotlin, you will also be able to apply this in Java 8, for instance, where we have functional concepts introduced, in Swift, Scala, or whatever other, Python, Go, just basically all those modern programming languages. So it's really something that somehow also on a conceptual level goes beyond just Kotlin. So it's just very interesting to see. Of course, we're going to focus then on how to use this in Kotlin later in this section. But for now, I just want to talk about what functional programming actually is and the major ideas and concepts behind that. So I'm going to see you in the next lecture where we're going to get a better idea and a better understanding of functional programming. Let's first try to understand functional programming on a foundational level. So functional programming in a pure functional language means that your program is kind of like just a function. You have input that you put into your program, and that program performs its function. It can be defined or mathematically be described as just a function on the input, and it just produces some output. That's just the very broad conceptual idea. And you can then, for instance, compose programs, which are just functions, which is kind of like composing functions so that you take the output of one program, put it in as to the input to the next program, and so on. So that's a kind of modularity that you get with pure functional languages. But this is more of the idea for pure functional languages like Haskell or ML. It's not so much the case for languages like Kotlin, where functional programming is just one of the concepts that we can use to solve our problem. We also have object-oriented concepts, for instance. We have mutability. So in these languages like Kotlin, functional programming is just one of the paradigms we can use. And in order to understand how functional programming in this context is useful for us, there are, let's say, three major concepts we have to understand. So the first is immutability, which we've already discussed. And then we have lambda expressions, which we're going to talk about in more detail in this section and also in the next lecture, which are basically just like anonymous functions you can use throughout your code to make better use or to better modularize functions in your code. And this is going to become much more concrete when we actually use this in the code later on. And the third concept that we have to understand for functional programming are higher order functions. So those are functions that either take in another function as an argument or return another function as its return type. And all those concepts have just proven to be very useful for software developers because it helps us solve problems in easier or more understandable ways. And this is why many modern languages, like not just Kotlin, like also Scala, Java 8, Swift, Go, Python, all these languages introduce functional concepts to allow us to find better or more concise solutions to common development tasks. And we're going to see this again later on when we really dive into the code. But in the next lecture, I want to first focus more on what lambda expressions and higher order functions actually are. Because immutability, I think we already understand well enough at this point. But those two concepts I really want to just take a few minutes to talk more about so that we really are on the same page when it comes to those concepts. So with this, I'm going to end this lecture and I'm going to see you again in the next one. Alright, so in this lecture, I'm going to talk about higher order functions, lambda expressions, and also about lazy evaluation, which I forgot in the last lecture, which is another concept that we should try to be on the same page on when it comes to functional programming. So first, higher order functions are, as I mentioned, functions that either take in another function as their argument and or return another function as their return value. And that allows us to create more reusable code because we can basically, for instance, when we have a function as an argument, we can essentially define some kind of the logic for a larger part of code. So we can basically insert via that function we passed in part of the code, which we're going to use, for instance, to define a better way to do SQLite transaction on Android. And it also generally allows us to better compose different functions and therefore to also implement many common items in a better way. So for instance, if you know about this strategy pattern, that can also be implemented in a nicer and easier way using lambda expressions and higher order functions. So next, lambda expressions are just anonymous functions basically, which allow us to define a function very concisely at the place where we need it. Most of the time that's going to be to define the argument for a higher order function. Then we just want to define a lambda expression, a function in place without actually having to define a function separately and give it a name and so on. We only really want to have this function, this lambda expression, at this specific point in our code, for instance, as the argument to a higher order function. And we don't really need it anywhere else. So we don't want to give it a name. We don't want to really store it in an object. And that's exactly what lambda expressions are going to do for us. And you're going to see many examples in this section about how to use that. Now the last concept that I forgot in the last lecture is lazy evaluation. And lazy evaluation is a major concept in all pure functional programming languages because it allows us to only evaluate an expression as far as necessary. Most programming languages follow the concept of strict evaluation. So as soon as you have an expression in your code, that expression is going to be evaluated completely whether or not it's actually going to be used. Now with lazy evaluation in functional programming, that's going to allow us to have infinite lists, first of all, because that infinite list will only be evaluated as far as necessary in order to work with the rest of our code. So if we define an infinite list and only need the first 100 elements, then only those first 100 elements will be evaluated. And that's what we're going to do also in this section. So we're going to see quite a few examples of this for lazy sequences in Kotlin, is what they're called. And with this, you will then have all the fundamentals about functional programming that you need for not only Kotlin, but also other languages. And I think it's just a very cool topic to talk about and also to learn. Now at this point, I just want to mention that there's a lot of theory behind functional programming. And I'm going to try in this course to keep it as practical as possible. I try to explain all these concepts on a quite high level, just to keep them also understandable for you. Of course, if you have any questions about how something works in more detail or anything like that, just let me know in the Q&A and I will try to answer as good as I can. But for now, I'm going to leave it at this. I think we're now on the same page when it comes to the major concepts in functional programming. So in the next section, in the next lecture, we can finally start to really dive into some code in Kotlin and see how we can use lambda expressions, higher order functions, and so on in our code. So I hope you're excited about this, and I will see you again in the next lecture. Now that you know what functional programming in general actually refers to and what the major parts or concepts in functional programming are, let's start our journey into functional programming in Kotlin by diving right into lambdas and higher order functions. So for that, I'm going to go ahead here again in our project structure, create a new file, and I'm just going to call that lambdas. And I will also again include a main function here first of all, so that we can just try out what we do in here. And now first of all, let's go ahead and take a look at how to actually create a lambda. And you can think of a lambda function as just a function without a name. So you can just create a function like this. You first use curly braces to define the lambda. Then next you can go ahead and define the parameters of the lambda function. In this case, I'm going to say it takes in an integer x. Then use an arrow and define the return value of that lambda. In this case, I'm going to say x times 2. So this is now a lambda function here, which has one parameter of type integer, and it's just going to multiply that number by 2. Next thing you can do now is you can store that function into a variable. In this case, let's say times 2. So now the variable times 2 here has actually a type function, and you can write this out explicitly as well as a function that takes in an integer and returns an integer as well. But we're also going to have to wrap all the input parameters in parentheses to make sure that this is actually a function type. But again, you can also get rid of this for now because Kotlin can infer that type for us. So let's go ahead and just remove that for now to clean up the code a bit. And you can also go ahead and create a lambda with more than one parameter, of course. And in that case, you can just separate them by comma. So for example, x and y, and just return x plus y, for example. And again, the return type here is going to be a function that takes in 2 integers and returns an integer again. And that's the way you can write this in Kotlin, using parentheses to define the input parameters, also separating them by comma, and then the arrow to define the return type on the right hand side. Again, you don't need to do this here, but it's just to show you what the syntax of the type declaration would actually look like. So now that you know how you can create lambdas, let's take a look at higher order functions in Kotlin. And for that, I'm first going to go ahead and create a list, and I'm going to construct that as a list of elements 1 to 100, and then put that into a list. So this is going to generate the range of numbers from 1 to 100, but I want to actually wrap that into a list. So I can call the toList method on that. And this way I'm going to get a list of all numbers from 1 to 100. And now one of the built-in higher order functions in Kotlin is this filter function on collections here, which, as you can already see, takes in a predicate, so a function that returns a boolean, and it's going to take in one integer in this case because we're calling this on a list of integers. So it's going to take in one integer and it has to return a boolean. So notice here again the same syntax with the parameters or the input parameters of the function in parentheses, then the arrow and the return type. So you can see that this filter function here is a higher order function because it does actually take in another function as its argument. Another way for higher order functions is that they return a function. And of course, they could also take in functions as parameters and also return functions again as the return type. In this case here, we're going to take a look at this filter function, which is a higher order function that just takes in another function as a parameter. So how are we going to pass in a function like this? Well, we can again create a lambda, so curly braces, and then we're going to have one argument here. In this case, we're going to call that element, but you can call it whatever you like. And it is actually going to be of type integer. But again, the Kotlin compiler can infer the type here because we do actually need a lambda from int to boolean. So it's going to assume that the type of this is going to be int. And then what we can do is we can, for example, filter out all the numbers that are not even. So I'm going to say filter element modulo 2 is 0, meaning that the element is divisible by 2. So in those cases, it won't be removed from the list or from the return value of the function call. But if it is an odd number, it's not going to be in the result of this filter. So if we print this out, it's only going to return the even values. And let's actually go ahead and give this a test run just to make sure that we do get the expected result. Alright, so as you can see, we only get all the even numbers returned, which is exactly what we wanted to do. So this is working fine, but it's still a bit lengthy. And this is more like the Java way to write a lambda with having the input type here or the input arguments on the left-hand side and then the right-hand side. So let's go ahead and actually make this a bit shorter. And to do that, we can actually make use of the implicit it variable, which exists if the lambda expression, like in this case, has only one parameter, in this case the element. Then we can get rid of the left-hand side and the arrow and just refer to the element that we're currently looking at using it. So this is a variable that is implicitly created by Kotlin, and you can use this whenever, as I mentioned, you only have one parameter in the lambda. So now we can say list.filter it modulo 2 equals 0, but we can make this a bit more readable again by wrapping this modulo function here into its own function call. And actually the nicest way to do this is to actually use an extension function here on the int type. So let's say int.even, again, I think we had this before, is equal to this modulo 2 equals 0. And then this way we can again improve this code up here by actually going ahead and using it.even, because it is a integer variable, and so we can now use our extension function on that. So this way now we have very concise and very readable code, which is often the case once you actually apply all the nice features you can use in Kotlin. Now I want to show you one more thing you can do by having a function, let's say is even, which is going to take an integer and is also just going to return whether I modulo 2 equals 0. Then you can also make use of so-called function pointers to pass in the function that you want to filter with. And to use or refer to a function, in this case is even, you can first use 2 colons and then pass in the name of the function, in this case is even. And this way now it's going to apply this function here to each of the elements. So this is basically just another way to write this, and to refer to a function like this, you're going to have to use the double colon notation. And of course, the signature of this function has to match the function that is expected as an argument. So in this case, it must be a function that takes an integer here and that returns a boolean, which of course is fulfilled with isEven here. Now one last thing we can even improve with this solution here is to make use of the fact that in Kotlin, if a function like filter in this case takes in a lambda as its last argument, we can move that lambda expression out of the parentheses here and just use it like this. Now let me just get rid of the print line for a moment just to make this structure a bit clearer. So you can see now for calling the filter function here, we don't actually use any parentheses anymore. We just define the lambda. So basically we can move this out of the parentheses because in this case the lambda is actually the only parameter. So of course it's also the last parameter. So especially in more complex use cases, this is a very neat way to write the lambdas and to actually structure your code. And we're also going to see in a few lectures later how you can also make use of this to create functions that look a bit like as if they were keywords and which also help make your code much more readable and concise. Alright, so those are the basics of lambdas and higher order functions in Kotlin. And as an example, we already looked at the filter function for collections. And we're actually going to move on in the next couple lectures to look at other methods or higher order functions on collections in more detail so that you can really work with collections very effectively in Kotlin. But for now, the main takeaways of this lecture are how to create lambda expressions and then that you can actually use the implicit it variable here if a lambda expression only has one parameter. And also that you can move out the lambda expression of the argument or the function call if it's the last argument. So with this, we're now ready to go ahead and dive into the next couple lectures to look at other useful functions beside the filter function. So thank you very much for watching and I look forward to seeing you again in the next lecture. Alright, so in the next couple lectures, we're going to take a look at how functional concepts and higher order functions are applied to collections in Kotlin. And as I mentioned, Kotlin actually extends Java's collections API, which already provides many useful functions and also all these functional concepts since Java 8. But of course, here we're going to take a look at the actual Kotlin collections and Kotlin collections API. And we're going to take a look at how to use them with all the great features surrounding lambdas in Kotlin. Now, if you're already familiar with a functional programming language, then the functions we're going to discuss in the next couple lectures are going to be nothing new to you, but it's still going to be a nice practice to see how to use and apply them in Kotlin. So let's go ahead here and jump into our project structure again, and then create a new Kotlin file, which I'm just going to call map, because in this lecture we're going to discuss the two higher order functions called map and flat map. So let me first go ahead and create a list again here with all the numbers from 1 to 100 using toList. And now what the map function does, if I do list.map, you can see also that IntelliJ suggests the syntax here with the parentheses or without parentheses with the curly braces just standing there already. And we're going to use this from now on because now we know what's going on and why we can actually write it this way. But now what the map function does here is that it's going to take in another function and it's going to apply that to each of the elements in the list or in the collection in general. So for example, we can go ahead here first again and say we want to map each element to twice that element. So that's of course going to go ahead, and if we just store this into a variable and then print this out, it's going to double each of the elements in the list. So in this case, it's going to give a list with all the elements from 2 to 200, but with steps of 2. So you can see we have 2, 4, 6, 8, 10, and so on. So it has applied this function here that we passed in to each of the elements in our original list. But of course, we can again do this in a much more concise way in Kotlin by just using list.map and then just saying it times 2. And that's going to give the exact same result. Now, just to look at another example, we can also go ahead and let's say first get the average of the list using this helper function in Kotlin, and then shift all the elements in the list by that average which is kind of like a normalization of data in some cases. So we can do it minus average, and that's gonna, well, center all the data or all the elements around 0 in this case. So let me go ahead and also print out this new variable shifted, and then run this code using Ctrl+Shift+F10. And you can see here we get the list, but now it starts at minus 49.5 and goes all the way around 0 up to 49.5 positive. So that's the map function in Kotlin. Now, next thing we can take a look at is flat map. So this was map, or actually all this part here is map. And then flat map is very similar, but instead of just applying the function to each element, it's also gonna flatten any nested collections. So let's say we have a nested list here, which is then of course a list of lists. So I'm gonna say list of and pass in some lists. In this case, let me actually use ranges again from 1 to 10, .toList. Next element is gonna be the list with all elements from 11 to 20, and then all the elements from 21 to 30. So this is now a list of lists, or in other words, a list that contains 3 other lists as its elements. So let's first take a look at what happens if we say nested list.map instead of flat map, and then, for example, sort each of the lists in descending order. So sorted descending, because remember that now the it variable here actually refers to a list of integers and not a single integer. And since we're applying this function to each element, the type of that element is going to be list of integer. So let's go ahead and take a look at the result of this. So let's store this actually, let's say in not flattened, and print out not flattened. And then again, we're going to take a look at the output. So you can see here in the output that we have a list that contains 3 other lists. So this is the first sublist, the second one, and the third one. And you can also see that each of those lists has now been sorted in descending order. But we still have this structure with a list that contains 3 other lists. So if we now go ahead and say val flattened equals nested list dot flat map, and then say it dot sorted descending, then let's go ahead and take a look at the output of this function call. So here you can see now we don't have a list of lists, but just a single list here of integers, and you can see that each of the elements of the first sublist from above here have now been inserted into this one flattened list, then followed by all the elements from the second list, and then followed by the rest of the elements from the third list. So in this case, the function that we put in here has been applied to each of the elements, so each of the lists, and then all the results of that have been concatenated into one single list that now contains 30 elements. And this can often be quite useful, and it's actually also pretty much the same thing as calling map, and then this function called flatten, which is of course gonna flatten a nested list of lists also into just one single list containing all the elements from those sublists. But you can of course also make use of the flat map operation, which is often quite useful. Now later when we look at object orientation, we can also use map in order to map any objects to only specific properties, like for example map a list of users to only their usernames in order to then work on only those names. So this is a very, very essential function that's being used very widely nowadays, and with Java 8 of course and the introduction of these functions in the Java Collections API as well, people have gotten used to using these kinds of concepts a lot more than before. And I think that's also a good thing because it makes your code very concise and readable again. And it's just something you should learn as soon as possible if you haven't already had much experience with other functional languages. Alright, but that's all about map and flat map, which are some of the most essential higher order functions in Kotlin. So now let's go ahead and move on to other useful higher order functions. Okay, let's move right on to the next two higher order functions in Kotlin, which are called take and drop. Now I'm going to go ahead and create a new main function here again, and I'm also going to go ahead and create a list of all the elements from 1 to 1000, for example, and put that into a list. So now what are take and drop? Well, basically they're very simple, because take is just going to take the first n elements of a list and only going to return those, whereas drop is going to drop the first n elements of a collection and is only going to return then the rest of the collection. So let's take a look at an example for this. Let's say first 10 equals list.take 10. So this will now return the first 10 elements of the list. And similarly, you can go ahead and say without first 900 equals list.drop 900, which is going to go ahead and drop the first 900 elements in the list. And in this case, there will be 100 elements left. So let's go ahead and just take a look at the output to really make sure this is working in the way we expected. And you can see that indeed we get the first 10 elements with take 10 and the last 100 elements if we drop the first 900. Alright, so far so simple. But this is especially useful when using sequences in Kotlin, which are basically lazy collections. And that means that only the elements that are actually used will be calculated. Now we're going to take a look at lazy sequences in detail later, but for now let's just take an example of how you can use take and drop in a more useful way. So I'm going to go ahead and say list, or I'm going to change the list above. I'm going to say list is supposed to be generate sequence, and I'm going to go ahead and use this function with a seed and then the next function, which is basically just the element you want to start with. So let's say 0, and then you pass in a lambda that can calculate the next element in the sequence based on the previous one. So let's, for example, go ahead and say it plus 10, which is then going to generate the sequence 0, 10, 20, 30, 40, and so on. And as you might have noticed, this is now actually an infinitely long list, which is only possible because of this principle of only calculating all the elements that are actually needed. So now when we say take 10, then only at that moment is Kotlin going to go ahead and actually generate or calculate the first 10 elements using 0, 0 plus 10, then 10 plus 10, 20 plus 10, and so on. And then when we say first 20, then all Kotlin has to do is it's going to have to calculate the elements 11 to 20, but it has already calculated the first 10 elements. So it's not going to do that again. And this is a very fundamental concept to be able to work with infinite lists and to also be able to have a good performance on those. And you can see that with sequences, there's actually not a good toString method. So what you have to do, like in streams in Java, and this is actually the equivalent to streams in Java, which are also lazy, is you can again gather them into a list by using toList at the end. And that way now when we actually go ahead and run this to get the output, we can now see the output that we expected with 0 to 90 and then the first 20 elements. But now let's actually make this a bit more interesting by also printing out in this lambda here what kind of element was just calculated. And this has to be the return type, where we can print out calculating and then let's say it plus 10. And that way we can know how often or at what point in the code Kotlin is actually going to go ahead and calculate each of the elements. So now when we scroll up here, you can see that it calculates all the elements from 10 to 90. And then it actually does calculate them again when you say take 20. So it's not going to cache those results for later invocations. But still, using take is very essential for performance reasons, because whenever you only actually want to work with a specific amount of elements, it's always important to use take first and then perform all the other calculations and operations on only those few elements instead of taking the whole list, which of course let's assume is not infinite, otherwise it's not gonna terminate at all. But instead of taking the whole list, performing all the operations on that, and then just taking a sublist of the result. So the order of operations is always going to be very essential with this. And we're going to take a look in a few lectures at chaining function calls like this. So for example, taking 10, then mapping the result, and then filtering and so on, and how to chain all those calls, and then also some best practices about how to do that, like the one I just mentioned, to first filter out any elements and only then perform all the expensive operations. Alright, but that's all about take and drop. And I just want to quickly mention there's actually also a function called first, and there's also one called last if you only want those two elements specifically, because in those cases that's a lot easier than using take one or maybe dropping the first n-1 elements of a collection. So keep those in mind. You have take to get the first n elements of the list, you have drop to drop the first n elements of the list and then only return the rest, and you also have first and last to get access to those two specific elements. So thanks a lot for watching, and let's again move on to some more great higher order functions in Kotlin. Alright, let's take a look at one more higher order function that's very useful for working with collections in Kotlin. Before we then actually go and look at how to chain all those functions in order to really use their power in combination. So for now, let's go ahead here with Alt-1 into the sidebar, use Alt-Insert to create a new file again, and I'm going to just call that zip, because the higher order function we're going to discuss in this lecture is called zip. Now for this function, I'm going to go ahead and create two lists as a preparation. So I'm going to say, first of all, some list of strings like hi there, Kotlin, fans. And then I'm going to create a list contains t is a list of false, true, true, and false, because these are supposed to refer to each of the elements in this list above here and define whether the word contains a t or not. So hi doesn't contain a t, but there contains a t. Kotlin also has a t, but fans doesn't. And now what the zip function does is it takes two collections and then, well, puts them together in a zipper-like fashion. So what it's going to do is it's going to create a pair, or 4 pairs in this case, which are going to be a, let's do it in a comment, a pair of string to Boolean, because we're actually zipping a list of strings here using zip with, in this case, a list of Booleans. So the type of this is going to be a list that contains those pairs of string to Boolean. And I'm only writing this down just to make the type clear, but of course Kotlin is just going to infer this again if you don't write it down. So for each element in this list here, for example hi, it's going to go ahead and zip that into a pair of string and Boolean with false. So basically it's going to have a pair hi false, then the next element in the list is going to be a pair with there and true, and so on. So this is very useful to combine different data sets that actually belong together and just zip them into pairs. Now of course using this list with contains t is not something you want to do in real world, so you can also achieve the exact same result using list.zip, and then inside here using list.map and mapping this to whether the word that we're looking at contains the letter t. So now this argument that we have here in the zip call is again a function of Booleans, and it's going to return the exact same result as the call above, but it's just how you would do it in the real world instead of creating this array or list of Booleans yourself. So let's go ahead and just take a look at the output of these two function calls just to make sure they're actually the same. So you can see here that Kotlin is going to print this first of all with square brackets again for a list, and then it's going to put the pairs in parentheses where the first is high and false, there and true, and so on. And you can also see that the two are indeed the same. Alright, so here we actually started already chaining them in a certain way, or just using both zip and map together. And that's exactly what we're going to look at in more detail in the next lecture. But for now, I just want to mention that this was just a very brief or a very small selection of all the higher order functions in Kotlin that work on collections. But of course, with these, you already have all the tools you need in order to also use the other higher order functions and to understand how they work and how to use them. So I'm not going to go through every single one of them, but if there's some function that you just can't quite figure out, you can also let me know, and I'm going to create a new lecture on that to just exemplify how you can then use that. For now, you have all the tools you need to use higher order functions in Kotlin. So let's now go ahead and take a look at how to combine all these to really use all their power in combination, and that's also how they are usually used in practice. Thanks for watching, and I'll see you again in the next lecture. Remember when we talked about some of the benefits of functional programming at the beginning of the section? Well, one of the things was to be able to actually concatenate functions in order to reuse them and also to just combine them. And that's exactly what we are going to do now with some of the collection API functions in Kotlin. So let's go ahead inside our basics package and create a new file that I'm going to call chaining, because we're going to chain some function calls. I'm going to create a main function again. And now the first thing I'm going to do is I'm going to create a value input rows, and I'm going to assume that this is a list of maps. So I'm going to assume for the sake of this lecture here that we have a somewhat complex input data that we want to convert into a much more usable format. So let's say we have a list of with a map of, and then the map always maps some input file. So let's say input o1.csv to a list of the data that was in that file. So let's say we have data here 3, 5, minus 9977, 7, 11, 66. Just some example basically. And I'm going to duplicate this for some more data. And I'm going to say we have input 2, 3, and 4.csv. And let's say in this, from this file, we have read the input 1, 3, and 4. Then we have extracted nothing from the third file. And here, let's say we have another error data 33, 14, 12, and 5. Doesn't really matter what numbers you put in there. It's just the structure that we have now is kind of complex. And of course, we want to map this to another data structure that we can work with much more easily. And more precisely in this case, we want to make this, all of this, into a int array. And we're going to assume here also that all the valid values are only between 0 and 100. So those values with 9,000 something are actually errors from our input that we want to filter out of our data. So we're going to clean up the input data, and we're also going to transform it into a more usable format. So let's go ahead and do that. So the question now is, of course, how do we get this structure into an int array? And also, how do we filter out all the invalid inputs? So first of all, let's go ahead and store a new variable here that's going to carry the result. And that's going to be input rows. And now let's go ahead and actually start performing some operations on the input data in order to get rid of all the unnecessary stuff. Now, first of all, we're not interested in the file names. So what I'm going to do here is I'm going to say flat map. And now what I'm going to do is I'm going to map each of the maps in the input rows to just their values. So it in this case here refers to a map, mapping strings to lists, and it.values refers to only the values. So in this case, there would be this list here of numbers, this list of numbers, and so on. So with this, we already got rid of the name of the files that we're not interested in. But now let's think about the result of the call to flat map here. Now, as I mentioned, it is a map from string to list, and so it.values is going to be a list of integers, each one of those. So what flatMap is going to do is it's going to map each of the maps to their list of integer values, and then it's going to concatenate all of those lists into one list. So what we basically get here as a result is a list of lists of integers, but what we actually want to have is just one flat list. So I'm going to call flatten here again in order to retrieve just a list of integers, and then I'm going to go ahead and say filter, and I'm going to filter out all the elements that are not between 0 and 100, and to do that I can just use it in 0 to 100, which is a valid Boolean expression that you can use in this case because it refers to an integer. And now all that's left to do is to just make this into an int array using toIntArray, a nice helper function we can use here in this case. You could of course also do something like toList or whatever you want to have, but in this case we said we want to have an int array, so that's what we're going to do. So now we got rid of the input keys or the file names, then we flattened this into a list of integers instead of having a nested list. We filtered out all the invalid data and then put this all into an integer array. So let's go ahead now and call println cleaned. And again, since this is an array, I'm going to call join to string, just so we get a useful output here. So let's now go ahead and run this file to see how the data looks now with all the cleanup. And as you can see, we only have our valid data inputs, so we don't have any minus 9,000 something or 9,000 something. And also we have all the numbers, all the valid numbers in one array. So this is actually a typical use case, or how you're going to see those functions used in practice by just chaining them after one another by just calling .flatMap, .flatten, .filter, .toIntArray, for example. So you can very easily concatenate all those functions in order to perform multiple operations on some object. Now I hope that this example of chaining was helpful for you. Now in the next couple lectures we're going to take a look at lazy sequences in Kotlin, and they are very helpful to increase the performance of such chains in many cases. So thanks for watching, and I'll see you again in the next lecture. Now in this lecture I want to take a look at lazy sequences in Kotlin, which are the equivalent of Java 8 streams. Now they're similar to collections, but they are lazy, which means that they will only be evaluated when it's actually necessary. So let's go ahead and just look at an example of this and see how to use this in Kotlin. So I'm going to go ahead here in our basics package again and create a new file that I'm just going to call sequences, with of course another main function again. So let's say here for the sake of this video we have a, let's say, very long list which contains all the numbers from 1 to some large number to list. So in this case 999,000, and then we're going to go ahead and calculate the result of a chain call on that list. So again we're going to make use of function chaining, like for example let me go ahead and say very long list dot filter, where this is larger than 50. So I only want those entries which are larger than 50. Then let me also go ahead and say map those to the doubled value. So map it times 2. Then I'm going to go ahead and make the mistake to only then take the first 1,000 items instead of doing that at the first step. And then I'm going to say sum. So notice that as I mentioned, you should normally go ahead and first take the first 1,000 entries here before you actually call filter, map, and perform all those operations. So notice that normally you should call take here as soon as possible. In this case, you could call this before mapping each of the entries, but not before filtering, because if you first take the first 1,000 and then filter those to only those that are larger than 50, you're going to lose some of the elements. And in this case here, that would yield a different result, because here we're going to take 1,000 elements in total, But if we were to move this take call here in front, then only 950 items will be left at the end. So that's just a quick mention about how you should normally do this, but for the sake of this lecture, I'm going to go ahead and make the mistake to call this one last, and then just call the sum. So here so far we haven't used any sequences in Kotlin. This is just a list on which we're calling all these functions. So let's go ahead and say print line, and I'm going to store this to a value called sum, and I'm just going to print that out. Now notice also that I used the long data type here by appending an L to the number, because otherwise you might run into the problem that the sum here will be larger than the largest size of an integer, and then you're going to get an overflow. So here, since the very long list contains longs, the sum variable here will also have the data type long. Alright, so for now let's take a look at what this will print out if we actually run this. And you can see here that the result is going to be 1,101,000. So now that we have that baseline, let's go ahead and create or use lazy sequences in Kotlin instead of using the list here. And it's very simple to do this. If you have a collection, like in this case, the very long list, you can simply call sequence in order to transform that into a lazy sequence in Kotlin. And now all the calls after that are actually going to be called on that sequence object, which means that they will be evaluated lazily. And as I mentioned before, this means that only those elements or those function calls here will be evaluated that are actually necessary. So this means that in this case, it's going to filter for an element that's larger than 50 because it has to. Then it's going to map that to double its value, and it's going to try to take 1000. So lazy sequence here will actually only perform those calls here on the 1000 elements that are really necessary and avoid calling it on all the other elements in this very long list. Now this is very different from using this without sequence, because now this way filter here is going to take the whole list, traverse the whole list or iterate over the whole list and filter out all the elements that don't match this condition here. Then it's also going to again take all the elements after the filter here and map all of them to their double, and only then it's going to take only the first 1000, but it has already performed all the previous calculations here for over or nearly 1,000,000 elements. So let's go back here to using sequence. And in the next lecture, we're also going to take a closer look at performance and try to compare the two, because in some cases, using lazy evaluation can actually improve performance, but in other cases, it's actually just overhead and can actually decrease performance. Alright, so a sequence is the easy way to use a sequence if you already have a collection. And now I want to take a quick look at another way to generate a sequence. And I'm actually going to create now an infinite sequence as well, just to show you that the lazy evaluation here is actually also going to allow us to have infinite lists or infinite sequences of elements, because the next element in the list will only be evaluated once it's actually used. So in contrast to just having a normal collection, which can never be infinite because you don't have infinite memory, we can actually have an infinite long sequence where each element will only be calculated on demand. Alright, so using a sequence here is an easy way to work with collections or sequences by using an existing collection and then just calling a sequence in order to transform that to a lazy sequence. But now let's take a quick look at how to use sequences right from the start. So I'm going to say val seq for sequence is generate sequence, which is a helper method here in Kotlin to actually generate a sequence. And I'm going to use the second signature here again in order to create a sequence with some start value, for example 1, and then passing in a lambda, let's say it plus 1, which will in this case then generate a list of all the numbers starting at 1. So what you can't do now, because this is an infinite sequence, is you can't go ahead and say print line seq or sequence, but you can go ahead and say print the first, let's say, 10 elements of this. And then, as I mentioned, the first 10 elements of this sequence are going to be calculated on demand. And again, as you have maybe noticed, I forgot to again convert this to a list. So to make this sequence back into a list, you can call toList. And then you also get a more useful output because they have actually a good toString function that's going to be called when printing it. Alright, so you can see we now have the first 10 elements in the list. And similarly, you could again go ahead and call any of the higher order functions that you learned about on this sequence. Now, in the next couple lectures, I want to dive more into generating sequences, maybe more advanced examples of sequences, and then also compare the performance of lazy sequences to just normal collections in order to see when lazy sequences actually make sense and can improve performance, and in what cases you should rather stick to normal collections. So thanks a lot for watching, and I'll see you again in the next lecture. Alright, so we've already seen now how to actually use sequences, either by using or transforming a collection into a sequence, or by generating a sequence from the get-go. Now in this lecture I want to do a case study to compare the performance of lazy sequences against normal collections. And to do that, I'm going to stay in this file here. I'm going to get rid of this sequence here for now. And instead, we're going to focus on this computation here and compare this between the two types of, well, collections or sequences. So I'm actually going to move the variable here, sum, out of the statement here for now and make this a var, just so that we can later put the computation into a block. You're going to see that in a minute. So we have a sum and we have a lazy sum, which is going to be using sequences, and sum is going to be using normal collections. So this way now we can put this block of the computation here into a call to measure time millis, which is a helper function in Kotlin that lets you easily measure the time that the calculation takes. Of course, it's not a professional benchmark, so if you're serious about this, you don't want to just use measure time millis. But for our purposes here, that's going to be fine. So the first one here is not going to use lazy sequences, and it's going to put the result into the sum variable. And let me actually move this back, because that indentation is actually correct. And then here I'm going to do measure time millis again. And as the name implies, that's just going to measure how many milliseconds the whole computation takes. And the computation here is actually the same, but we're going to be using lazy sequences instead. So I'm going to add a sequence and then store this result into lazy sum. Alright, and then at the end here I'm going to just print out how much time all this took. So I'm going to store the return value here in another variable. So we have milliseconds non-lazy, and here we have milliseconds lazy, and then we can compare the two and see which one actually performs better in this case. So let's go ahead and say non-lazy took milliseconds non-lazy. I'm going to put milliseconds there. And then let's also go ahead and print out the result, just to also make sure that it actually does indeed give us the same results. So I'm going to print out sum here. And then of course, let me scroll down a bit so you can see better. In the lazy case, so lazy, I'm going to print out milliseconds lazy and the lazy sum. So this way now we perform the same kind of computation, once with a normal list and once with a lazy sequence. And so let's go ahead and take a look at the results for this. Alright, so you can see here we come back with the result. That's of course going to be the same for both. It's just going to be the same sum. And you can see that the non-lazy implementation now took 232 milliseconds and the lazy one took 41 milliseconds. Now again, I just want to note that this is really not a strict or a complete benchmark. It's just a very simple way to get a broad estimate or rough estimate of which of the two computations might perform better. And in this case, you can see that the lazy variant does actually perform better. And that's because also we make this mistake here still to only at the end of the computation take only 1,000 elements. So this means that for the non-lazy implementation here, we have a list of nearly 1 million elements, and it's going to go ahead and filter all the 1 million elements. Then it's going to go ahead and map all the 1 million elements and only then take the first 1,000. Now, of course, we can also go ahead and change this to see which one performs better if we actually put the take call into the position where we can. So we want to actually just sum up the first 1,000 elements that are larger than 50 and map those. So in this case, we can actually move the take call in front of the map, and then let's go ahead and see how the result or what the result looks like now. And again, you can see that it's not such a large gap anymore. We now have 100 milliseconds for the non-lazy computation with normal collections and still around 40 milliseconds for the lazy implementation, because here it doesn't make much of a difference which call comes in which order. Now, the general rule of thumb is that the more elements you have, so let's say 10,000 here in this case, and also the more operations you perform on the elements or the sequence, the better the potential is for using lazy sequences. So here you can see the lazy implementation is still better, and if we actually go ahead and add more computation steps here, and for now I'm just going to go ahead and just perform the same kind of computation again, just in order to demonstrate the effect that this has on the performance. Then you can see that, well, it doesn't really make much of a difference because calculating times 2 with an integer is actually very, very efficient on the machine. So instead, let's go ahead and try to divide by 3 and maybe add 17 to this, in the hopes that this will maybe be a little bit more work or effort for the processor in order to show more of a difference between the two. So you can see both numbers have actually increased a little bit, and you can still see that lazy performs around 50% better, or it only takes 50% of the time of the normal collections. Now, just to make this really clear, let's go ahead and actually make the mistake again to call take last, and then run one last, well, benchmark, let's say, to see the difference between the two implementations. So here you can see we really run into a problem now with normal collections taking over 2 seconds here in this case, because we have lots of computations which are all performed on all the 1 million elements, whereas with lazy sequences the operations are only performed if necessary. And of course this is just a mistake here to do the take at the end, but still this is just to demonstrate this rule of thumb that the more computations you perform and the more elements you have in your list, the better it is, or the more potential you have, the larger is your potential to actually increase performance by using lazy sequences instead. Now, of course, you can perform a quick check in your use case, also using measured time millis if that's appropriate for your case, or using a real benchmark library in order to find out which one performs better for your case. But this is just to demonstrate how you could go ahead and do this, and also just to give you some of the best practices when working with sequences. And you can see here that in some use cases, the effect can be quite tremendous when using lazy sequences and can really improve your performance. In other cases, it can also decrease your performance a lot, so you really have to test. Performance in general is something you always have to test in your use case on your environment and so on to really decide what works best for you. Alright, but that's it about the performance of normal collections versus lazy sequences. So let's go ahead now and take a look at a bit more advanced example of using sequences to generate actually a sequence, an infinite sequence of all the prime numbers. So I hope you look forward to that, and I'm going to see you again in the next lecture. In this lecture, we're going to implement the CF of Eratosthenes using lazy sequences in Kotlin. Now, this is an algorithm, a rather simple algorithm, to generate a sequence of prime numbers by just going through all the numbers there are in order and then filtering out all the multiples. So you can see here the animation where you start with the 2, and then you can already filter out all multiples of 2 for the future prime numbers. Then you can go ahead and just select the next item or number that hasn't been filtered out yet. So in this case 3. Then you go ahead and filter out all the multiples of 3, and you move on, in this case, to a 5. Take that next number, which is not yet filtered out, and then again filter out all the multiples of 5, and so on. This is why it's called the CF of Eratosthenes, because it filters out elements like through a CF over time. So let's go ahead now and go into the code to see how to implement this in Kotlin. Let's go ahead and get set up. So I'm going to say prime sequence. And again, I'm going to create a main function here. So now this is going to be a pretty advanced example of using sequences in Kotlin. So don't worry too much if it takes a while for you to understand this, or if you can't really follow every step along the way right now. If you go ahead and use this more in practice, you're going to also be able to read such code more easily. But it's just to get you accustomed to also more advanced examples of using sequences. So in this case, we're going to use the generate sequence helper function that you've already seen. And we're going to go ahead and actually start with the sequence we want to actually begin with. Now in the end, we want to have some sequence primes, and we're going to use generate sequence as I mentioned. And in this case, I'm actually going to start with a 2, because that's the first prime number I want to use here. And in each step, I'm not actually going to generate a sequence of just integers, but I'm going to generate a sequence of pairs. So I'm going to map 2 to all the possible prime numbers that can follow 2. So let's say possible primes after 2. And of course, we're still going to have to create that. So let's go ahead and say up here, val possible primes after 2 is generate sequence starting at 3. And then the next elements are just going to always be it plus 2. So this is just the initialization step. We want to start off our prime sequence here with the element 2, but we're not actually going to just use integers in our sequence, but instead we're going to use the integer or the next prime number we want to have, in this case 2. And we also want to store along the way all the possible primes that can still follow at this point. So we're going to start off with the element 2 plus these possible primes after 2, and the possible primes after 2 start at 3 and start or go on with it plus 2. So this means this is the sequence 3, 5, 7, 9, 11 and so on, which at the very beginning are still the possible primes, even though of course the number 9, for example, is going to be filtered out later. So let's go ahead and do that now. So we want to see, first of all, we want to store the next prime number we can still have. That's going to be p. So p is going to be the first element we have in our sequence of still available primes. So at the beginning, that's going to be possible primes after 2. So I'm going to say it. And it is the current element in the sequence, which is, in this case, as I mentioned, a pair. And you can actually see here IntelliJ also tells you it's a pair from int. So int is our current prime number and a sequence of int. And that's the sequence of possible or still possible prime numbers at this point. So I'm going to go ahead and say it.second, which is going to give me this sequence. And now I want to get the first element of that. So I'm going to go ahead and do it like this. Now you can see here that this will be marked with squiggly red lines, but that's not because this line is actually wrong, but because remember we're still in the lambda expression here, which is the second argument to the generate sequence function. And remember that the last line in this lambda is again going to define the return value. And in this case, of course, the return value must be a sequence with pairs from integer to a sequence. So let's go ahead for now and just say that the return value is going to be null, and that's going to be at least a valid return type for now. So you can see that we now have p, which is our next prime number. Now let's go ahead and take a look at how this will start at the beginning. So we're going to start off with a 2 and the possible primes after 2, which are in this case 3, 5, 7 and so on. So it.second is going to refer in this case to exactly our variable possible primes after 2, and the first element of that is going to be 3. So correctly, the next prime number we're going to choose after 2 is going to be 3. Now all we need to do in order to actually get the correct return value here is also generate now this sequence of possible prime numbers after this prime number p. And as you saw in the algorithm, what we have to do for this, and I'm going to store this in a variable possible primes after p in this case, is just take the sequence that we currently have of all the primes that are currently still possible and filter out all the duplicates of this next prime number p. So we're going to say filter it modulo p equals 0 because we want to keep only those elements that are not divisible by p. So in this case, again, in the first iteration, we said that p is going to be 3, which is of course correctly the next prime number after 2. So we're going to go ahead and say possible primes after 3 is then going to be it.second. Again, this is going to still be the possible primes after 2 from the step before. So that's still going to contain 3, 5, 7, 9, 11, and so on. But now we're going to filter out all the multiples of 3, which in this case is going to filter out the number 9, the number 15, and so on. So this way now basically this is the step which performs this idea of the algorithm to filter out or to use a CF for all the elements that are divisible by our next prime number. So now we can simply return here a pair that contains p and the possible primes after p. And again, I'm going to use the infix function too. So I'm going to say p to possible primes after p. So again, if you think about the first iteration here, we said that p is going to be 3. Possible primes after p, so after 3, are now going to be all the elements from before, minus all those elements that are divisible by 3. So that's going to now contain 5, 7, it's not going to contain 9, it's going to contain 11, 13, it's not going to contain 15, and so on. So this return value here is the exact same thing as having a pair of p and possible primes after p. If that's maybe more readable for you, it's just a matter of taste. That's the exact same thing. It's just basically two values wrapped into one object. But for now, I'm going to use the infix function here to say p to possible primes after p. So now this way we have this sequence primes, which is a sequence of these pairs. And all the first elements in each pair are the actual prime numbers that we wanted. And the second element in each pair is basically just a helper variable that we use inside here in order to filter out all the elements that cannot be prime anymore. So at the end of the day, we're only interested in the first entries in each of those elements. So we're going to go ahead and map this result, so this sequence, to only the first entry, so it.first. And this way now we basically map this to only the actual prime numbers without these helper variables that we only need inside here for our computation. Now this way you can go ahead and say, for example, print line primes.take10, and that's going to go ahead, and I'm going to have to again use toList here before I forget this again. And this is now going to compute the first 10 prime numbers on demand. And this means also you can now generate as many prime numbers as you want because, well, this is just an infinite sequence, a lazy sequence, which is just going to go ahead and calculate the number of prime numbers that you want. So now here you can see that the first 10 prime numbers are computed correctly as 2, 3, 5, 7, 11, 13, and so on. So this seems to be working. You now have a sequence, an infinite sequence of all the prime numbers. So you can, on demand, just create as many prime numbers as you want. Now again, let's talk about these steps in here and see again what we did. So we start off by selecting the next prime number that is just the next number that hasn't yet been filtered out from our helper variable, so it.second. Then we go ahead and filter out all the elements that are divisible by 3. So filter out all elements divisible by p in this case. And then this way we already have all the data we need in order to return the next element in the sequence. So this is just the next element in the sequence. So after the first iteration, this is going to be 3. So 3 to, well, possible primes after 3, so to say, which will just be the possible primes after 2 that we had in the beginning, minus all the elements that are divisible by 3. And then after that, in the next iteration, after that it's going to be 5, because 4 is not actually going to be in it.second when we come here. So after we had the iteration with 3, p is going to be 5, because it.second here is not going to contain the number 4, which is just because we started actually with possible primes after 2, which starts at 3 and goes on in steps of 2. So 4 hasn't been in here from the start, meaning that it can never happen to have p here assigned to the number 4. So it's going to go on with 5, going to filter out all the elements that are divisible by 5, then move on to the next step where it's going to be 7, and so on. Now I hope I was able to make this as clear as possible. Of course, it's a more advanced example of using sequences, and it makes use of many of the functional concepts that we've learned, like the filter function, the map function. So you can see also that the concepts of functional programming here come together with lazy evaluation, which allows us to create actually infinite sequences, and also with higher order functions, which allow us to write code like this in just a few lines of code. Alright, so I hope this was helpful for you and not too confusing. If you do have any questions about this, just let me know in the Q&A, and otherwise I'm going to see you again in the next lecture. At this point, we're done with lazy sequences in Kotlin for now. I'm going to move on with other types of higher order functions in Kotlin, which also have nothing to do with collections, but just generally useful functions from the standard library. So let's go ahead and create a new file here. I'm going to just call that let and create my main function here again. Now, as you might be expecting, we're going to look at a function called let, which can be very handy, first of all, for scoping and also for working with nullables. Let's first go ahead and look at scoping for now. So let's say we have a file, and this class comes from Java. A file, let's say example.txt, which doesn't exist right now, and we want to have a buffered reader on that in order to read the file. We can do it like this. That's going to give us a buffered reader. So we could now go ahead and store this into a variable like reader here, but actually we only want to perform some operations with the reader, and then we don't want that to be visible anymore down here somewhere. So here reader should not be visible anymore, and you shouldn't be able to use it down there. So let's go ahead and just remove this variable for now, and let's instead call let here, which you can use on any type basically. And then again, this is just a higher order function. So the signature looks like this. It just takes in a lambda function, which can also return a result. But as you know, we can use the syntax without parentheses and just pass in the lambda like this. And of course, for beginners, this looks like a language keyword or something where you can then open up curly braces, like here, for example, for a function. But it's very different. It's just a lambda you can pass in. And you already know this from the basics that we went through about functional programming. And you can also see that in IntelliJ and also Android Studio, it actually highlights those curly braces in a bold font, so you can differentiate those from curly braces like this, which aren't bold and are just curly braces that define a block for a keyword, like for example, for a function in Kotlin. But now what we have here is we can either create a variable name here like reader, and then for example say if reader is ready, we can go ahead and say print line reader.readLine, and that's going to go ahead and read the first line in the file. And of course we can also again make use of the implicit it variable in Kotlin. So we can say file.bufferedReader.let, and then if it is ready, we're going to say print it.readLine. So again, this is also a very readable syntax here using the implicit it variable. And again, we don't have access to the reader anymore outside of this let block. So this is a very useful way to use this for scoping. So scoping means that the scope of the buffered reader here is limited to only the let block, which means there are no side effects, or at least you can't use the reader anymore outside of where it should be used, which is inside here. Now the next thing again is using this for working with nullables. So let's say we have a nullable string again, and I'm going to call that Kotlin for Android. And then let's say you want to perform multiple operations on this object, so you could go ahead and say if string and then the safe call operator is not empty, then you can go ahead, open up the braces, and for example perform string dot to lowercase. But you're even going to run into trouble here because the type of this expression here is actually a nullable boolean, and you can see this down here in the status bar. But for the if expression you actually need a boolean. So what you could do is you could use the unsafe call operator, but of course this just gets messy. And one better way to do this is to use string safe call operator dot let, and then this let block here will only be executed if string is not null. And if it is null, this block will just be ignored completely. So now we can just use if string dot is not empty. And you can see that also we don't need to use a safe call operator anymore. We can just use functions on this object without any concerns about nullability, because the Kotlin compiler knows that once it actually does get into the let block here, string can never be null. And you can see also that the string variable is here marked in green. Not sure if you can see this in the video, but you should be able to see this in your own editor, which means also if you hover over this, it's going to tell you that it has been smart cast to just a normal string, which means it has been smart cast to not be nullable. So this makes it really easy to perform some code only if a variable is not null. And then inside that code block, you can actually just use this like a non-nullable variable, which is of course very nice and much more handy. Alright, so those are two ways to use the higher order function let in Kotlin. Once for scoping, to only have a variable, or for example here a reader, available inside this block, and also to work with nullables in order to execute this block only if it's not null. And at this point in the course you also know what's going on here with the curly braces. You know you're just calling a higher order function here, and that you're just passing in a lambda using Kotlin syntax. Alright, so that's number one of the higher order functions from standard.kt, so part of the standard Kotlin library. And in the next couple lectures we're going to look at two more examples, just so you get used to or accustomed with some of the higher order functions available in Kotlin. Alright, so now that you know about the higher order function let, let's move on to the next one, which is called with. And this one is very useful in order to perform many calls on the same object without having to repeat the object name. And it's also a good way to structure the code in order to see that some of the assignments or statements actually belong together. Now let's take a look at this using the system properties. So let's go ahead and say system.getProperties, which is from Java again. And then you can simply use with, which is always available here as a helper function, which takes in a receiver as the first argument, and then a lambda. So again, we can go ahead and say with props. And then as you know, if the lambda is the last argument, you can just move this out of the parentheses and just write it like this again, which again looks as if it was a keyword in Kotlin, but it's just a higher order function. So now you can do things like list, which is actually a method defined on the props object. So this is actually props.list. But now using with here, you don't have to repeat that property or that object name props. You can just use list system.out, which is going to list all the properties you have to the system.out stream, which is just the console here. You can also go ahead and say property names dot to list, for example, to get all the names of the available properties. And you can, for example, again print this out to the console. And then you would also see that there's actually one specific property which is called user.home. So you could say things like get property user.home in order to retrieve the value of that property. So this now is the exact equivalent of not using with and instead writing props.list system.out props.get property names or just property names .toList and so on. So here you're going to need to use the props variable name for each call you want to make. So with is just very useful if you want to perform many calls on the same object, and then you don't have to actually use the variable name for each of those calls. This is often useful if you have some kind of longer initialization or some transactions with a database, for example, where you want to perform many calls on the same object. And so this way you don't have to repeat the name, so it's a bit more concise, but it also groups all the calls together into a block here, which also improves understandability because it just groups this logical set of statements into one. So that way anyone reading your code is able to tell that these statements somehow belong together. Alright, so just for the sake of completeness, I'm going to actually go ahead and run this one in order to see the output for this. And as you can see, it's going to come back with a lot of output, starting with all the properties that you have. Then it's going to go on with here all the names of the available properties. That's property names to list. And get property user.home for me is just going to refer to this path on my system. Alright, so I think this is fairly easy to use. So whenever you find yourself writing lots of calls to the same object, you may want to think about whether this might be more readable and also maybe more concise using the higher order function with. Alright, so in this lecture we're going to look at one more example of, let's say, this kind of higher order functions in Kotlin. And the last one I want to take a look at here is called use. Now use is basically the equivalent to Java's try with resources. So it's a very useful feature in order to avoid the common programming mistake to forget to close a, for example, database connection, a socket, or a file. But let's take a step back now and first take a look at what use actually is and how we can use it. So let's say we have, for example, a file reader that is coming from Java, and you're going to initialize that with the name of some file. So let's say makeSys.txt. In my case, it doesn't exist. And then you can just call .use on this because it's actually a closable. And we're going to take a look at that in a moment. So I'm going to say use. And then again, it's the same kind of syntax. You just pass in a lambda in order to perform some operations using the file reader. So now inside here, you can just make use of the file reader again using it. So you can call, for example, it.readText, which is going to return back a string. You could store that into a variable and just work with that. Let's just say a print line for now. But the important thing to notice here is that this function use is available for all types that implement the closable interface. Now we haven't talked about object orientation yet, but of course if you're coming from Java, you're already kind of familiar with this. So I just want to take a quick dive into what kind of objects you can actually use this on. And to do that, you can simply use Control-N in IntelliJ and then type in closable here in order to find the class or the interface. So let's go ahead and hit enter on this one. And then you can use Control-H to show the hierarchy. And then you can make sure that you're looking at the downwards hierarchy using this button on top here. And this way you can see all the classes that implement the closable interface. And those are exactly the kinds of classes you can use with the use operator or the use function, because all those classes will then be sure to implement the function close, which means that this can always be called on the object that use is called on. So if we look into the implementation of use here, you can see that the type that's passed in here or that it's used on has to be closable. Now don't worry too much about this code if you can't really understand all of it yet. I just want to show you that inside the function declaration here, it actually makes sure that you're calling this on some object that uses the closable interface. So in other words, it's an object that has a close method that you can call, and the file reader is one of those. So what this will do is that use will automatically at the end of the block call it.close, which you might forget otherwise. And of course, again, you also have this kind of scoping in here that the file reader is actually only visible inside the use block. So that way you can be sure that you're only using this inside here in an atomic way. So this way you can't forget to use close, because that's going to be done automatically using use, similar to the try with resources in Java. So you can't run into this common programming error that you forget to close, well, for example, a socket, a file, a reader, or some other kind of closable object. So this also comes in very handy for things like I/O operations or database interaction. Alright, so that's all about the higher order function use. I hope this was helpful to you as a kind of substitute for try with resources in Java. And those are also all the higher order functions of this type I want to take a look at explicitly in this course. And we're going to see how to use them in a more real world example, of course, later on. So as always, if you have any questions about this, just let me know in the Q&A. And otherwise, I'll see you again in the next lecture. Now at this point in this course, you've already used many of the higher order functions that Kotlin already provides for you, and you've also created your own higher order functions. But now in this lecture, I want to take a look more closely at inline functions, just in order to give you the understanding of what inline functions actually do, what kind of benefits they can bring if they're used correctly, and just to explore what kind of inline functions you've actually already used. So to dive into this topic, let's actually go ahead and create our first inline function to get started. So I'm just going to call this inline, and then I'm first of all going to create a very simple function called modify string. Let's say it takes in a string parameter, and then let's say it just returns string to uppercase. Just a simple example. And of course, then I'm going to have the return type string as well. And that's just a very simple function you could use. So now in the next step, let's actually go ahead and make this a higher order function by making it take in a parameter that actually is a function that is going to define how the string is going to be modified. So I'm going to call this operation, and that's supposed to be a function from string to unit. So unit meaning it's just a void function that performs some kind of operation on a string. And this way now you could go ahead inside a main function, for example, and just call modify string on, let's say, Kotlin is amazing, and then pass in a lambda expression here, like for example it.toUppercase. And of course I should now change the function body here as well to just call the operation on the given string. And actually we should go ahead and make the operation here return a string again, so that we can also have the return value of string. So this makes this method much more reusable, because I can perform some kind of operation here to uppercase, to lowercase, or whatever I want. Of course, this is still just an example you wouldn't use in practice, because you can just call that method on the string directly. But just for the sake of this lecture, we're going to try and create our first higher order function here. And now we want to talk about inlining functions. Now this way that the function is currently defined with the operation, it's going to have to create an anonymous object for each invocation of the function, just like you sometimes do in Java when you create anonymous classes just to override, for example, a listener. Now this can be a lot of overhead in many cases, like here for example, where you just want to call the operation on the string. It might actually improve performance a lot to just inline this call, meaning that the compiler will basically replace any call to this function here with just the body of the function. And this way then, basically before the code is run, it will just replace this part of the code here with the actual function body, which means that no more anonymous objects are necessary and there's not going to be as much runtime overhead. And the way we can achieve this to make this an inline function is to simply prepend the inline keyword here to the function, and that's all we're going to have to do in order to make this change. Now this only makes sense if it's a higher order function that actually takes in some operation here or some lambda that can then be inlined in order to, well, not have to create an anonymous object for this lambda. Now one more thing you can do if you have multiple lambdas you take in, you could also go ahead and say that one of those shouldn't actually be inlined. You can use the no inline keyword for that. But if I do that in this case where I only have this one lambda that could possibly be inlined, then you can see that the Kotlin compiler will already complain because it says that there is no performance benefit with high probability to using the inline keyword here, because basically I'm going to say this should be inlined, but the only thing that could be inlined here, I'm telling the compiler again to not inline this. So the compiler is going to get back to me and say, what am I supposed to do? If I'm not going to inline this operation here, there's nothing for me to inline. So in this case, it wouldn't make sense to add this here. And then of course, it would also not make any sense to have no inline there. But if you have multiple lambdas, you can with no inline define which of those should be inlined and which shouldn't. Now this already goes very deep into functional programming in Kotlin, but I just wanted to discuss this briefly just in order so that you understand better the functions that you're actually using yourself. So for example, if you take a look at let here, you can see this is also an inline function, meaning that whenever you call let, it's just going to inline the function or the lambda that you pass in, and in that way it's going to avoid any performance overhead from anonymous objects. And this works the exact same way for with, for run. There are also other higher order functions we didn't actually take a look at explicitly, like run, apply also, which are all kind of similar. But you can see that all of them are actually inline functions. And in fact, all of the functions here in standard.kt, if you take a look at this, they are all inline functions. And this is because in these cases here for, let's say, with, for example, it would just be unnecessary overhead not to inline this function and to create an anonymous object for this. In other cases, you might want to not inline them so that you're going to have an object at runtime, meaning that you can also then store the lambda to a variable because it's going to be inside an object, or to also pass around the lambda. For those kinds of things, you cannot inline it because you need to have an object at runtime. But in cases like this here, it's very good for performance to just inline all the calls. And of course, the Kotlin standard library is going to do exactly that. So it's a very interesting feature, and I just wanted you to get a quick look at inline functions, but it's not a must for you to understand or especially to use for yourself. It's just important to also understand what's going on internally when you use higher order functions like these in Kotlin. So I hope this was helpful for you to get a deeper look inside the Kotlin standard library and to understand more of the concepts in the language. If you have any questions, again, let me know in the Q&A, and otherwise, see you again in the next lecture. Congratulations, first of all, for making it to the end of this section. You have now learned about functional programming. I hope you have a much better understanding of the concepts of functional programming. If you've never done it before, I hope you now have also a good understanding of what it is, what it's for, why it's actually useful, and how you can use it in Kotlin. So you've seen how powerful functional programming can be in order to write more modular code, writing more concise code, making it also quite readable in Kotlin, and using higher order functions to be able to better compose different functions and therefore also increasing reusability in your code. So you now know why functional programming can be so helpful for us as developers, because it really helps us to write more modular code, more reusable code using higher order functions, also more concise code in many cases, pretty much always, and also writing more readable code in Kotlin, for instance. You also now have a good understanding of how to use lambdas in Kotlin, which will also help you use lambdas in Java 8 or other modern languages. It's not that different. We've even seen how to use lazy sequences in Kotlin, and we've created an infinite list of all the prime numbers, or an infinite sequence of all prime numbers, which I think was a pretty cool example of sequences. And you've also seen some of the useful higher order functions from the Kotlin standard library, more specifically let, with, and use, which we're going to also use later on for Android app development. Now with the contents of this section, you're very much closer to writing idiomatic Kotlin code that doesn't look like just Java ported to Kotlin, which many people do, unfortunately. So you now know how to really apply functional concepts, how to make your code more concise, how to make use of the concepts that you have in Kotlin. And we're going to see in the end, when we actually create an Android app, how to then also use those concepts in order to write much cleaner code for our Android apps. So with this, I want to finish this section, and in the next one, we're going to take a look at object-oriented programming in Kotlin. So thank you very much for watching, and I will see you again in the next lecture. Alright, so at this point you know about functional programming, so it's now time to look at the second major paradigm that's part of the Kotlin programming language, just like Java 8, which is object orientation. Of course, you're very familiar with this concept from Java, but we're going to look again at some of the features in Kotlin that don't exist in Java. And also there are quite some differences actually. There are also many similarities. And of course, we're going to contrast everything again when it's important to how it's done in Java. But there are still quite a few things for you to learn in this section, even if you come from another object-oriented language. And this includes features like data classes in Kotlin, just different ways to handle inheritance and different defaults you have to be aware of, different ways to write constructors, different ways to access properties, and there are actually quite a few differences when compared to Java. And you're going to learn about all of them in this section, and it's also a great way to really get a better understanding maybe of object orientation itself and see some of the things that in Java aren't really treated the best way, and which you haven't maybe thought about up to this point. But when you see how it's done in Kotlin, in many points you're going to see that really in Java there's a lot of boilerplate code, which is just unfortunately the way it is. But in Kotlin we can do it a lot better. We can write more concise code, get rid of lots of the boilerplate, and with this I think we can just dive into the actual code and see how Kotlin actually does things better than Java. So thank you very much for watching. If you have any questions along this section, of course, ask me in the Q&A at any time. And for now, I think we're ready to dive in. So I'm going to see you again in the next lecture. Alright, so what could be a better start into the topic of object orientation than the most fundamental concept that object orientation actually revolves around? So let's go ahead and talk about classes in this first lecture. So for the purposes of this section, I'm going to go ahead and create a new package here, just called OO for object orientation. And I'm going to go ahead and create a new Kotlin file here, call that one classes. And then let's go ahead and see how we can actually create a new class in Kotlin in this file here. Now, first of all, classes are conceptually the same as in Java, and the syntax is also very similar. We're only going to take a closer look at some of the differences when we get into more advanced topics later on. But for this basic class here, or this basic example, it's going to be very familiar to you coming from Java. So let's go ahead and start off with the class keyword, just like in Java. And then you can define any name for the class you like. And you also do this in camel case, so like you would do in Java, as you're used to. So for example, the class empty here. And I just want to use this one to show you that if you have an actual empty class, which seems like it doesn't make much sense at this point, but we're going to take a look later on, and you're going to see that in some cases, which at this point might seem a little pointless, but you're going to see later that in some cases you don't really need a class body in Kotlin. And if that's the case, then the curly braces here and the class body really are optional. So you can see that if I remove those, the compiler is not going to complain. So I could go ahead and create a new object of this class by calling the constructor that's implicitly there, just like in Java again. And you can also see that in Kotlin, we don't actually have any new keyword. You can still clearly differentiate calls to a constructor because in contrast to functions, your classes will start with an uppercase letter. So it's really not necessary to have a new keyword. Of course, if you do want to do something or add something inside the class, you can use curly braces just like in Java and then move on inside the class body. And of course, that's what we're going to take a look at in the coming few lectures. So let's go ahead now and see what we can actually do with these classes and how we can give them some meaning. So in this lecture, let's go ahead and see how we can fill our classes with properties and also how to then define the getters and setters explicitly. So for this, I'm going to go ahead and create a new file here and call that properties. And I'm going to go ahead and create a class city in this case, which is now actually going to need a class body here to contain the properties. So let me first go ahead and create a property called name. And I'm going to say that should be a string. But you can see here that now in this case, since this is a non-nullable type, we're going to have to give a value to this variable. In Java, if you were to do something like this, well, it's implicitly nullable. So in Java, it would be equivalent to having a nullable type and just assigning null by default. But that's not what we want to do here. We want to avoid nullable types as far as possible. So let me go ahead and just say this is a non-nullable string and just set it to an empty string for now. So with this, we now have our first property in a class. It's a mutable one and it's of type string. And in this case, it has to be mutable because, well, currently we haven't had lots of concepts, so this is not how you would normally do this in practice. So we're going to have to make this mutable in order to be able to actually set a useful name and also, let's say, a useful population later on, because now this way you could go ahead and use this class to create, let's say, the city of Berlin, and then just call berlin.name, set that to your name of the city, and then also setting the population here to, in this case, 3.5 million. So 3.5 million. And then you could go ahead and print that out just to test that everything's working as expected. And now I think I have to go into some of the things that you might be wondering about coming from Java. Because with properties, we're already running into something that's very different in Kotlin than it is in Java. So in Kotlin, you only have properties and not fields. Now the way you can imagine this is that this property here is like a field in Java, so a string attribute in your class, but it also has getters and setters defined by itself or automatically. So when you go ahead and say berlin.name equals Berlin, then you're not actually accessing the name attribute directly like this syntax would do in Java, but instead this will implicitly call the setter of the name property in order to set it to the value. And similarly, if you go ahead and use berlin.name here, it's implicitly going to go ahead and call the getter of the property. So don't worry about this notation here. I know in Java this would be a very bad practice to access the attributes directly instead of having getters and setters. But in Kotlin, these are properties. So implicitly, this is actually a call to a getter, and this is a call to a setter. So now at this point, of course, the question comes up, how can we actually override the getters and setters? And the way you do this in Kotlin is you can go ahead and after defining the actual property here, you can go ahead and define get. You can also see that you get the autocompletion in IntelliJ here. And now what you have to understand at this point is that every property in Kotlin or every property in a class has an implicit backing field in which it stores the actual data. And when you define the getters and setters, you can access that backing field using the implicit field variable here. So get here in this case will just return the stored value. And this is actually the default implementation for the getter. And also let's go ahead and see how to define the setter. So for the setter, you have a parameter here, which is just called value by default. You can also give it some other name you want. And then the default implementation here would be just setting the field to the value. So again, we're going to use the backing field here that's used inside or internally in the property to store the actual value. And we can set this to the new value. So now this way, this will basically not change anything because these are the two default implementations. And if I go ahead and run this one, just to give you an example, we're going to get the expected output. So now just to verify that the setter here is called implicitly in this line, let's actually go ahead and check that the value that we get is not blank. So it's not just an empty string or a string that only contains white space. And only in that case, we're going to update the value. So let's go ahead and say we set the name to Berlin and then try to set the name to just 2 spaces. And now let's see what's going to happen in this case. So you can see that still we get the output Berlin for the name. So this line here is going to actually update the value, but this one here again is implicitly going to call the setter. And since this value is just blank white space, it's not actually going to update the name of the city. Alright, so this is one way you can define properties inside your class, but this is not the way you want to do this most of the time. It's kind of the Java way to define all your members in, well, kind of list at the top of your class. But we're going to see a better way to do this in most cases in the coming lectures, because this is not the way it's done in practice normally in Kotlin. Most of the time you can define your properties right inside the constructor. So let's move on now and take a look at how to do that. Alright, so we've seen how we can add properties to our classes, but in many cases we actually want to have constructor parameters to take in data like this, so we don't have to call or modify the properties like this. So let's go ahead in this lecture and create a new file to look at constructors in Kotlin. So for the purposes of this lecture, I'm going to go ahead and create a new class called country. And then in the parentheses here in the class header, we can now define the constructor parameters. So let's say we want to have a name, which is of type string again, and we want to have the area in square kilometers of type int. Now this way we can again go ahead and create values in our class. So let's say string. And for now again it's going to complain that we don't initialize them, but we're going to solve this in a second. So this is very different from Java again, because we can define the constructor parameters right at the top with the class definition. But now the question is, how can we actually define what's going to happen in the constructor? Now the way you can do this is you can create a so-called init block here. So you're going to use the init keyword, and this is the code block that's going to be executed whenever a new object of that class is created. So in other words, when the constructor is called. And inside here we could now go ahead and do it like it is done in Java. And we're just going to do this for now. We're going to see how this is done in a more concise way later on in Kotlin. But for now, let's do it the Java way and say this.name is name and this.area is area in square kilometers. So this way now we initialize our class properties with the argument values that are passed into the constructor. Alright, so this should now look somewhat familiar to you from Java, but it's not the way we want to do this in Kotlin. Now actually we can just use the IntelliJ refactoring, because you can see here that we have some gray squiggly lines. So this means that IntelliJ has a suggestion for us, and if we press Alt Enter we can take a look and it's going to say join declaration and assignment. So let's go ahead and just do this for now, because we're actually going to end up with the way we want to do this in Kotlin. So the first kind of simplification is that we don't actually need the init block. We can just use the values of the constructor parameters right inside the property declaration. But now we can go one step further and actually go ahead and say move this to the constructor. Now the only thing this is going to change is it's going to add the val keyword in front of the constructor argument. And I'm actually going to go ahead and do the same for the area, where it looks like the suggestions for move to constructor only exists if the variable names are exactly the same. But again, we can also go ahead with the variable name here, so area in square kilometers, which is actually also clearer. So this way now we have our constructor defined, And we basically upgraded our constructor parameters here to properties by prefixing the val keyword. Now this means we can not only access them inside our class in order to, for example, define some functions. So let's say print should be a string that just prints out the name and then the area in square kilometers. So here we can now simply use the properties from our class. And similarly, if we go ahead and create an object of that class, so let's say, for example, Australia, then you can now go ahead and actually pass in values inside the constructor, or well, more precisely, you have to pass in values. So for example, the name is Australia and the area here is 7.7 million. And then you can also again access those just like you did in the last lecture to, for example, access the name and to access the area. Now notice that we use the val keyword and not var, so you don't actually have a setter in this case, so you can't go ahead and say name equals something else, because it's going to go ahead and complain that val cannot be reassigned. So let's get rid of this. So this is the way you want to do this most of the time, because, well, many times the constructor parameters should also be properties of the class. So whenever in Java you just go ahead in your constructor and say this dot member equals member. So whenever in Java you go ahead in your constructor and just say this dot A is A, this dot B is B, and so on, you can simply do this right inside the class declaration line here in Kotlin. So again, this saves a lot of boilerplate code and makes your code much more concise and readable. Now, one last thing I want to mention here is you can also have multiple constructors like you do in Java. In that case, you refer to this constructor you define up here as the primary constructor, and you can define any number of secondary constructors by just using the constructor keyword, then defining the variables or the parameters like you do in any function. But one thing you're going to have to notice here, and it's also going to tell you down there in the bottom left, is that you always have to delegate to the primary constructor if you have one. So in this case, if we have a secondary constructor that only takes in a name, we're going to have to delegate to the primary constructor which takes in the name, so we can pass that on into the primary constructor. And now for the area, we might just want to go with the default value of 0. And also you can go ahead again in curly braces and define some kind of logic you want to happen when the constructor is called. So let's say just a print line here as an example. Now once you have this, you can go ahead and create, for example, a new value. Spain is country. And now you have two possibilities here that IntelliJ is also going to show you. You can go ahead and only put in a name, so Spain for example. And then you're going to have to live with the fact that you don't actually know the area of the country. And also you won't be able to set the area anymore because it's a value and not a variable. So if you go ahead and print out Spain.name, that's going to come back with name, but the area is just going to be 0. And we can see that if we run this, it's going to come back here with Australia, 7.7 million. Then you can see the secondary constructor here is called, and then we're going to print Spain and 0. So if you ever do want to have different constructors, you can use secondary constructors here by prefixing the constructor keyword. And notice that you also have to always defer or delegate to the primary constructor. But in many cases, this won't actually be necessary in Kotlin, because in contrast to Java, where you often use this for the so-called telescoping pattern or anti-pattern, where you have a similar case to this, where you have a different amount of parameters. So you have constructors taking only a subset of the arguments of another constructor, and you always just keep delegating to a constructor with more parameters and some default values like we do here with passing in just 0. This isn't actually necessary in Kotlin because we're going to have the possibility to use default parameter values, but that's a topic for another lecture. For now, just notice that you can use secondary constructors, but some of the use cases where you use this in Java aren't actually relevant in Kotlin. Alright, so that's all about constructors for now. You can simply define them in the class declaration line here. you can basically upgrade the constructor parameters to properties using the val or var keywords. You can use the init block to perform some further logic when the constructor is called, and you can use secondary constructors using a constructor keyword and delegate to the primary constructor if you have one. So thanks for watching, and I'll see you again in the next lecture. So at this point, you know how to add data to your classes in the form of properties, either by using them in the constructor directly or declaring them in the constructor directly, or by adding them inside your class as properties that are independent of any constructor. But this is only one part of classes, so in this lecture we're going to take a look at how to add methods to your classes in order to add logic and not just data. So again, I'm going to create a new Kotlin file for this called methods, and for this I'm just going to go ahead and create a class robot, and it only has a name of string. And notice that I'm actually making this a property using the val keyword. And now methods are again conceptually the same as in Java. They're just functions inside a class that can operate on the data of the class, can have a return value, and so on. And you can declare them just like normal functions. The only difference is that they are inside a class. So you can go ahead and say fun again, and then for example greet human. For this one we're going to have no parameters, but you could have parameters in here like an a of type int, just like with the normal function syntax. And then in curly braces you can define the method body. In this case, let's go ahead and say print line hello human, my name is, and then print out the name of the robot. And remember that again, you have the return value of a method behind the name. So for instance, this one has a return type of Boolean, and it's just going to return name is not blank. And in that case, we're going to say that the robot knows its name. So you can see that inside the methods, you can of course just refer to all the properties in the class, operate on the data. You could also mutate the data if it wasn't a immutable value using the val keyword. But generally, you might also have classes that actually mutate the data, and the methods are normally the place where all the computation takes place. But notice that this is not the way you would go ahead and define getters and setters in Kotlin, because remember you do this by just using the get and set methods right after the property declaration. Alright, so now we have some methods defined. So whenever we create a object of the class, like for example a fight robot, which is a robot with the name of destroyer 9000, then you can go ahead and use that object to call any of the methods on it. So for example, greet human, and this actually only makes sense if the robot knows its name. So let's go ahead and say if fight robot knows its name, then we're going to go ahead and say fight robot.greet human. And of course, just to demonstrate this, let's go ahead and run this to see the output. And as you would expect, this is going to come back and print out hello human, my name is destroyer 9000. Alright, so I think this is a rather simple topic for now because you're already familiar with methods from Java. You already know all the syntax you need from just normal functions. You just now put them into a class. And you're also familiar with the syntax to call a method from Java. So now in the next lecture, let's actually go ahead and take a look at another concept that doesn't exist in Java and that's completely new to you. Alright, I hope you're excited for this lecture, because in this lecture we're going to take a look at extension functions in Kotlin, which is probably one of the most important and most powerful concepts also for Android app development in Kotlin when compared to Java. So let's go ahead and create a new file again, and I'm going to call this extension functions. Now with extension functions, you can basically extend the API or the interface of any class you like, and you don't actually even need access to the source code. You just need access to the binaries, and you can then just add a new function to any class you like. Now this is a very powerful concept
that allows you to get rid of any utils classes that you're probably very familiar with from Java. So things like string utils, date utils, the arrays and collections classes, which are also just util or helper classes, which often come with just loads of static methods in order to, for example, create objects of that type or just perform some kind of method that's just very useful for example, the date class when you're using date utils, but it just wasn't defined on the date class. So you're going to have to create that very separate class, add a lot of methods to that in order to work with dates more usefully. But then you also end up with code like date utils dot some method on my date, and that's just not very readable. What you actually want to do is you want to say my date dot some method. And we can actually go ahead and achieve this in Kotlin with extension functions. So let's go ahead and say, for example, that we want to extend the int class and just add a new method on it called isEven, which is just going to return whether an integer is even. And we can do this very simply by just using the fun keyword again, because we're defining a function or method, and then using the class that we want to define this on, put a period here, and then define the function name, so isEven. And now it's just the same way as any function we want to define. You could add a return value here and define this explicitly, in this case a boolean. And you can also use the shorthand syntax in this case. And now the way you can define to the actual integer you're talking about is by using the this keyword that you also know from Java. And just say if this modulo 2 is 0, then you're going to return true and otherwise false. So this is already the whole extension function. And of course you could again get rid of the explicit return type here because it can easily be inferred by the compiler. And then you can go ahead and say, for example, let's say print line 5 dot isEven. And you can simply do this with any integer value, just like you could go ahead and call any other method like div, for example, to divide, inc to increase, and so on. So now you can also use the isEven function that you just defined. And this also means that you can use this in higher order functions. So let's go ahead and say we have a list of just some kind of numbers. I don't know, just random numbers, doesn't really matter in this case, some odd, some even. And then say print line naturals dot filter, and then you can actually go ahead and say it dot isEven, because it here refers to an int, and we now have our extension function we can call. So now you have very readable code again. Naturals dot filter it isEven. I mean, it doesn't get much more readable than that. So now let's go and take a look at doing this for, well, one of our own classes. Of course, you could also extend this inside the actual class definition, but just to show you that you can do this with any class you like. Let's say we want to do city.isLarge, and then we can just access any of the properties inside the class, like for example population, and we want to check that the population is greater than 1 million, and then we're going to return that a city is large, and otherwise it's not going to be large. So if I go ahead and create some value for a city here, let's say Austin, then define the name Austin. And remember, this is not the way you actually want to do this in practice. It was just the example class we created before we actually talked about constructors. And here the population is actually 950,000. So if you print out Austin.isLarge, then by our definition is actually going to return false. So you can see here we have the output false for 5.isEven. Then we have naturals.filter it isEven, which is only going to let the 2, 8 and the other 2 remain. And then Austin, by our definition here, is not a large city. Alright, so very useful, very powerful concept, extension functions here, and also very easy to use. So this is going to give us a very powerful feature or possibility to work around any limitations in the Android APIs that we come across. So anytime we're missing some method on a class that would actually be very useful, we don't have to create some utils class to do that, we can just define our own extension function and then use that in a very natural and consistent way like any other method on that class. So I hope you really like this feature. You're going to see how powerful this can be later on when we're actually applying this to Android app development. But that's actually also all about it because it's very easy to use and you already know how to define functions. So that's all you need to know for now about extension functions. Thanks a lot for watching, and if you have any questions about this left or about any other topic in this course, as always, just ask me in the Q&A. Thanks, and I'll see you again in the next lecture. In this lecture, I want to talk about another completely new feature or concept in Kotlin that doesn't exist in Java. And that concept is called data classes. Now, data classes are a very useful concept that's again also very helpful to make your code much more concise in some circumstances and also much more readable. So let's go ahead and take a look at what data classes are, how you can define them, and how you can use them. So I'm going to go ahead, create a new Kotlin file. I'm going to call it data classes. And then I'm going to go ahead and, just to recap, create a normal class here called address. And the address class should have a value street, which is going to be a string. We also want the number of int. We want the postcode, which I'm also going to store as a string, and the city, where I'm also just going to use a string for this case. So now with this, we actually already have a quite useful class. So we can go ahead and create a new object of this, but it's not yet a data class, it's just a normal class. But you can already go ahead and say, for example, residence is address, and then let's say Main Street 42 in 1234 New York. And you could now go ahead and read any of those properties to work with them. And again, implicitly, this is going to call the getter. But now let's go ahead and go actually one step further. And to do that, I'm just going to create a data class, and it's very simple to do that. You just prefix the data keyword here. So you're going to say data class, address in this case, and now let's see what happens. So this will now generate a hashcode method and an equals method and a toString method. It's also going to create a useful copy method. You can use a destructuring operator that we're going to look at, not a destructuring operator. So it's going to go ahead and generate lots of stuff for you that you normally go ahead and generate with the IDE in Java, which of course doesn't take a lot of time, but the problem is that it's just a lot of overhead to go through if someone's reading your code, when compared to just one line of code. You know it's a data class, you know it has 4 attributes, and in Kotlin you also know you can use this, you can compare them, copy them, and so on. So with this now you can go ahead and say you can print line the residence because you have a useful toString method. You can go ahead and check if, let's say, I create another residence 2 with just the same attributes but it's a different object. You can go ahead and check for referential equality using 3 equal signs. Or you could go ahead and just check for structural equality using the double equal sign. So notice here that the triple equal sign is the same as just double equal in Java. So it's going to check for referential equality, whereas the double equal sign is going to look for structural equality, which is the equivalent of calling the equals method in Java. So let's say equals. And as I mentioned, this will also be generated from the data class keyword, just like you can also do it with an IDE. Now next, as I mentioned, there's also a copy method. So you can go ahead and say neighbor, for example, is residence.copy. Now without any parameters, it's just going to make a copy of the whole residence where all attributes are the same or all properties are the same. But you can also see you can define any of the properties you want. So you can also go ahead and say number equals 43. Now we're going to look at name parameters in more detail later on, but this way you can define only this one parameter number, set it to 43, and then it's going to be the same address with just one change in the actual number. So this is something you can do in a similar way in Java, but in Java the clone method that exists, so the clonable interface, is something you have to be very wary of, because oftentimes it's not implemented correctly, and you have to assume that all your parent classes implement it in a correct way so that you can also implement it in a correct way. Now the last thing I want to mention here is the destructuring operator, which you're not familiar with from Java, but you may be familiar with it from Python, for example. So if we have our residence, you can see that we have methods called component124 in this case. So they're named very generically and you don't normally call them like this, but they do exist because in this case we have 4 properties. So component 1 here is the street, then we have the number, postcode, and city. So you could go ahead and call one of them, but the way you normally use this is you go ahead and say val, and then let's say we want to store each of the values from our data class into specific variables. So we want to have street, number, postcode, and city. And now we can simply set this to residence so that each of the properties is going to be stored in the appropriate variable. Now, if you're not interested in, let's say, the postcode, you can also go ahead and just put a underscore here to basically ignore this entry. But for now, let's go ahead and say we want to store each of those. And then you can go ahead and use all of them to print out, for example, street without a comma, number, then postcode, and city. So this way now, let's go ahead through each of the output that this gives us step by step to see how this works. So first of all, you can see here we have address, where street, number, postcode, and city are all printed in a nice manner. So that's the toString implementation, the standard toString implementation of a data class. Then we have referential equality here with the triple equal sign, which is false because residence and residence2 here are different objects, so they point to a different place in memory. But when checking with equals, so when checking for structural equality, we get true because each of the entries is exactly the same. Then moving on here to the neighbor declaration, you can see it's the same kind of object. You still have the toString method, but just the number is 43. And then lastly here you can see that each of the properties or the values stored in the residence has been assigned correctly to each of the variables. So we get here the street number, then a comma, which we have here, and then postcode and city. So you can see that it's very effective to work with data classes in Kotlin. And in a normal code base, you often have many classes like this where you just want to store some data and which don't actually have much logic. Now you can also go ahead and create a class body for this. You can define some kind of methods in here. It's no problem at all. You can also add logic to this. But in many cases, you also just want to create a data class to store some properties that belong together. Maybe also just to define a more readable or expressive return type. If you want to, for example, return some kind of string and an integer that somehow belong together, you can create a new data class for those with a useful name in order to group them together. So if you think about how many lines of code the address data class here would be in Java, it's really ridiculous to think that in Kotlin you just have to write this one line of code and it's going to generate all the rest for you. Now, as I mentioned, the major benefit of this is not to save time when coding, because you can generate most of the stuff like hash code equals to string and so on with your IDE in a matter of seconds. But it is a very important issue when talking about readability of your code, and when someone else goes into your code and has to go through the data class and first check whether really all of the methods are just getters and setters, which by the way are of course also implicitly created here, like we also have for normal classes because we have properties here. So all of those, hash code equals to string, and you don't really know anymore if you maybe have made some manual changes to any of those. So you really have to go through all of the code to see whether it's just the generated code or maybe there are some manual changes in there and so on. So it takes a lot of time and it's much less readable and less maintainable than just having this one line of code. So again, this is another very powerful and very useful concept in Kotlin that, as so many other features in Kotlin, help you make your code more concise, more understandable, and also more robust in a way. So I really hope you liked this lecture and you like data classes, extension functions, and so on. If you have any questions, again, just ask me in the Q&A, and otherwise I'm going to see you again in the next lecture. Alright, so after all the awesomeness with extension functions and data classes in Kotlin, in this lecture we're going to slow down a bit again and just look at enums, which are a concept very familiar to you when you come from Java, and it works very similar in Kotlin. So let's go ahead and take a look at how this actually works exactly. I'm going to create a new file again called enums, and then you might already guess that you have to use the enum keyword. But in Kotlin, you actually also have to use the class keyword, which is kind of consistent with data class, for example, where you also have the data keyword followed by the class keyword. So in contrast to Java, you don't just use enum, but you use enum class. And then you can, for example, give it the name direction, open up curly braces, and define all of the possible enum values. So in this case, that would be north, east, south, and west. Now you can also go ahead and give them some value, like let's say degree of double, and then you would go ahead and have to put in the values here, like in a constructor. So let's say 180 for south and 270 for west. But in many cases you don't actually need those. So you can just create an enum class without any constructor parameters, like for example also suits, which could then for example be hearts, spades, diamonds, and clubs. Notice that of course you write them all uppercase because they're constants, like you would also do it in Java. So enum classes in general are very useful when you have a distinct set of finite elements you want to distinguish, like here the 4 suits. Those are all that exist and that will ever exist, and also directions here, which are 4 directions you want to distinguish between in your app. So you can simply define them as an enum class in order to work with them in your code. Now these are very useful, particularly when you want to use them in a when construct. So let's say, for example, we have a suit. So actually we might have a card that has a suit as a property. So this is called suits.spaces. Sorry, not spades, of course. So my suit is suits.spades. And then I can go ahead and define a color here as the result of a when expression. So when my suit is, let's say, hearts or diamonds, then I'm going to return red. Sorry, this has to be an arrow like this. And on the other hand, if it's either spades, not spaces, spades or clubs, then I'm going to go ahead and return black as the color of the card. And now the important thing to notice here is that when the variable inside the when expression here that you, switch on is an enum class, then the Kotlin compiler will again infer if your case distinction is exhaustive. So if you use all the different possible enum values here like I did, all the 4 values, then it's not going to have an error here, and you don't have to create an else branch because Kotlin can infer that no other cases are possible. So an else branch here would just be unnecessary because it can never run into that. But if I were to have only 3 or 4 cases used, you can see that when expression must be exhaustive because I'm trying to assign the return value to a variable here, and otherwise the question would be what kind of value should be taken for color. So in that case I would have to use an else branch. But the power of enums here is that the Kotlin compiler can infer if you handled all the cases, because it can simply look at the enum declaration and see if there are any more possible values. So it's again a very useful way to always have a defined value for a case distinction here, and in this case for the color. Let's just go ahead and use the variable as well. So this is just another case where the Kotlin compiler is quite clever. and can help you avoid unnecessary code like an else branch in this case. Alright, so that's all about how to create and use enums in Kotlin. Again, in this course, I'm going to assume you are already familiar with enums and have probably used them a few times before, so I'm not going to go too much into detail on when to use them. I mentioned briefly when you have a distinct set of different elements you want to distinguish in your code, but in this case, I focus more on the syntax in Kotlin, the differences to Java, and then also implications for other language constructs, like in this case, the when statement. So with this, we already have quite a few different elements to design our system using normal classes or data classes or using enums. So it takes a bit of practice to know when to use which of those. And of course, I'm going to try to explain this again in more detail when we actually go into Enroll app development to see when you would use which of those concepts, data classes, enum classes, or just normal classes. But for now, let's move on with object orientation in Kotlin to really dive into the language itself so that you have a solid understanding of Kotlin and can use it for any application you like, not just Android apps. You can use it to create desktop applications, to create console applications, anything you like basically. And it's just getting more and more widespread with Kotlin native and so on. So really, I want you to get a solid understanding of the language itself first. And then Android app development is just one particularly interesting application of the programming language. Alright, so thank you very much for watching, and I'll see you again in the next lecture. So now that we've seen classes, which are the main concept in object orientation, and then we've also seen how to actually fill classes with properties and methods, and also that we've seen some special types of classes, like data classes, enum classes, let's now in this lecture move on to the next central concept in object orientation, which is inheritance. Now, inheritance means that we can have so-called child classes which inherit properties and methods from their parent classes. And this allows us to reuse code from parent classes because all the properties and especially the methods, the implementations of the methods, are inherited to all the child classes. So this way, this allows us to avoid code duplication because we can inherit functionality from parent classes, and therefore it can also increase maintainability if it is used correctly. So if done correctly, object orientation is basically programming of deltas, so of differences, because all the similarities are already encapsulated in the inheritance structure and in parent classes. So the way this is normally used is you have some more abstract parent classes which become more and more concrete when going down the inheritance hierarchy. Now, to make this more tangible, let's actually go ahead and take a look at how to use inheritance in Kotlin, meaning how to create parent and child classes. So I'm going to go ahead and create a new file here again, and I'm going to call that inheritance. And now I'm going to first go ahead and create the simplest class declaration you can probably do, which is just class base. So as you remember, if it's an empty class, you can actually also emit the curly braces, they're optional. And now let's say this should be a parent class, and I want to create a child class of this. So just to create a minimal example. So here this is just going to be a minimum example just to really look at the syntax. Now in Java you could just go ahead and say class child extends base. Now the way the syntax works in Kotlin is you use the colon, which works the same way as the extends keyword in Java and also the same way as the implements keyword in Java. So there's no differentiation here between the two. So I'm just going to say colon base and then add parentheses here to call the default constructor of the base class. But now you're going to see that this gives an error because in Kotlin you can see that types or classes are by default final. So this means you can't inherit from this class unless you specifically say so. And the way you do this is you declare this class as an open class, and only then can you inherit from it. And now the important thing here is again the rationale behind this decision in language design. Because in Java by default all classes are open or you can inherit from them, but in Kotlin, all classes are by default closed, so you can't inherit from them. Now at this point, I would actually like to ask you to post in the Q&A if you have ever declared a final class in Java, so whether you've ever used the final keyword in front of the class keyword in Java. And if so, if you've done this, whether you also always think about whether a class should be inherited from or not. That would just be an interesting question to see, because it's very good if you do so, if you always think about whether that class should actually be inherited from or not, but most programmers don't. So that's why the decision was made in Kotlin that you have to declare your class as open. And for this reason, you're also going to have to explicitly think about whether you actually want that class to be inherited. And in that point, when you do make it open, you're also going to have to think about whether you're going to have to do something to really design your class for inheritance. Now, this is a very important principle that's also promoted by Joshua Bloch in his book Effective Java, which I can very much recommend. He's one of the people who worked a lot on the Java language, who's contributed a lot to the collections API and so on. And one of the points he mentions is also to specifically design for inheritance or prohibit it. So in Java, you would have to add the final keyword unless you really design your class to be inheritable. Alright, so what's essential here is just to remember the fact that you have to declare your classes as open in order to inherit from them. And this also goes for any properties and methods inside your class, as we're going to see in the next lecture. So I'm going to recommend we're going to stop here with the basics about inheritance in Kotlin and why we have this difference between inheritance behavior in Kotlin and Java. And in the next lecture, we're going to move on and create a more real-world example just to see how to also work with properties and methods. Alright, so as I promised in this lecture, we're going to take a look at another example of inheritance, which is a bit more of a real-world example using also properties and methods. So let's first go ahead and create a new open class. So we want to inherit from that later on, and I'm going to call that shape. So you can already see that this is a rather abstract word, so it's also a more abstract class, and it's just going to only define all the properties and methods that are shared between all kinds of geometric shapes. So I'm just going to give this a name, for example, and then let's say we have a function area, which for now I'm just going to initialize with a default value of 0.0. So you can see here I use the open keyword for the class so that I can actually inherit from it in child classes, and then also the method area here is open so that it can also be overridden in all the child classes. So now let's go ahead and create a child class of this. So I'm going to call, for example, the class circle, which is of course one specific type of shape. And this has a name just like its parent class, but it's also going to have a radius because that's another important property of a circle. So with this now we have our constructor defined as before. So now again, we're going to use colon in order to inherit from the shape class, and again call a constructor here. So this is basically the equivalent of calling super in your child class's constructors. So we're going to have to delegate to the parent constructor here and just pass on the name. And of course, since I used the val keyword for the radius, this is just again going to be a property of this class circle. So now let's see how we can override the method area in order to return the area of the circle. But now let's actually go ahead and remove the open keyword here just to see what happens if we try to override this now. So now in Kotlin we have the override keyword. So it's not an annotation like in Java, it's really a keyword to override any properties or methods. And we can just say override the function area. And in this case we want to give this another value. But for now, let's look at the error here. It says that area and shape is final. So this is exactly why we're going to have to add the open keyword here as well, because we might have some methods in here which we want to be final. So they shouldn't be overridden in any children, but others we might want to have them open. So we're going to have to differentiate between the two by adding either the open keyword or not adding it to the method declaration. So now you can see the error is gone here. We can now override this method. And of course, for a circle, we're going to return here math.py. So math again coming from Java, times math.pow for the power method. And we're going to return radius squared. So pi times the radius squared. And that's going to give us the area of the circle. And by the way, now the class circle here is again final. So even if it's a subclass or a child class of another open class, so by default, this is going to end the inheritance tree. So there can be no subclasses of circle anymore. There can only be subclasses of shape. So now we can also take a quick look at how to use this. It's very similar to any classes. So small circle, going to create an object of that. And we're going to call the constructor with a name for our shape and the radius for the circle. And then we can again, for example, access all the properties like the name, the radius, and we can also call the area method in order to compute its area. So let's go ahead and give this a run. And you can see here it's going to come back with the name, small circle, the radius, and the area of the circle. So again, you can see here it's very strict. You always have to specify the open keyword for the class itself. For any methods that you should be able to override in the child classes. Also, you're going to have to repeat the process in any child classes here. So it's really going to enforce or force you to think about whether you actually want to allow inheritance. And if you do so, you should also always think about how to design your class so that inheritance actually works fine. Now, by the way, you could also go ahead and override the property here. So you could say override val name. But again, you're going to then have to define this as open. And only then can you also use the override keyword in the child classes. So now you have overridden this value, but in this case it really doesn't make a difference. So you can also just take a name as an argument to your constructor, pass it on to the parent class, and just inherit this property from the parent. Now in other situations where this maybe has some default name or something like that, you might want to override the property in order to change the default value, for example. But in this case here, we don't really need this. But just remember that you can override properties as well as methods as long as they're declared as open. So of course, you can discuss whether this design decision to have all the classes and methods final by default is good or bad. It definitely makes you think more about your code and what you actually want to allow or disallow, and really enforces you to also design your classes for inheritance. Thanks a lot for watching, and I'll see you again in the next lecture. When talking about inheritance, you normally also want to talk about abstract classes and interfaces. So those are the next two concepts that we're going to look at in Kotlin. So first of all, let's actually improve this code that we have here for inheritance, defining shape and circle by using abstract classes. So let me actually go ahead and refactor these so that I can use those class names in the other file. And I'm just going to call those shape1 and circle1, and I'm going to do the refactoring. So now I can go ahead and create a new file here again, and I'm going to call that abstract classes. And now what I want to do when compared to the last lecture, I want to actually make the shape class abstract. And that means I don't actually want anyone to be able to create an instance of the shape class. I only want that class in order to encapsulate the similarities of all shapes I can have, like the circle, for example. But you should only be able to create an object of those child classes, but not of the shape class itself. Let's go ahead and use the abstract keyword here before the class keyword in order to define the shape actually as an abstract class. And then inside an abstract class like this, we can also define abstract methods. So let's actually say that the area should be abstract and it should return a double value. So now this is already an improvement because we didn't have to specify some unnecessary default value like 0.0 like we had before. And we can just say this is abstract. So this can, in abstract class, so this method can never be called by itself. It can only be overridden in child classes. So it doesn't really have to have a value yet, because it's just an abstract class, we only define the interface. So all the child classes will now have to override the area keyword unless they're also abstract classes. So let's see what that means. So if we create a circle here again, I'm going to give this a name like before, and it's also going to have the radius as a double. That's going to be a value. And again, I'm going to inherit from shape and delegate the name argument to the constructor. And now at this point, again, we're going to get an error here. So by pressing Alt Enter, we can also say that we want to implement all the members, because the error here just refers to the fact that the circle class here is not an abstract class. So it's going to have to define or override the area method and define a concrete implementation. So if this class was also abstract, we wouldn't have to do that. But if this is a concrete class, then we have to override all the abstract members of the parent class, in this case, the area method. So let's actually make use of IntelliJ here and just say implement members. And we're going to select the area method. So you can see it's going to add here our code. It's going to say override function area. It's going to return a double. But again, we're actually going to use the shorthand notation to return pi times the radius squared. So let's say radius 2.0. And so this way now we have this abstract parent class, which only defines an interface basically. So it only defines that all the child classes should implement an area method so that you can always get the area of any shape. And then all the concrete child classes will have to override or implement that method. And notice here that abstract classes are by default or implicitly also open, just like abstract methods are also open, because otherwise they just wouldn't make any sense, because the only use for them is to inherit from them. So let's go ahead and just make sure we understand that I can create an object of the class shape with some name because it's an abstract class. So it's gonna say I cannot create an instance of this class. You can only create instances of concrete classes, like for instance our circle class. So here let's say large circle, and we're going to give that a radius of 17, and then we can print out the area of that shape. So whenever you really just want to encapsulate the similarities of several child classes, but don't want to actually let anyone create an object of that class, you can just make use of abstract classes, and they're very similar here again to Java from the syntax. So you just prepend the abstract keyword in front of the class, and then also you can use the abstract keyword to say that some methods are abstract, because you could also have concrete methods in here. So you could also define a method A, which has already an implementation of 1. So in abstract class you have some abstract methods. You can also have some already concrete methods that in this case here also can't be overridden. You can also say they're open. So this way now all the child classes could change the implementation of the method A, but they don't have to. But for abstract methods here, they have to override the implementation. Alright, so abstract classes are a good way to define the so-called greatest common divisor of all the child classes and prohibit any object creation from them. Now in the next lecture, let's take it one step further and take a look at interfaces. In this lecture, you're going to learn how to use interfaces in Kotlin. So basically taking one step further after abstract classes on an even more abstract level. So just like abstract classes, interfaces allow us to define the APIs of a class, so all the methods that should be able to be called on any child elements of that interface or that abstract class. And also for interfaces as well as abstract classes, you can create any objects from them. But again, interfaces are normally even more abstract because they shouldn't really have any implementations for methods, and they also can't have any state. So let's take a look at an example of how to create interfaces in Kotlin. I'm going to create a new file, interfaces, for this, and then I'm going to use the interface keyword, again just like in Java, and I'm going to create an interface drivable. And this drivable interface is just going to define a function drive. Now this is basically all you need for an interface. You could also define more functions in here that should be implemented by all the drivable classes, so all classes inheriting from drivable. But for this, I'm only going to go with this one method here, which is also a kind of common use case. It's also kind of common to have this able suffix for interfaces whenever they define only one specific thing you can do with any of the classes. So here, for example, drivable just means you can always call the method drive. So for example, we could go ahead and create a subclass called bicycle, which inherits from drivable. And in this case here, the interface doesn't have any constructor, so we're not going to add parentheses here like for classes when extending classes, but instead we can just use curly braces in order to define the class body. And again, you can see for now we have an error because we're going to have to override, and actually also comes up with this, we have to override the function drive and create some implementation for this. So let's say just driving bicycle. And similarly, you could go ahead and create, let's say, a class boat, which is also drivable. And in this case, we're going to say override function drive. And we're going to print out, in this case, driving boat. So now it's important to notice here that with interfaces, you can't have any constructors. So you can have something like a name of type string here. Interfaces never have a constructor, which is one of the differences from abstract classes and also normal classes. You can have abstract properties. So let's say we have a property A of type int. And of course, I'm going to have to use val or var here, which just means that all the child classes will have to override this property. And of course, here the abstract keyword is redundant in interfaces, so you can also get rid of this. And now again, we would have to say override val, and it's going to come up here and actually want us to override the getter. So you could say it would always return 42, or you could just do it like this. So you can also have properties in your interfaces, which basically means that all the child classes will offer this kind of properties. So it's also a statement about the interface or the API of all the classes that implement drivable. But here for the drivable interface, I don't actually want any property like this, so I'm going to get rid of it. So this is how you normally use interfaces. You just want to make a statement about what kind of methods are always available. So if you go ahead and create a, let's say, drivable object, which is of type drivable, and you instantiate this to, for example, an object of type bicycle, then at this point here, drivable is not of type bicycle, but we said that the type should be drivable. But still, even with this abstract object declaration, we always know that we can call a method drive on this, because every object of this type drivable will always allow or offer this method drive. So this allows you to work on a higher level of abstractions. So whenever you only want to rely on having something you can, drive, you can just say you want to have this of type drivable, and you don't actually need to force this to be a bicycle. This is one of the common good practices you can use in programming, and I hope this is kind of familiar to you. So when you're only relying on the drivable interface, you can't use any other methods here. So for example, if I make this a drivable, then on this object, I can't actually call this method A here, even though in fact at runtime it is going to be a bicycle here. But since the type is only drivable, it might also be a boat. And on the boat, I don't have the method A. So if I were to declare this also as the type bicycle, then I also have access to the method A, which is specific to the class bicycle. But whenever you don't really need this and you only need to have access to the method drive, it's a good practice to rely on the most general or most abstract interface you can use in order to be able to do whatever you want. So in this case here, you only want to have the method drive. So again, this is just a good practice in programming in general. Now, one last thing I want to mention about interfaces here is that similar to Java 8, you can also define default implementations. So you could go ahead and say in the interface method, driving something, but you should really try to avoid this because it's better to have interfaces really just defining some set of methods that you want to be able to ensure for all the child classes. And if you want to really create default implementations, you can also use abstract classes, which might be more fitting for that purpose. So normally try to avoid default implementations in interfaces if you can. In some cases they can be useful, but in most cases they shouldn't really be necessary. Alright, so from this lecture again, you should take away that you can use interface to declare interfaces. All the functions or methods inside an interface are also open by default because they all have to be overridden anyway. And when implementing an interface, you can differentiate after the colon here between classes and interfaces, because for a class you have to add the parentheses to call the constructor, but for interfaces there's no constructor, so you're just going to write the name of the interface. And then in all child classes you're going to have to implement all the methods that are defined in such an interface. Alright, so this should be a very familiar concept to you from Java. So I'm going to stop here, and if you have any questions left about this, feel free to ask me in the Q&A. So thanks a lot for watching, and again, I'm going to see you in the next lecture. Now we've already seen the override keyword used quite a bit, but in this lecture I want to dive more into some of the rules concerned with overriding. Now first of all, notice that, as I mentioned, it's really a keyword here in Kotlin, it's not an annotation like in Java, so you really have to use the keyword here. If you don't use this, it's going to be in compile error, so Kotlin will check at compile time whether you're using the override keyword or not. And if you declare a method in your class with the same name as a method in the interface, it's going to force you to use the override keyword. So it's always good to have these compile time checks so that you know early on when you have an error like this in your code. But apart from this general fact, let's look at some of the more specific rules. And for that, I'm going to again create a new class here. I'm going to call that overriding. And now let's first take a look at the situation where you're inheriting the same kind of method from two different parents. So let's say we have an abstract class vehicle in addition to our drivable interface. So this abstract class here is now going to define a function drive as well. Maybe it has some default implementation, just saying driving. And it might also declare other methods like an abstract function for honking. And then when you create a child class, let's say sedan, which inherits from the vehicle class as well as from the drivable interface, then you're going to run into the situation where you're going to inherit the function drive with the same signature. So it has no arguments, it has a unit return type, again referring to void. So now in this case you can't differentiate between the two so easily when trying to actually call the parent implementation. So let's say you want to override the function drive here. And now what you actually want to do in here is you want to call, well, super.drive, which in this case here right now is actually still unambiguous. But if I go ahead into the interface here and then actually define a default implementation, because remember we can actually do this. So driving, this comes from the interface. And now let's say we want to actually call that method in our child class, because now at this point it's not clear what super.drive refers to. So super, as in Java, refers to the parent class, but again there are two parents, and then the drive method is not clear which one of those is meant. So what you can do in this case is you can parameterize this super call here by adding the type or the name of the class or interface you want to refer to, and then call the method on that. So you can either say super drivable to refer to the interface, or you can refer to super vehicle in order to call the method on the vehicle class. Now in this case, let's say we want to go ahead with the implementation from the interface. And now we still have an error because we also have to override the function honk, which I'm going to say is just going to outprint line honking. What did you say in your country what it sounds like? So in the main, you could go ahead and now again just create an object of this class as usual, and then call the drive implementation. And of course you can also call the honk method And now if I run this, it's now going to call the default implementation here from the interface. So as you can see here, as expected, we're going to get the output driving from the interface, because that's just the print line statement I used there. And it's also going to return the output for the honk method. Alright, so the first rule is if you have to differentiate between two parents, you can use that by defining the name of the class or interface in angle brackets. Of course, here in this case, this is just a problem we run into due to bad design, because first of all, the drivable interface has a default implementation, which is not great, and also the vehicle class in this case should just inherit from drivable instead of only the sedan child class. So really, in many cases, you can avoid this, but in some cases, you're going to have to use it like this if you ever run into this kind of case. Now, the next rule I want to show you is that you can override a value with a var, but not the other way around. So if I have a val, let's say brand, it's of type string, and I'm going to say this is just empty for now, then I can go ahead in the sedan class and say override, and I'm actually going to have to make this open again for this, and then I can go ahead and say override val, should be of type string again, and just be some brand, let's say. So we want to override here the default value. So I can do this by staying a val. I can also say I want to override this with a var, but what I can't do is if this is a var, I can't just go ahead and override this with a val. Now this is because I can't go ahead in the child class and actually restrict access to this variable, because, well, it's kind of part of the API of the parent class that you have a setter on the brand property support that kind of API, so they're also going to have a setter. So you can't just get rid of that, but the other way around, you can imagine that you're just basically adding a setter in addition to the getter that's defined in the parent class. So this is no problem, just like you can also extend any other methods you want here without any problem. And this is just a special case where you actually extend the API of the class by a setter, which is not available in the class vehicle. And then again, another rule that I also briefly mentioned already is that if you have a concrete subclass of an abstract class, then you're going to have to implement all the abstract functions or methods from the parent class. So if this is an abstract class here, it's going to be an error if I don't have an override statement for this method, unless of course this is also an abstract class. So I mentioned this briefly before. Then you could also go ahead and leave some of those methods abstract, and you're basically deferring the implementation of the honk method to, again, subclasses of the sedan class. Now similar, if you do have a concrete class, but this is not an abstract method, then also you don't have to do anything. Of course, it's going to have a default implementation here, but the normal case is that in abstract classes you have quite a few abstract methods, and you're just going to override all of them in the concrete subclasses, because at that point in the inheritance hierarchy, you actually know what should happen when that method is called, which is not the case in the abstract class. So this is also what I meant by having this kind of abstract classes or APIs at the top of the inheritance structure or hierarchy, and then getting more and more concrete when going down the inheritance hierarchy, because you also have more and more knowledge about how the class should actually behave. So you can then turn abstract classes into concrete classes, turn abstract methods into concrete implementations, and so on. So those are the three rules I wanted to mention here. So first of all, when you have clashes between parent methods, you can use angle brackets to differentiate between calls to the parent class. You can override val with var, but not the other way around. And you have to implement all abstract methods from your parent classes in a concrete child class. So most of these are probably familiar to you from Java, but I hope it was a good refresher, and also again to see some more of the syntax of Kotlin and to really get familiar with the concepts. Awesome, so that's all I want to do about inheritance for now. So now we're going to move on again to some of the really great features of Kotlin which are not already familiar from Java. So I hope you're excited for that, and I'm going to see you again in the next lecture. In this lecture, you're going to learn about smart casts, which are a very nice feature in Kotlin to make it easier to work with inheritance structures and again to avoid boilerplate code. So let's go ahead and create a new file for this again, and I'm going to just call this smart casts. And then let's go ahead and create a main function here, and then I'm going to go ahead again and create an object called vehicle, and I'll explicitly use the drivable interface as the type and then instantiate this to bicycle. So at this point here in the execution, the vehicle object or variable here is always just going to be of type drivable to the compiler, even though it is actually instantiated with the more concrete or more specific class bicycle. So this again goes back to this good practice I mentioned before to only use the most abstract interface you can. But in this lecture, we're actually going to use this to talk about how to differentiate between different types if you have to in Kotlin. So this is what's instance of in Java, and it's just called is in Kotlin. So now at this point here, we can only call vehicle.drive because that's the only method defined on the drivable interface. But let's actually go ahead and say if vehicle is bicycle. So just like in Java, when you check for instance of, it's just that the keyword here is simply is. Then inside here, you will actually now be able to make use of smart casts in Kotlin. But in order to actually see this difference, we're going to have to make some changes, or let's actually just add some extension functions to the bicycle and the boat classes, just so we have some kind of differentiation between the two. So for the bicycle, let's say we have an additional method called replace wheel. I'm just gonna do a print line on that again. And for the boat class, we have start engine, which returns a boolean. So return type boolean, and it's just gonna go ahead and print out starting engine, and then it's gonna return true. So this way now we actually have a way to differentiate between whether we're dealing with a bicycle or a boat. So now when I go ahead here and say vehicle dot to call a method, then you can see that now we also have the replace wheel method here, even though we defined the object vehicle here to just be of type drivable. So in Java, when you have a condition like if vehicle instance of bicycle, then the next line is normally always something like val b is, and then you just cast the variable to a bicycle here. But that's not how you do it in Kotlin. So in Kotlin, you can see that it's going to automatically cast the vehicle object here to a bicycle in this case. And you can also see in IntelliJ, I'm not sure if you can see in the video, but in your editor, you will be able to see that the vehicle object here is also highlighted in green with a green background. And if you hover over it, it's also going to tell you it was smart cast to a bicycle. So the green background always means that a smart cast has happened, because inside this condition here, the compiler can actually infer that vehicle is of type bicycle. So it's safe to call the method replace wheel, which only exists for bicycles. And similarly, you can go ahead and say else if vehicle is boat. Then of course you can similarly just go ahead and call vehicle dot start engine. So in this case, it's going to smart cast the vehicle object to a boat. So this is a very neat feature, but we can actually go a bit further with the examples, which is also going to be a bit of a logic exercise. So let's take a look at this. So what I can also do is I can say if vehicle is boat and vehicle dot start engine, then I'm going to do something that's not really important for us. The important thing here is that in the second part of our condition, the vehicle object was again cast to a boat. Now at this point, in order to understand why this is actually possible, it's important to know that just like in Java, Kotlin will only evaluate the second part of this condition if the first part here is true. And this is actually something that programmers make use of quite a lot. So whenever you have an AND operator in your condition, then Java and also Kotlin are going to go ahead, look at the first expression or the first part here, vehicle is boat. And if that part's already false, it's just not going to go ahead and even evaluate the second part, because if this first part here is false, then the whole condition can't be true anymore. So only if vehicle is of type boat, only then it's going to go into the second part here. So now the Kotlin compiler can again infer that vehicle is indeed of type boat. So again, it's going to be able to smartcast this to a boat so that we can call start engine. And similarly, you could also go ahead and say if vehicle is not instance of or is not boat, and then use the OR operator for disjunction, then you can also actually call start engine, and the compiler can again smartcast this to a boat. Now I'm going to challenge you to think about why this is possible again with the same kind of reasoning that we did for the AND operator here. In case you're already familiar with this, you probably know why this works. But just think about in what cases the second part of the condition here actually has to be executed and in which cases it doesn't. So now the last example I want to do is if vehicle is not a bicycle, let's say, then we're just going to return. So far no smartcast in here, but now after this block, you can go ahead and just call replace real on this. And again, the compiler is just going to smartcast this to a bicycle, because at this point at the execution, the vehicle object can only be of type bicycle, because if it wasn't of type bicycle, it would already have returned at this point. So I think it's just very interesting to see how clever the Kotlin compiler actually is, and in what kind of cases it can infer the type of an object, and will then just help you with smartcasting the variable so that you don't have to write that kind of boilerplate code. So again, this increases readability. It also makes your code more concise, more understandable. So it's really a very nice feature, and well, there's really no drawback to it. Alright, so what you should take away from this lecture is that instance of is called is in Kotlin, and whenever you have to do this, make sure to remember that Kotlin can use smartcast, so whenever you have something like this, there's no need to cast the object yourself. Just make use of smartcast and call the method you want to call. And also I think the other takeaway is just that the compiler is quite clever and can infer in many cases where it's possible that an object has a specific type. So that's all for this lecture. Thanks a lot for watching again. If you have any questions, let me know in the Q&A. And otherwise, I'm going to see you in the next lecture. By now we've seen all the fundamental concepts of object orientation like classes, inheritance, and so on. And we've also dived into some of the more specific topics like methods, properties, and so on. But at this point now, I also want to talk about some of the principles of object-oriented design, for which we're going to need to talk about visibilities in more detail. So visibilities, of course, are very familiar to you from Java. So let's take a look at, well, many of the similarities and also some of the differences. So as you know, visibilities allow you to restrict access to a class or methods or properties of a class from the outside, which in object orientation is a fundamental concept known as information hiding. So information hiding is really all about restricting access to class internals from the outside. And instead you're only gonna provide access to the outside to what's really necessary. And you can also to some extent define the granularity of where it should be visible. And this of course helps you make your software much more robust, because you know much more how the class can be used from the outside, so what kind of things can be done to it. And for example, that the internals that you don't want to be changed from the outside can also not be changed from the outside. So it's really an important topic to understand. So let's go ahead and dive right in. So generally you have the private visibility, which is the same as in Java, meaning that inside a class, all private methods or properties, or commonly referred to as just the private members, will only be visible inside that class. And for top level properties and methods, so on file level, private means that they're only visible in that same file. Then you also have protected, just like in Java, which is also the same. So this means that protected members of a class are only visible inside that same class, so like private, but they're also visible in subclasses. So protected here is also a very restrictive visibility, meaning that it cannot be accessed from somewhere outside. It can only be accessed from child classes and of course the class itself. Now the major difference is that there's no package private visibility just like in Java. So when you write no visibility, then the default is actually public. And that is again the same as in Java. So public means that it's accessible anywhere or anywhere the parent is actually visible. So if it's an inner class of some class with restricted access, then it's only as visible as the parent. But normally, if you have a public class, that just means it's visible anywhere. And public methods of public classes are also visible just anywhere. So now what's interesting is this gap here, which doesn't exist in Java, which is called the internal visibility, which means that it's visible inside the same module. So the term module here, according to the official documentation, refers to a set of Kotlin files compiled together. So for example, this might be an IntelliJ module, can also be a Maven or a Gradle module, or in many cases just a whole Maven or Gradle project. So as long as you're just using one module in your project, then of course internal is just the same as public because, well, the whole project is one module. So it's not going to make a change to, well, how you code inside your project. So for now, this is not really that important because most of the time we're just going to be dealing with one and the same module. Like in this case here, you can see Kotlin Android here is one module in IntelliJ, indicated by this blue rectangle. Of course, in larger Android apps, you might have different modules. And in that case, internal is a good way to also use information hiding on module level, which is something that still Java is struggling with in Java 9 with modules and the Jigsaw project, which is still kind of, well, in discussion whether that's really going to go live in Java 9, I think, because they're having lots of trouble with it. But in Kotlin, you already have this concept of internal visibilities in order to use, well, information hiding also in module level, which in larger projects can be really powerful. Now, I don't want to go through examples for each of those on file top level or classes and subclasses and so on, but just let's take a look at a quick example. And also notice that the public here is actually the default visibility, as I mentioned. So when you don't write any visibility, like when I just say class car, let's say, then by default that class is going to be public, so it's going to be accessible anywhere. And you can simply in the constructor add visibilities like private val model, so of type string. And that way now when you create a object of this, so some car is car of some brand and the model, then you can only access car.brand, but you can't access car.model because model is private, so it can only be accessed inside the class. Now what you could do is you could still add a method like tell me your model that will return the model. In this case, of course, it doesn't make much sense, but now with this, you could still use this. Also, if this had the internal visibility, so without this, it's just public again as default. But with internal visibility, it's also going to be visible because, well, we're just using one module, so it's just going to be the same. But if it's protected, then it can only be called or it's only visible inside child classes. And it's going to actually warn me here because, well, the class is not open. So then protected doesn't make any sense. But if I were to have some specific car as a subclass of this, then inside this I could actually go ahead and, well, use this in some other function. So if I have a function here, I have now access to tell me your model, which is just a method on the object or the class itself. So you can use this dot tell me your model, or you can just call it without any prefix because it's just a method inherited from the parent. So the same as in Java. Now, as I mentioned, of course, you can also have top level properties and methods, or, well, in that case, functions in Kotlin. So you could also say private val I is, let's say, 42, then this is only visible inside this file. So I could go ahead here and say print line I, but I don't have access to this variable I in any other file than this one. Of course, protected doesn't make any sense for top level properties and functions because, well, there can never be any subclasses. So here it only makes sense to use private, internal, or public. So you could also just define a public function, say A, which returns 17. And you can also see that public is going to be in gray because it's actually redundant because it's the default visibility. Alright, so all very familiar from Java except for the internal keyword, which is only important for larger projects with different modules. And of course, please remember that public is the default visibility here. There's nothing like package private like in Java. Since you can have top level properties and functions, you can also use visibilities on those. But I think that's also very intuitive with your knowledge of visibilities from Java. Now, of course, you could also go ahead and use some of those keywords on the class. So now this way, this class is only visible inside this file here again. So the same kind of concept. And if a class isn't open, it doesn't make any sense to use the protected keyword. Alright, so that's all about visibilities for now. Remember that in general, we try to restrict access or visibility as much as possible. So for instance, by using private as much as we can in order to follow the principle of information hiding. Alright, so that's all I want to mention about visibilities in this lecture. So thank you so much for watching, and I'll see you again in the next one. In the next two lectures, we're going to talk about objects in Kotlin, but not just creating objects from classes. We've already done that quite a lot. But really, there are also object keywords in Kotlin, and we're going to talk about what we can do with them. Now in this lecture, we're going to talk about so-called companion objects, which are a kind of way to replace the static keyword from Java, which you may have been missing so far in this course, or maybe you're not missing it. Instead of having static methods on a class, in Kotlin we're going to use so-called companion objects. So let's take a look at how this works. I'm going to create a new file. I'm going to call that companion for this lecture. And I'm just going to create a class for now, which is then going to hold a companion object. And I'm going to give the house a number of rooms as an integer and a price of double. So now inside this class, you can define a companion object in which you can put all the properties and methods that you would normally declare as being static in Java. So let's go ahead and just use companion object. So both of them are keywords in Kotlin. And then you can define again in curly braces here all the properties and methods you want to have. So let's say you want to have a kind of static property, houses for sale. And I'm going to say that's going to be 10. So this is now a constant that belongs to this companion object. And you could also make this companion object a kind of factory. So let's say you have a method get normal house, and that's just going to return a house with, let's say, 6 rooms, and maybe it costs 199,000. And similarly, you could go ahead and say get luxury house. So luxury house with, let's say, just 42 rooms, and this is going to cost 7 million. So this is now the equivalent of static methods in Java and having static attributes in Java. Now the way you can use this is you can simply go ahead and call house dot, and now you already have access to all the properties and methods from the companion object. So you don't need to have any additional nesting here, although you can also use the default name called companion and then access all these, but you can also access them right from the class itself, just like static, methods and properties in Java. So you could access house get normal house, store that into a variable, let's say normal house, and then you could, as always, just use this like any other object and, for example, access the price. And similarly, you can also go ahead and just access the houses for sale directly from the class. So you don't need to use or go the route over the companion object. Now you already saw that the default name for this is just companion. So writing this would be redundant, but you can also give this some other name, like oftentimes this might be a factory that creates instances of this class. But for this one here, I'm just gonna remove the name because it's optional for companion objects. Now notice that, again, going with the intuition of static when comparing to Java, inside here you can't actually access on any of the properties of the class. So number of rooms, for example, is not available inside the companion object, just like price isn't, because those two are just properties or values that are going to be instantiated for a specific house. But as you can see, in order to call a method or access a property from the companion object, I don't need to create a specific object of the house class first. So there is no number of rooms and there is no price defined yet, and I can still just access any of the methods here. So it's impossible inside here to have access to the number of rooms or price of a specific house. Because just like static in Java, companion objects refer to things that are kind of existing for the whole class itself and not per object. So this should be intuitive when comparing this to static in Java. But one important difference when comparing this to Java is that the companion object is indeed an object at runtime, which means you can also extend or implement interfaces. So for example, you could say this should be a house factory when you say you have an interface, house factory, which says that there must be a function create house, which is going to return a house. Then you can say that the companion object actually implements the house factory interface. So now you're going to have to override the function create house. And for now, we're just going to say that this is just going to call get normal house. And I don't need to use the return here. I'm just going to call get normal house. All right, so that's how you can use companion objects in order to replace the static keyword. So things to take away here are that, well, you don't have static keyword in Kotlin. You can use companion objects to use kind of static properties and methods of a class. And inside such a companion object, you don't have access to any properties of a specific object of a house, because the companion object refers to the class as a whole without referring to any specific instance of that class. Next thing to take away is that you can actually implement or extend classes or interfaces with a companion object. You can also give it a name if you want to, but it's optional. And you can access any properties and methods of the companion object by prefixing only the name of the class. Alright, so that's all for this lecture. Thanks again for watching, and I will see you again in the next lecture. In the last lecture, you've learned how to use companion objects inside your classes to replace the static keyword known from Java. Now in this lecture, you're going to learn how to use objects as first-class members in your system in order to define singletons. Now before I explain what that means, let's actually go ahead and create again a new file for this lecture. And of course I'm going to call that objects. Now object declarations in Kotlin are declarations where you can actually define an object just like you can define a class, but an object by definition is only there once, so there's only one instance of that. And this is what you also commonly refer to as a singleton. Now singleton is normally a pattern you can implement in Java, for example, by enforcing that there can only ever be at most one instance of a class. But in Kotlin that's a lot easier because you can just use the object keyword here to define object. And this could traditionally be something like, again, a factory, but that already exists. So let's say a country factory, for example. We still had this country class at the beginning of the course. And then just like a normal class, you can just go ahead and add properties and methods to this object. But in contrast to classes, you don't have a constructor for this because, well, you can't create objects of this, only one object at any time in your system, or at most one object. So it doesn't make any sense to have a constructor, which is just useful in order to create many objects of the same class. So now inside this object, you could define some constants or just any kind of properties as you like. For a country factory, for example, you might definitely want to have a function create country, and that might just return some kind of default country. So we had a name here, and I'm just going to say this is randomly going to return Australia, and I'm going to leave the area out, so it's just going to be 0. So now the difference is that when compared to class, the object can only ever exist once, as I mentioned. So you can't create something like an object from this thing because it also doesn't have a constructor. That's only the way you do it for classes. Instead, you can simply access the country factory itself and then access either the properties here or call any of the methods on this object. So again, this is similar to static methods in Java because we have an object here, which means that all the methods, for example, always belong to this one object, meaning that this kind of syntax is the only thing that makes sense in this case. So we just write the name of the object and then call any of the methods we want on it. Now you can also create objects like this and extend from some parent class or implement an interface. So for instance, you could say some kind of default listener is gonna, for the purposes of this lecture, just extend the mouse adapter from Java. And then you can override any of the methods like mouse clicked, and for instance, just print line the mouse was clicked. So this way now you have this one object you can always use when you want to just pass in some default click listener, meaning that you don't have to create anonymous classes like in Java when passing in a mouse adapter in this case. And in cases like this, it makes sense to make this an object or a singleton because you only ever want to have one instance of this. So these are the kinds of cases where you might want to use singletons, and whenever you do want to use singletons in Kotlin, it's ridiculously simple to do that, just using object declarations. So no need for you to create a private constructor and so on and just implementing the singleton pattern by yourself. Instead, you can do this all very simply and in one line in some cases using Kotlin. Now digging deeper into this topic, actually in Java, creating a singleton, or the easiest way to create a singleton in Java, would be to use the enum keyword. So to just create an enum, you can also add methods to that, and you only define one possible instance of the enum. You can just call that one instance like it's done in the singleton pattern, which means that you don't have to care about making the singleton thread safe, serializable, and so on yourself. This is just a given. So that just as a side note for those of you who have already used the singleton pattern and are just wondering about these details of the pattern. So this is a very neat concept to keep in mind whenever you want to have at most one instance of some kind of type in your system at runtime. Thank you so much for watching, and I will see you again in the next lecture. Now, for the sake of completeness, I want to go quickly into packages and imports in Kotlin, which is very similar to Java, so it's not going to be any problem for you. And also the IDE basically takes care of all of this, but I still want to just quickly go through the concept and how it's done in Kotlin. Now, first of all, you can see the package is defined in the first line automatically by IntelliJ. For instance, the file objects.kt resides in the package 00 for object orientation, which we created here, whereas any of the files in the functional package will have the declaration package functional. And this, of course, just maps to where the file can be found or where any of the objects or classes can be found that you define in that file. And then you can also use that to import them from some other package. So for example, here we have the package Java with the subpackage AWT. And again, in the subpackage event, we have the class mouse adapter. So this syntax here is so far exactly the same as in Java. And you can also, just like in Java, use wildcard imports by using a star. So that way you only have to use this one import which is going to import everything from the event package. Now, one thing that's different is that you can also import any methods from a companion object. So let's say we have our house here, which has a companion object that defines, for instance, the method getNormalHouse, and we also had this property houses for sale. So we can import all of them to just be able to use that method without any prefixes in our code. So this way we could now just go ahead and call getNormalHouse here without any problems. You can see that as soon as I hit save, IntelliJ is going to go ahead and just optimize the imports again. So it removed the star import, the wildcard import again with these two specific imports. So as I mentioned, IntelliJ is normally going to take care of this anyway, but I just want to quickly go through some of the concepts here, because there's one thing that's also not possible in Java and might be introduced in Java 9 or Java 10. I don't think it's in Java 9, which are type aliases, which are aliases for the imports. So you could, for instance, give getNormalHouse the name createHouse, and then I'm gonna have to change this method call here, of course, to createHouse. And I don't actually need the prefix here. So just createHouse is now available in this scope here because we have called it this way. Now, one last thing that's different is we can also have top-level functions and properties, and those we can also import. So let's see, in our basics package here, we had some top-level property here called pi, for instance. So we can import that. We could also go ahead and just import basics.getExternalInput. So those can also be imported without any problems. And in many cases, this is actually the recommended alternative to using companion objects, unless you really have to, because many times what you would do as a static method in Java, you can just declare as a top-level function in Kotlin. And as you see, you can then also simply import those top-level methods and properties in any other files you like. Unless, of course, the visibility is restricted in a way that you don't have access to them. Alright, so those are the basics about packages and imports. Just remember, for takeaways for this lecture, you can actually use the as keyword in order to give another name to a method or to a class. And you can import top-level methods as well. You can import any methods and properties from companion objects, and you can do so without, again, a static keyword like you would do for static imports in Java. So thanks a lot for watching, and I will see you again in the next lecture. Now at this point in this course, you're already familiar with most of the basics of object orientation and even some of the more advanced topics. You've also seen many things that are new in Kotlin when compared to Java, like extension functions, smart casts, and so on. So in this and the coming lectures, I want to introduce you to a more advanced example or more advanced topic in object orientation, which are generic classes and generic functions. And then we're also going to dig a bit deeper into the theory and how to use generics in the best case. So if you've done a lot with Java already, you probably know about generic classes, and they're very similar in Kotlin. On a conceptual level, they're basically the same, and also syntactically, they're very similar. Only when we look at covariants, contravariants, and so on, we're going to see a difference here in Kotlin when compared to Java. But for now in this lecture, I want to just introduce generic classes in order to get you started into this topic. So let's go ahead and create a new Kotlin file here called generics. And in just a moment, we're going to create our first generic class in here. But first, I want to talk a bit about what generic classes actually are and why you would use them. So as the name already implies, a generic class allows you to write classes and their methods in a more generic way, so that they can also be used in more different situations. So to make all this a bit more concrete, you've actually already used lots of generic classes when we were talking about collections. So if you go ahead and create a list, for instance, then the type actually looks something like this. You might, for instance, have a list of integers and initialize that to, let's say, a list of 1, 2, 3. That's not important here. What's important is that you have this type here where the class is just called list, but it's a generic class, so you can further define the generic type parameters in angle brackets. So this means that the list class here is very generic because you can use it for lots of different types of lists. You can create lists of integers, lists of doubles, you can create lists of strings, and basically of any type you want. And the important thing is that all the functionality here for lists is only implemented once inside this list class, because adding an element to the list or removing an element works logically the exact same way, no matter what kind of elements here are actually stored inside the list. So this is the whole principle behind generic classes, which is just again to avoid code duplication in order to first of all increase maintainability of your code, but also just to keep things more concise by not repeating them over and over again. So let's see how we could create a class like this by ourselves. So for instance, let's say we have a class called timeline, which will store elements of some specific type, just like a list, and it's also going to add a date time to each of the items. So it's basically going to store data that's also tagged with a date. And we want to make this class generic so that we can have a timeline of integers, storing integer values tagged with a date, or a timeline of strings, for instance, or any type we like. So what we can do here is we can add a generic type parameter by opening up angle brackets and then choosing an abstract name for this, like E, for instance. So typically these generic type parameters here are called E for element or maybe T for type, something like that, just to indicate that they define the type of elements you want to store in this class. So now inside this class, we could go ahead and say, for instance, we have a method here called add. And now, of course, in the add method, we want to get an element that we can add to the timeline. So we're going to call that element, and the type for this should be the type E. So if we have a timeline of integers, for instance, then the add method here would take in an integer that's added to the timeline. So let's just say that inside here or internally, we're just using a map that maps dates to the data. And we're just going to say this should be a mutable map of. And again, since map is also a generic type, we want in this case to have a map from date to the type E. And again, the date class here comes from Java, so we're just going to go ahead and use that. And with this, we internally store all the elements, all the data. So if we get a new element, we can just say date to data dot put. And for a mutable map, this would actually exist, but I made the mistake to use the map type here. So what I actually want to use as the type is a mutable map. And now I also have access to the put method here. So I can go ahead and say put. And the key here should just be the current date. So just create a new instance of that. And then it's going to map that to the new element. And similarly, you could also go ahead and use the generic type. So let's say get latest element as the return type here. So for instance, this here would return an element of type E, depending on what the timeline actually stores. And in this case, we could return date to data dot entries dot last. And this will hopefully give us the latest one. I'm not too concerned here about the actual return type. And I actually want to just return the value. So just E without the key. So I'm going to access values here instead of entries. And this way I'm going to return the latest element. So this should all be very familiar from Java. You just add these generic type parameters here in angle brackets after the class name. And then you can simply use them inside the class. For instance, to define the type of properties or to define argument types or return types. So you're free to use this generic type parameter E. And at runtime, when you go ahead and create, for instance, a timeline, let's say this should be a timeline, and we don't actually have a constructor for this, but I'm going to say that this should be a timeline of int. Then you can go ahead and call timeline.add, and it's already going to show up here with an argument that takes an element, so the name is element, and the type here, as IntelliJ can tell you, is going to be int in this case. So we're going to have to pass in int here, and then when we call timeline.getLatest, you can also see here that the return type is again going to be an integer. And this is also very similar to how the generic types or generic collections in Kotlin are implemented. Normally here for lists or sets or arrays, you also have this one generic type parameter, and you can also see that maps are just generic classes as well, but they take in two generic type parameters, one for the key and one for the value. Now, if you ever want to do something like that, you can simply do that by comma separating them in here. So you could also add more generic type parameters here, but for the timeline, we only want one. All right, so that's the essence of how to create generic classes in Kotlin. Again, very similar to Java. So now in the next lecture, we're going to take a look at how to also then create generic functions with the same kind of purpose to, again, avoid code duplication and make those functions applicable in more situations. So I hope this was interesting for you, and I will see you again in the next lecture. Alright, so now in this lecture, we want to take a look at how to create generic functions in Kotlin, again, to avoid code duplication, to make our code more readable, more concise, and more maintainable. So why don't we go ahead and create a function, timeline of, that works the same way like list of, and allows us to create timelines more easily. So let's go ahead and say we have a function that's called timeline of, but now what kind of parameters do we actually want here? So it's going to be a var arg, so that we can just put in as many elements as we want. And we can also give this a name, but now the question is, what kind of type should each of those have? So depending on the timeline you want to create, this could be integers, this could also be doubles, this could be strings, this could be any type you want. But the thing is that the return value here should then also be a timeline specifically for that type. So if you pass in integers, this should actually return a timeline of int and not a timeline of any. So just like for our declaration of generic classes up there, we're going to have to define the generic type parameters that we want to use for this function. So again, we're going to have to add angle brackets here and then define all the generic type parameters we need. In this case, that's just one type parameter again. So I'm also going to call that e just like we did up there, but that's not necessary. You could also go ahead and call this t or whatever you like. So now it's very clear what the type of element should be. Each one of them should have the type e, and then the return type is just going to be a timeline of e. So for now, since we don't have a useful constructor in the timeline, what we could do is we could go ahead and create a new result as the timeline class, and this should be a timeline of e, and then we could loop through each of the elements. So for element, in elements that we get, we're going to add that to the result, and then in the end we can just return this result timeline. So as you can see, it's not that difficult to actually create generic functions. You just define the generic type parameters here before the function name, and then again you're completely free to use this as types for the arguments, for the return types, and also to use this inside your function. So now let's just quickly take a look at how to use this. So you could go ahead and say, for instance, another object, timeline2, is a timeline of, and then depending on the type of object or values you put in here, like for instance, if I put in 1, 2, 3, you can see it already changes here to int. And you can also see now that the type of this object timeline2 here, if I go ahead and actually select here specify type explicitly, is now timeline of int. If instead you go ahead and create a timeline of strings, then of course you can see that this will be a timeline of strings. So now you also have a much better understanding of how all those helper functions work, like list of, set of, map of, and so on. And even better, you're also able to create such functions yourself because you now know about generics, how to use them, how to create generic classes in Kotlin, and also how to generify your functions. So this is a very powerful concept, and so far with these basics, it's also actually quite easy to use. So always try to think about whether you can actually generify any of your classes or methods if you have a very general structure with very general functionality that can actually apply to all kinds of types. This is often the case for data structures. So for instance here, the timeline is a data structure that stores data attached with some timestamp. And of course, it's just the same for lists, sets, and so on. Those are the basic data types in pretty much any programming language. So those kinds of things can often be generified very nicely. And now you know how to do this in Kotlin. So now in the next couple lectures, we're really going to dive in a bit deeper into the language and also into Java a bit, because we're going to try to understand variants in generic types. So more specifically, covariants, contravariants, and invariants, which will also require quite a bit of knowledge in Java and how it works there. So this is not a beginner course here, but still I'm not going to assume you have lots of knowledge about these very advanced or more advanced topics like variants in Java, but let's leave that for the next couple lectures. So for now, thanks a lot for watching, and I hope to see you again in the next lecture. In this lecture, you're going to learn about the concept of covariance and what it can actually do for you in your code. Now, this is a more advanced concept, but it's also a very interesting topic, I think, and as a professional developer, it's something you should understand. So in this lecture, we're going to take a look at that. Now, just as a quick motivation why this is relevant, let's consider again our time series class here, which I renamed from timeline to time series, and this generic add function here. So in this method add, when you imagine you have a time series of person, for example, and student is a subclass of person, then you should also be able to add new student objects to that time series, even though it's not declared as a time series of student, but rather as a time series of person. And the same also goes for lists and other collections. So essentially, this is going to further increase reusability of your code by making a method like this work not only for the exact type that is used for the generic type parameter, but also in the case of covariance for subtypes. So to make this a bit more concrete, let's go ahead and create a new file for this lecture here. And of course, I'm going to call that covariance. So I'm going to create my main function here. And now as an example, let's just consider a list of person or list of people. Let's say we have a mutable list of person. So for this lecture, I'm going to assume a very simple class hierarchy. Let's say we have a class being, we have a class person that extends from this very abstract class being. And then finally, we also have a student class that again inherits from person. So we have this hierarchy with 3 levels. And now when we create a mutable list of person here, and we say we want to have a mutable list of, well, let's say just 2 person objects, just as a quick example. Then just like you would expect, you can also go ahead and say people.add, and you can just pass in a student here, because a student is also a person. So in the list of persons, you should be able to also add students to it. And this is one example here of covariance. So we're going to think about covariance as just the fact that you can use a more derived type. So let's say covariance is we can use a, let's say, more derived type. So in other words, a subtype. So in this example here, that would be the student class that we can use here instead of the person class. Now what's not possible is to go ahead and say people.add being, because this is not a more derived type, it's actually a less derived type. And that would be a concept that's called contravariance, which we're going to talk about in one of the following lectures. But this is not possible for a list like this because, well, this is a list of person. So if you go ahead and say, well, people 0, so the first object in there, you always expect this to be a person. And a person might have a method like speak English, for instance, which an object of the type being here doesn't necessarily have, because it's a super type of person. So this is not possible here because it doesn't fulfill the contract. So being doesn't fulfill the contract of class person. And that's why that's not possible here in this case. Now another very simple example for covariance is to assign a more derived type to a variable or value of a more abstract type. So for instance here, any is of course the most abstract type you can use, and we could assign a person to this, And then this here is also covariance because we can just use a more derived type in that place. So you can go ahead and say person. Of course, you can use the exact same type, but you can also go ahead and use a more derived type. So again, this is how we're going to think about covariance. Now, another situation where covariance comes in is when you want to create, let's say, a list called students, and you make that a list of person. And then you just go ahead and assign a list of student to that. So this is going to make it the type of list of student, and you assign that to a list of person. And that's okay here in this case, but what you can't do is you can't go ahead and say you want a mutable list of person, and then you go ahead and assign a mutable list of student to this. So it seems to be important here whether the collection here is read-only or whether it's also mutable. And why is that the case? Well, think about this list here for a moment. It's mutable, so you can go ahead and say students2.add, and then since it's a mutable list of person here, you could go ahead and add a new person object to this. But remember that you actually assigned a mutable list of student to this. So at runtime, it's actually not going to be possible to add a person object to this. So you can directly see that at runtime, this would lead to inconsistencies because, well, you can add person objects here from the type declaration here, but you can't actually add a person element to the actual value or list that's assigned to the variable. So that's why this is not possible. So it's important to remember here that you have read-only collections that are covariant. So read-only collections are covariant. So this would be another example of covariance. And on the other hand, for mutable collections, you can easily construct this counterexample, which is going to make it quite intuitive why that's not possible. Alright, so those are already the basics of covariance. Now in the next lecture, we're going to dive into more detail about this to see also the differences when combining Java and Kotlin, which is of course an important topic also when you have an existing Android project or any existing Java project where you want to actually introduce Kotlin to your code. Then you're going to run into these cases where you have some, well, different behavior, depending on whether you're using Kotlin or Java. So that's exactly what we're going to take a look at in the context of covariance in the next lecture. Now, as I promised, in this lecture, we're going to take a deeper look at covariance in order to see the differences when using covariant or not covariant types from Kotlin versus when using them from Java. Now, there are two steps to prepare for this. So first of all, I created two files here, two Java files, one of which is just a Java implementation of our time series. So this class is called Java time series, and it's basically the equivalent to our Kotlin class. And then also we have a Java main file that we're going to take a look at in a moment. Now the next step we need is to just create a add-all method here. So function add-all, and that's just going to take in a parameter called elements, which is a collection of E. And then as the implementation, we can simply go ahead and say elements dot for each, and then say edit, which is going to call our add method above. All right, so that's how simple it is in Kotlin. And with this now, we're all prepared to really dive into the differences between Kotlin and Java. And the difference really is in this add-all method that's going to take in a collection of E. And in our Java time series, also there's a collection of E elements. So the parameters look pretty much the same, but let's just go ahead and take a look what happens when we use them. So first I'm going to go ahead and use the Kotlin time series. So our Kotlin time series that we created. And I'm going to say, well, let's say events. So we have an events, which is a time series of person for some reason. And I'm going to just initialize this to an empty time series. So implicitly, this is going to be a time series of person, but there's no need to put this there explicitly. So in this time series of person now, we can go ahead and use add-all and then add a list of students here. So let's go ahead and say students, which is something we've already initialized, but as a list of person. So let me just go ahead for the sake of this lecture and call it students3. So this is now going to be a list of student, and I'm just going to say this is a list of, and let's just create 2 objects in here. Doesn't really matter. So now we can go ahead and say add all students3, and the compiler is going to be perfectly fine with this. So we can go ahead and just add a list of students to our time series of person. So again, in our declaration of add all, we have here a collection of E, and E is going to be person because we created a time series of person, but we can still also pass in a collection of student here, like for instance the list of student we just used. So this is another example of covariance we came across here. So covariance. And of course this makes sense, just like for lists, you should be able to add students to a time series of person. Now next, let's take a look at using the Java time series, which is pretty much equivalent. So let's say here this would be some kind of chart data, which is going to be a Java time series of person, and we're just going to initialize that with Java time series. And again, we could go ahead and add the type parameter here explicitly, but that's not necessary in Kotlin. So now first of all, we can go ahead and just say chart data.add and use a student object here. So that's also a kind of covariance. And we can also go ahead and say chart data.add our list of students. So students3. So that's again another example of covariance. And that should of course be add all, so that we can actually pass in a collection here. Alright, so everything very nicely reusable. You can go ahead and just add students or use add or add all to create or add a list of students or a single student. Everything's covariant here, the way we implemented this in Kotlin and Java. But now let's go ahead and take a look at using both these classes from Java. So first of all, we have our Java time series here, and I'm doing pretty much the same thing. So first of all, I'm initializing a Java time series of person, call that people data, and then we can go ahead and say add new person or add new student, and that's going to be no problem. So that's also the second one here is an example of covariance. But then when we go ahead and create a collection of students, like a list of students we did in Kotlin, and then we try to use add all to insert our collection of students, you can see that in Java that's not possible because the collection of student here is not a subtype of collection of person, which is going to be this type here at runtime because we assigned E to be person. And that's because in Java, there is no clear distinction between mutable and immutable collections, which is something I've really talked or tried to convey about Kotlin, where you always have interfaces list and mutable list, set and mutable set, and also map and mutable map. So there's a very clear distinction. And as you have learned by now, when you don't have that clear distinction, then a collection or a list can't be covariant by itself, because basically then it's mutable. And as you saw, when we have a mutable type, so when I go back to covariance.kt, you can see here when we had this mutable list, then we can't assign a mutable list of students to a mutable list of person. So that basically means it's not a subtype. And that's why we run into trouble here with add all students. So what we can do in Java, and what's normally the solution to this, which is also used in the Java standard libraries, is to use bounded generic type parameters. So you're gonna go ahead and instead of add all collection of E, I created this method here, add all covariant, and you would have to make this parameter a collection of something that extends E. So something that's a subtype of E or E itself. And then you can go ahead and say add all covariant and then pass in a list of students here, because now collection of student is a subtype of this type collection of something that extends E. Now, if you're not familiar with Java, I hope this is not just very confusing for you, but just remember that when you're working with Java, you may run into different behavior when working with these generic type parameters because of the fact that covariance is solved in a bit of a different way. So that's why in Java, to make your methods more reusable, you normally have to use generic bounded type parameters. So something like question mark extends E, or in the case of contravariance, something super E, which is something you've probably come across if you've worked with Java and Android before. But you can see that in contrast to this, when we use our time series class from Kotlin here, we can go ahead and say add new person, we can say add new student. So this is also an example of covariance. And we can also just go ahead and say add all students, where students is still our collection of students from above, which we also try to use here in our call for the Java class. But when we use our Kotlin file here with just the same declaration collection of E, you can see that when using this from Java, it is still covariant. So when using a Kotlin file from Java, you're not going to run into trouble so easily. And also actually when you go ahead and use a Java file from Kotlin, as you can see here, you're also not going to run into trouble so easily. It's actually just when you're using a Java file from Java, you have to make sure to make your API more reusable using the syntax of bounded generic type parameters. Of course, if you're just staying inside Kotlin, you won't come across this problem. So here in this example, we really only come across this problem when using our Java time series also from Java. And that's due to the fact that in Java, collection of students, first of all, is not a subtype of collection of person. And also that you have to explicitly define your method to take in a collection of this type so that you can actually use covariance. So again, this is another example of something that's a little more easily and also more concisely handled in Kotlin. And I hope that when you ever come across a problem with this, when using this on Java or Android, you will now have an idea of what to look for and to look into the method signature here and look at the use of covariant types. If it's defined in Java, you can take a look at the syntax here. So if it's just a collection of E and you try to pass in a subtype, you should be able to figure out why this might be a problem now. So with this, I'm now finishing up the concept of covariance, and I hope that the lectures here helped you to get a bit more familiar with the concept. Again, if you still have any questions left about this, just let me know in the Q&A, and I will get back to you as soon as I can in order to really clear things up more if it's necessary. Alright, so that's again all for this lecture, so see you again in the next one. So now that you know about covariance, in this lecture we're going to take a quick look at contravariance. Now we're not actually 100% through with covariance yet, because contravariance in this lecture is best explained by, well, comparing it to covariance. And also in Kotlin there's a concept of out and in parameters, generic parameters, that I want to take a look at in this lecture. And so we're going to talk about here in this lecture about really contrasting covariance and contravariance. But after this, we're done for now with variance, and we're going to move on to really diving into Android app development. So for this lecture, I'm going to go ahead and create a new file, contravariance. And in here, I'm going to first create my main function again, but then also I'm going to create two classes here, one of which is going to use an out parameter and one which is going to use an in parameter. So let's go ahead and see what I mean by this. Let's say we have a class called source, where we have a generic type parameter t for now. And then let's say we have a function here called produce t. And that's of course going to return a value of type t. And let's say in order to actually be able to return something, we take one into the constructor and then just return that. So now you can see we have a class here which actually only ever returns values of type t, but never takes in any parameters into a method of type t. Now classes like this source class here are called producers because they only ever produce elements of type t, of their generic type parameter, but never actually consume any. Now in those cases, you can actually tell Kotlin that this class will only ever produce elements of this type and never consume any by prepending the out keyword here. And now let's see what that actually does for us. Let's say we have a string source, which is going to be a source, let's say producer. And then let's say we want to have any source or just some super type of string. So this is going to be of type source of string. Now we want to have a source of any, and any is the super type of any other type in Kotlin. So we could actually use any source here. So we should also be able to use string source. And with our class as it's defined now, that's also perfectly possible. So when you use any source dot produce t, then in this case, this is going to produce a value of type string, which of course is perfectly valid for a, well, output type of any. But now if I go ahead and remove the out keyword here, you can see that now we don't have covariance here anymore. So this is again covariance. We can use a subtype because now Kotlin cannot infer that, well, there might not be a function here, let's say consume t, which takes in a parameter of that type. And then of course, in that case, you can't do this because you could say any source dot consume t and then use any, for instance. But again, you can see that this would not be possible with a string source. So that's exactly why you can go ahead and actually say if you only have methods that have t as a return value, but not as an argument, you can say this is a source or some class of out t. And you can see that out here makes our class covariant. And this is the equivalent to what we already saw with immutable collections. So remember that with immutable collections, you actually had, let's say, a list of student as a subtype of list of person. But with a mutable list, you cannot do that because you could add a new person object to a list of students, which again would produce the same kind of inconsistency at runtime that we just saw with our source class. And now let's go ahead and actually take a look at how to create a contravariant class. So you can also, I'm going to call this sync, create a class with an in parameter of t. And then that class here can now only have methods that take in parameters of type t, but you cannot have a function that returns a t. So even if you were to return a nullable, and I'm going to say return null, that would now be correct, but I cannot use t as a return type here because I declared this as an int type. If I remove this, then everything's going to be fine. I could create that method called a and return an element of type t, but I'm going to call this one sync, and this is going to be a so-called consumer class. So in contrast to the producer, I could also just call this one, let's say consume t, just to make this a bit clearer. Not going to do anything in here. But now all methods in this class can only look like this, where they take in parameters of type t or some other type, but they can never return any. And now in this case, we can go ahead and say, let's say we create an any sync, so sync of type any, and just create a new object here. And now when we have a string sync, so that should be of type sync of string, we can now actually assign our any sync to this. Because if we now go ahead and say string sync dot consume t and pass in a string here, then of course our any sync is going to have no problem consuming strings because it can consume elements or objects of any type. So here in contravariants, the child or the inheritance relationship is basically inversed. So any is a supertype of string, so that now in this case, a sync of any is actually a subtype of sync of string. And that's why you can also use this assignment here. Now for me, contravariants is always a bit, well, the other way around, a bit confusing. But I think when you really try to think about why this is the case and why you can actually call a method like consume t here, but could not go ahead and do something like produce t, then you're also going to be able to figure out why you can actually, or in which cases, you can use one object as a value for another object. Now I hope I was able to make this a bit clearer for you. And just as a quick note at the end, you also have this term called invariance, and that just means it's neither covariant nor contravariant. So for instance, when you saw the add-all method in Java, in the Java time series, you were only able to add a collection of the exact type E if you didn't use the syntax $extends E, or in order to use contravariance $super E, which is very Java specific and not very relevant for this course. But in those cases you have invariance, so you can only use the exact type that's, well, declared as, for instance, the parameter type or in any other place. Alright, so with this we're leaving the topic of variance and invariance. So you have now learned about covariance, where you can use a more derived type, and contravariance, where you can actually use a less derived type. Like in this example here, you have a sync of any when compared to a sync of string. So this is kind of a less derived type, but you can still use that as the value for this object. And you've also learned a little bit about the differences between Kotlin and Java in this case. I know this has been a pretty well advanced topic, maybe a bit confusing for some of you. Again, just let me know in the Q&A if you have any questions. And also don't worry too much about this. I think once you actually come across an issue like this, you can always still refer back to these lectures. And once you actually have run into trouble with this, then you can also maybe better understand what the problem here is and be able to figure out why you have a problem in your code by referring back to these lectures. Alright, but with this we are finished with the topic of variance, so you can take a deep breath and just wait for the next lecture. And now we're going to actually also be able to really dive into Android app development. So I look forward again to seeing you in the next lecture.
Alright, congratulations for making it this far in the course. You have now learned all there is about Kotlin, or most of what there is about Kotlin, and you've not only learned about functional programming, you now also have a great understanding about object orientation in Kotlin. You've seen how to create different kinds of classes, how to use inheritance in Kotlin, how it's also very different from Java with open classes and final or closed classes by default. You've seen some great concepts in Kotlin that can really improve your code, like data classes to really save lots of boilerplate code when compared to Java, like smart casts in order to better work with inheritance hierarchies and also with nullability, and also how to use objects to create singletons very easily. Then we moved on to more advanced concepts like generics, for instance, how to use those in Kotlin to make your code more reusable, and also in the end, variance, covariance, contravariance, how this can be used in your code, and just some of the concepts around it so that you better understand what's going on and what people are talking about when they talk about variance or invariance. So with this, I think we're now ready to really dive into our Android app and begin applying all those concepts we learned, applying all those great features of the Kotlin language to really write better code when developing our apps. So I hope you find this useful. If you have any questions again, as always, let me know in the Q&A, and otherwise, let's move on now to the next lecture. Okay, so in this course, we will only be creating one app in which we will iteratively improve, introduce new concepts, and see how we can work with different Android APIs or part of the Android SDKs in a better way using Kotlin. Now, as I mentioned in the promo video and in the description for this course, we won't cover all of Android. So there are many courses on this topic. They take maybe 50 hours to cover at least much of Android, but it's really not possible to cover all the topics that revolve around Android. Instead, what we want to do in this course is we want to look at some of the things that are used most frequently in Android, and then see how we can really use Kotlin to really improve on the code that we normally write in Java. And we're going to use extension functions most of the time. We're going to use higher order functions, data classes, and all those concepts that we learned and that aren't available in Java in order to write cleaner code. And once we've done that here in this course, you will also be able to understand why we're doing this, how we're doing this, and in what kind of situations you might want to do this. So that way you will also be able to apply the same kind of transformations or refactorings to other parts of the Android API in order to write better code. So all those features in Kotlin really allow you not only to write cleaner code, but also to write just more robust and safer code by avoiding null, using non-nullable types, to write more concise code, more modularized code. And that's really the goal of this course, to really teach you how to improve your code with those features that you learn about. So most of the time I will start off by implementing everything basically the Java way, just written in Kotlin basically. And that's unfortunately also where many other courses stop. So they use null a lot, they use unsafe call operators, the double exclamation mark a lot, and all those kinds of things, which are really sad because you have much better features and much better possibilities in Kotlin. So we really want to focus on then how to improve the Java way or the way it's traditionally done by applying those concepts we've learned about and step by step making our code better. So I hope you're going to learn a lot from this section and that you're going to be able to write code that you and your colleagues like reading and maybe even your colleagues can learn something from. So with this, I'm going to stop talking about what we're going to do and instead we're going to dive into the code and get started with our app.
All right, so now we're finally able to really dive into Android and see how we can write cleaner code for Android apps with Kotlin. And for the purposes of this, we're going to create a new project with our new app, and I'm going to call this habit trainer. So it's going to be supposed to let the user create positive habits and then stick to them. And as company domain, I'm going to use com.petersommerhoff, or I can just do it the other way around, so that the package name is going to be com.petersommerhoff.habittrainer. If you don't have a domain, you can just use example.com, and the project location is going to be adjusted as well. So we can just hit next. Then I'm going to stick to the default minimum SDK here, which at this point in time is Android 4.1. Click next. And then I'm going to start off with just an empty activity. So we're going to do everything by ourselves. And I'm also going to keep this as the name main activity. I'm going to let it generate a layout file for that, which we're going to edit in the next lecture. And I'm going to make it backwards compatible. So with this, Android Studio is now going to go ahead and create this new project for us, in which we're then going to see how to actually use Kotlin for Android app development. Alright, so here we are now in our newly created project. And then first of all, you should make sure that you still have your Android virtual device. So in your AVD manager, you can go ahead and check that from the beginning of this course. Let me show this right here. You still have our Nexus 5X with an API level of 26 here in this case, so it's on Android O, so that we can use that to run and test our app on our computer. And also make sure here in the SDK manager, you can go ahead and always update to the latest version. So here, for instance, Android 8 or Android O, that's API level 26. And then also under SDK tools, you can make sure you have everything installed you need. But by default, you should already have all you need for this and the coming lectures. But make sure that if there's something missing and if there's an error message in Android Studio, you can always check if you have everything that's necessary installed here. What you might not have installed are the Google Play services. Those are only going to be needed once you want to use Maps or something like that. So for now, they're not really necessary, and probably Android Studio will also suggest installing them automatically. But just to make sure that you can always go to the SDK manager here. So at this point now, we should already be able to run our app, because in our Gradle scripts, which define our dependencies, we already have automatically Kotlin version 1.1.4-2 installed here in my case at this point of recording. And it's gonna automatically add the dependency to include Kotlin in this project. And under the apps build.gradle file, so for this module, we also have Kotlin Android, and we have the Kotlin Android extensions that we're gonna make use of in just a few lectures. Now, if all these dependencies aren't included for you, make sure to configure Kotlin for your project or add them manually to the Gradle files. You should also be able to do this in Android Studio by typing in configure Kotlin to let the Android Studio IDE help you with this. And in case that doesn't work, you can also go into the settings, search for Kotlin, and see what might be wrong. So the Kotlin compiler and so on, we have language version 1.1, as you can see in our Gradle file. Then by default, of course, Kotlin always targets JVM version 1.6, because that's what we have to rely on still in Android development. So you can go through these to see if everything's the same or configured the same as it is for me here, and try to see what the problem might be if it's not working for you. But now at this point, you should already be able to run your app on our virtual device. So with this, we're then now already able to start actually developing our app and customizing the layout, the functionality, and so on. So that's what we're going to go ahead and do in the coming lectures. Now you can see here, once the virtual device actually started up, it's going to also start up our app automatically, and still the same as in the setup in the beginning. By default, it's just going to show hello world. And with this, once you have this, you're now ready to move on to the next lectures. Now, before we create the initial layout for our app, I just want to take a quick look at Android versions in our project, just to get you familiar with the concept. Now you can see here in our apps build.gradle file, so for our module here, not for our whole project, you can see we have the compile SDK version set to 26, and that refers to Android O, so that's the newest version. And Android Studio will actually also give you a warning here when a newer version is available, so that you can try to upgrade as soon as possible. So this compile SDK version really defines, well, with what SDK version we're compiling our project. And then the min SDK version here is the one we used when creating our new project, which was given to us as the default value. So this was the one that referred to Android 4.0 or Android Jelly Bean. So this is the minimum version that we say we support in our app. And this is also what the Play Store will actually filter your app by when displaying them to users. So if a user is on SDK version 15, then in the Play Store, your app won't actually show up because, well, it's not even supported for that version. So it's really going to filter out all the apps that aren't available or aren't supported for your platform. If, however, a user is running Android Jelly Bean or even a newer version, your app will show up in the Play Store. And you can also see we have the target SDK version, which should usually be the same as the compile SDK version above. So that's really what we're targeting with our app. And that's also just the newest version, Android O. So as you probably know, there are a lot of versions of Android. And with each new version, there's new features and new functionality being added to the platform. So when we write our app, we really have to think about which users we want to support. And in many cases, Google just provides support libraries so that we can also target older devices quite easily in our app, so that we are actually able to support all the devices down to Android Jelly Bean, even though that's already quite an old Android version by now. But thanks to the Google support libraries, it's still rather easy to support them. So it's usually also good practice to do this. And of course, it also in the end just helps you reach a wider audience because, well, in the installation or at the project setup, Android Studio actually mentioned that around or over 99% of users are actually using Jelly Bean or a more recent version. So that means that for more than 99%, your app will also show up in the Play Store if you have Min SDK version set to 16. So that just as a quick note about versions to make you really think about this. But now in the next lecture, we're going to see how we can actually create the layout. And then we're ready to actually move on to Kotlin and see how Kotlin can actually improve our code in our Android app. All right, so in this lecture, we're going to start off creating a very simple card view for our app. Now for this lecture, please make sure to download the two lecture resources, the two images here, walk JPEG and water JPEG, which we're going to use in our app. Now once you've downloaded them, let's go ahead and create our layout. So you can easily open up the activity main.xml, and inside here you can see the layout that's currently used for the hello world. So we have a constraint layout at the top level, and inside that constraint layout, which is like a container, we have a text view that simply shows the text hello world. Now what we want to do for now is we want to create a scroll view so that later on when we have many cards on our main activity, the user can simply scroll through the cards, and each of those cards is going to represent one of the habits that the user decided to follow. So once there are too many to show on one screen, we want to be able to scroll them. So for now, we're just going to go ahead and use a scroll view. And then inside that, we want to use a card view. Now to use that, we're actually going to have to add a new dependency. So we're going to open up our app's build.gradle file. So use the one for app here. And then at the bottom here in dependencies, you can go ahead and add a new compile time dependency. And that's going to be com.android.support. So that's like the package name that it uses. Then you put a colon there, and the one we want to use is called card view v7. And then another colon which separates this from the version number. And at this point we can use version 26.0.1. So with this now we can save this and then let Gradle sync our project. And this should all work fine with this dependency here. And now once we have this, we can go ahead in our layout and get rid of the text view. And instead we can go ahead and use the card view now. And it's going to come up with a suggestion normally, right? So there's the card view. We want this to match the parent width, and the height should just be wrap content so that it only is as high as necessary in order to contain all its contents. And on the left-hand side of each card, I want to have an image view, and this should actually be 22 dp wide and also 22 dp high for now. And I'm just going to go through the concept of each of the elements here. So I want to have a text view, which is going to be wrap content for width and also wrap content for the height. So this is going to be the title of each habit. And then lastly, there's going to be another text view, again just wrapping its content, which is going to show a description for each habit. Now I want to mention that you can also go to the design tab down here in order to see everything in this editor. So you can see our card view here on top, and you can also see the hierarchy with the scroll view that contains a card view, which contains our 3 elements, and you can just drag and drop elements into this here. But I usually prefer to use XML to really show you now also what's going on under the hood. And also when using the design here, you're also going to end up with quite unreadable XML code. So I'm going to go ahead here for this lecture and just use the XML or write everything in XML. And actually now inside the card view here, I want to have just one child element, which is going to be a relative layout. It's going to match its parent's width, and it's just going to be as high as necessary. And this should now contain all our other 3 elements here so that we can better define how they're going to be laid out in relation to each other. I'm going to indent all this, And the first thing I want to do is I want to add some padding to our relative layout in order just to add some white space to the layout. And next thing you normally always want to do is you want to add an ID to all the important elements. So just type ID, select Android ID, and it's also going to come up with the syntax here to create a new ID for this element. And I'm going to call this IV for image view. And I'm just going to call this icon for now. So it's going to be the icon for the habit. And now I'm going to, inside this relative layout, we can use things like align parent left. So it's going to be aligned to the left of its parent. And it's also going to be aligned to its parent top, meaning it's going to be aligned to the top left corner. And then I'm also going to add some margin to the right, which is going to just add some white space to separate this image view from the text views. So we're going to have this image view here on the left hand side, and then the two text views on the right hand side of the card, where the title is above the description. So I'm going to repeat this here again. We're going to have an ID first, and I'm going to call this TV for text view, and then just call this title. Now again, we're going to make use of the relative layout, and we can say things like we want this to be to the right of the element with the ID IV icon. So it's going to be to the right of the image. And we also want this to be aligned again to the top of the whole relative layout. And for now, just to test this, let's also add a fixed text to this. So this is going to be, so let's say the habit should be drink water. So that's now just going to be our sample text just to see what the layout looks like later on. And I'm going to also increase the text size here to be 30 SP. Make sure for text sizes to always use the SP unit instead of the DP unit, so that Android can automatically scale the text size for different sizes of Android devices. So on tablet and phone, the text size should be different because the screen size is also very different. And this is all done automatically when you use the SP unit. Now lastly, we're going to go to our last text view here. Again, first add an ID. This one I'm going to call TV description. This one should also be aligned to the right of our image view. And it should be below our TV title. Alright, so this should now be everything we need for this layout. So now we have this file here, activity main.xml, which we can also take a look at again in the design view, where you can now see we have drink water here as the title. And I actually forgot to use just a sample text for our description. So let's say the text here should be, let's say, refreshing glass of water gets you hydrated. So just some motivation for this habit. And then in the design view, again, we can take a look at our card layout, where you can see we have this image here, we have our title, and we have some description that really makes the user more motivated to follow this habit. Now, one thing I want to do here is I want to also add a sample image to this. So I'm going to say source here is going to be a drawable, and I'm going to use the water drawable that you downloaded from the lecture resources. So this is just going to read this file here, water.jpg, and show that in the image view. So now when you look into the design view, you can see we have an image shown up here, from which you might actually want to increase the size a little. So let's say we want to have 64 dp for the image. You can see we have a glass of water there, and you can also still run this app, and now it's going to actually come up with this design, because in our main activity here, the default code is already going to include this layout, as you know, because the hello world layout also came from the same file. So just by creating the project, you already have this code here, which is actually going to show this layout, activity main.xml, in our main activity. So just running this now would already include the correct layout. And you can see here in our emulated device, you can see our first card from our card layout here. The title, the description, the image, everything looks fine. So this is the basic kind of layout we want to use. We want to have multiple cards here. Later on, we also want to let the user be able to add new habits on their own. And they should be able to also say every how many days they want to do that habit. So is it a habit they want to do every day, every 2 days, and so on. And we can, of course, just build on that and try to improve on that again and again later on. But for now, this is just the basic layout we want to work with. So that's fine now. We have our card layout, the basic layout we want to use. We're going to reuse that later on in a different way. For now, we just have our activity main that's just going to show one card. Later on, of course, we want to use one card for each habit that we have in our database. But at that point, we can simply reuse our XML code here in order to show that card and use that layout for each of those habits. Alright, so that's the basic layout, and I'm going to see you again in the next lecture. In this lecture, we'll finally see one of the powerful ways that Kotlin can improve your code when compared to Java. Now, normally we don't actually want to have a fixed text for our card layout here. So let's say we just remove this description and we want to actually set that description programmatically in our main activity. So first of all, we're going to have to get a reference to that text view just to then set the text. And as I mentioned, oftentimes I'm just going to go for the Java way to do things, and then I'm going to improve on that by using it the Kotlin way or using some of Kotlin's features in order to improve the code. Now, unfortunately, many other courses on this topic actually stop at the point where they just use Kotlin completely like Java, and they don't actually make any use of the benefits of Kotlin when compared to the Java language. So we're going to do this better in this course. So you're going to see how you can actually write cleaner code with Kotlin. Now, the Java way to do this would be to create first a private member variable in our activity. And we can call this, for instance, text view description. And actually, we can't even make this a val. We're going to have to make this a var because we'll have to initialize this with some value now. And then later on, we're going to have to assign the actual text view. So this should be of type text view, but we have to initialize this with some value now. So we can only go for null at this point. So we have a nullable type, and we also have a mutable variable instead of a val. And this is exactly what you'll see normally in Java code, and it's pretty much also the only way you can do this. And then inside here, you can go ahead and say TV description equals find view by ID. You can get the ID from this R file using r.id, and then we called this TV description. So this find view by ID here is going to be used in Java code all the time to get all the elements from the layout that you need, and then to put this into this variable here. And in Java code, you'll actually also have to cast the result of find view by ID normally. Here, this is going to refer to find view by ID of a text view, because that's the type of our member variable, TV description. So in Kotlin, we don't need to explicitly define this. And now we can go ahead and say TV description.text and set this to, well, I should probably have copied the value or the string here. So I'm going to do this now, switch back to main activity. So here you can see that with Kotlin, we also run into trouble again because this is a nullable field. So whenever we want to actually access this, we're going to have to use the save call operator. So only if this is not null, then we're going to set the text. Now in other courses, you often see the double exclamation mark used very often. That's already a warning signal, or should be a warning signal for you that they just don't really understand how to work with nullables in Kotlin, and also just don't know how to avoid nulls in the first place. So here you can simply use the save call operator because, well, this of course shouldn't be null at this point. We have just set it to the view, but it's just not necessary to go for the double exclamation mark, because if this is null, then, well, you just don't want to set the text. You just want to set the text here if it's not null. So remember that if this property here is actually null, then this line will just not be executed. And that's of course the safe way to do this. Alright, so that's completely the Java way to do this. So now let's go ahead and improve this one step by using Kotlin's late init modifier. So this means that this variable here doesn't need to be initialized at this point in time already. So this means we can now get rid of the nullability here, and instead we can still use our code as before. We just have to make sure to actually set a value to our member variable before using it. So with late init, we basically say that we're going to initialize this before use. If we don't, we of course run into trouble because, well, we can't use a non-initialized variable. But this is just a nice way in this case to get rid of null. But we still have a var, we can still use a val because we do still set TV description only here in this line. And it's actually not possible with the combination of late init. So this is already a lot better than before because we got rid of null in our code. But now in Kotlin there's actually a very nice way to do this even more simply. So when you go back to the build.gradle file for the project, you can see we have this plugin here called Kotlin Android Extensions. And that's gonna automatically go ahead and create member variables that we can simply access in our code without actually doing this ourselves. So the way this was called in our layout XML was TV_description. So you can see that's actually available here in our code already. So there's no need for us to actually create a member variable and to clutter our code with, well, when you have 10 properties, so you're going to have all those up here, then you're going to have to initialize all of them in the onCreate method. So it's going to really clutter up the code with just very simple initialization. And this way here, you can simply go ahead and use all the elements from the layout right away. So you could also see we have TV title. That's also available. We could set some text there. And of course, you can also access the image view and then use this in the same way you would with any other image view in Android. For instance, setting the image bitmap. So this is a really nice way to get rid of some of the clutter and boilerplate in your code. And it's also a very safe way to do this. You don't have any trouble with null. You don't have any mutable member variables in your class. And you just got rid of lots of lines of code. But there are also some drawbacks to this approach because first of all, this is a little bit of magic. So for many people who aren't used to this, it's going to be unclear where this variable suddenly comes from. Of course, you can always in IntelliJ or Android Studio just use Control-B to go through the declaration and they're going to see, oh, it's just the ID of the element in the layout. So that's where it comes from. So they're also going to be able to know how to access other elements like this one, for instance, and it's not going to be so magic anymore. But at first glance, it's going to be, well, a little different than what people are used to from the Java world. And also you should of course make sure to use good names in the layout XML. You can also go ahead, of course, in your layout now and actually use names that follow the coding conventions for Kotlin or Java so that in your code you have a member variable called TV description with camel case so that it fits better into the rest of the code. But you may also want to actually stay with the normal XML kind of naming things, because that way it's also clearer that this is again one of those variables that comes actually from the layout. So here in this course, I'm actually going to stick to the XML naming so that when you see a variable with an underscore, for instance, you know immediately that this is coming from the layout. And also I'm going to make use of Kotlin Android extensions in general in order to get rid of all the initialization code just to access all the elements from the XML layout. Alright, so again, we made our code much more concise with this. We also made it much safer. We don't have to use null. We don't have to use mutable member variables. And it's just very easy and concise and, well, nice to use. So I hope you like this approach using the Kotlin Android extensions. And of course, in the coming lectures, we're going to see many more instances of how we can make our code cleaner with Kotlin. So I hope you're excited, and I'm going to see you again in the next lecture. Alright, this is just a quick challenge. So first of all, I'm going to remove all the explicit or fixed texts and sources. So drink water here should not be set in this fixed way in the layout. Also the drawable here is going to be set in the code. And now for the warnings, this is actually just due to the fixed left to right layout at the moment. So you can see when you press Alt Enter here that it suggests to also add align parent start instead of align parent left. So I'm going to go ahead and do that. Margin right should be margin end as well. So on a right to left layout for people reading from right to left. And the same goes for to right of would be to end of. Basically right is always or corresponds to end and left corresponds to start. And now with both set, this is now going to work for left to right layouts as well as for right to left layouts. And this is of course something to be aware of. On the Android platform, we have users from all over the world. Now lastly, for image view, you should set a content description. I'm just going to say habit icon, which denotes what this image is actually displaying or what it's used for. And lastly, always when you use a fixed string like this, you should actually go ahead and put that into a string source. And you can again just make use of Android Studio to do that very simply. Now in the main activity, all you need to do is you need to access the image view icon. Then you can set image source. And again, you can access r.drawable in this case. So you can access all the folders here that are available here. So drawable, layout, mipmap, and values. Just like up here, r.layout.activity main is also accessed. So here we use the water.jpg. And here again, we should go ahead and say extract string resource. Just going to call that drink water. And I'm going to call this one drink water description. And then Android Studio is going to go ahead and use the getString method. And then again, it's going to just access this resource here, which in this case is a string resource. So it's accessed as r.string and then the name of the resource. So this way now we're setting all the values that should be dynamic in our layout programmatically. So later on, when we want to actually add more cards than one, we can simply show one card for each of the habits and set all the content in exactly the same way. And with this, we're now ready to move on to implement a recycler view in Kotlin, which is going to allow us to show multiple cards and also letting our app stay efficient, because the recycler view is just going to recycle parts of the layout so that it's easier or faster to render. This is a very common task in Android because recycler view is also used very frequently. So I just want to go through the process here and see how we can do this in Kotlin. So that's all for this section. I hope you enjoyed this, and I look forward to seeing you again in the next lecture.
Alright, so in this section we're going to move on to implement a recycler view in Android. Also a very common task because it's basically like a more efficient list view. So it's used in many apps and it's one of the common tasks you have to do in Android. So in this section we just want to go through the process and see how we can implement a recycler view in Kotlin. So this is going to be a nice way to recap what we learned about classes, object orientation, inheritance, overriding things, because we're going to have to override some methods, and just to get started into the world of Android when combined with Kotlin. Later on in the sections, we're going to see other places where you can apply even more of Kotlin features to get a lot more out of our code. But in this section, we're going to see how we can first create a recycler view, because it's such a common task and it's just a good way to get started using Kotlin on Android.
Alright, so at this point we know how to create our layouts. We also know how to access all the elements from the layout in our code by using the Kotlin Android extensions. And now in this lecture we're ready to scale our app to be able to contain more than just one card view. So to do that, we're going to change our main layout, and we're actually going to modularize this into two layouts. So first of all, our current activity main layout here is actually mostly the layout that we're going to use for each of the cards. So this card view here, I'm going to take out of this file and I'm going to put this into a new layout resource. So you can just go here and say layout resource file, and I'm going to call this single card because this is the layout for each single card we're going to show later on. And then I'm going to go ahead and instead of having this basic or default linear layout, we're going to use our card layout in here. Now, since this is now our parent element or our root element, we're going to have to add the XML schema that Android Studio already suggests to our layout by just using Alt-Enter or adding this here by ourselves, the XMLNS. So we have to import basically the Android prefix, and I'm actually going to make this the first statement here. And this will then allow us to use this Android prefix for all the attributes we're using. And that's the only change we have to make to this layout. This is what we're going to reuse for each of the cards. So later on, we want to show one card for each habit of our user. And then in our activity main, we're going to now be able to actually include a recycler view. Now to do this again, we're going to have to use the same process as we did for the card view. So we're going to have to add that as a dependency, and we can basically just copy the card view dependency and just rename this to recycler view because the rest is just the same. And then we can sync our project. So make sure you have this compile time dependency in your app's build.gradle file, and then you can go ahead here and use this. Then it becomes available. So you can here use recycler view. But what exactly is a recycler view? So a recycler view is very similar to just a list view. So later on we want to show a list of cards, a list of habits for a user, and a recycler view, as the name implies, recycles some of the objects that are needed to display each of the items and therefore makes it more efficient for long lists. So imagine you have a screen on your smartphone where you can only display 5 items at a time, but you have a long list with 100 items. Now the recycler view is going to go ahead and just keep a cache or a pool of maybe 5 to 10 objects that it can reuse when the user scrolls in order to quickly show the new items. So it's just going to modify the contents of each item. In this case, for instance, the habit title, the habit description, but it's going to avoid to create new objects. Instead, it's just going to reuse the objects that it already has. And this way, it's just a more efficient implementation of a list view, basically. So that's what we want to use here for our app in case the user later on has actually a lot of habits that he wants to follow. Now, the next thing we have to understand about the recycler view is that the recycler view actually has an adapter. And the adapter is where the recycler view gets its data from. So later on, when we have, let's say, an ID here of just RV for recycler view, then we're going to be able in our main activity to go ahead and access the RV, so the recycler view. So here you can already see it. And then there's going to be a method, or in this case, since we're using Kotlin, it's just going to be a property called adapter. And we're going to have to set this to some adapter for the recycler view. In this case, the adapter is basically going to be a list of habits because that's the data we want to actually display on the screen. And this is a common concept in Android. So we have to use some kind of adapter, and that adapter defines the data we want to use in a recycler view, the same way it goes for a list view, and so on. Now the main task for us as a developer to implement the recycler view is going to be to implement 3 methods which are called onBindViewHolder and getItemCount. And of course, we're going to talk about each of those in the coming lectures, and we're going to see how to actually implement them using Kotlin. And once we have that done, we're then able to simply add a new habit to this adapter, and then it's going to be automatically displayed on the screen along with all the other items. And since we're using a recycler view, it's also going to be nicely efficient and not going to skip too much when scrolling through the habits. So that's just a quick introduction and the roadmap for the next couple lectures. So now we're going to take a look and really dive into implementing a recycler view. Alright, so let's start off into the implementation of the recycler view by seeing what we actually want to do in the main activity and then creating all the classes and methods that we need to do that. So first of all, we already have our reference to the recycler view using RV. And then the first thing we can do in this case here is to set hasFixedSize to true, which is just a detail that will further increase performance, and which just tells the recycler view that the size of each of the cards that it contains will be constant and will not change when a new item is added or removed. But now the two main parts that a recycler view needs are first of all the layout manager, and in this case we're simply going to use a linear layout manager that we can simply instantiate using linear layout manager, and the context is going to be this activity. And then the last thing that the recycler view needs is the adapter, and that's going to be the main part of our work. So the adapter should be a class that we're going to create called habits adapter, and this is going to store a list of habits. So conceptually, this is what we want to do. So remember that the adapter defines the data for our recycler view. So we're going to create a class called habits adapter that's going to store some list of habits, and that list of habits is going to be, well, the data that we want to show in our recycler view. And for each of those, we're going to use our single card layout in order to show that habit. So let's go ahead now and start off with this by creating a new class called habit. So I'm going to go into main package here for this app, and I'm going to create a new Kotlin class called habit. And here we can also again make use of some great feature in Kotlin by using a data class, because this should simply hold some data, like for instance in this case we have a title of type string, we have a description of type string, and then we have some image, which for now, for simplicity purposes, we're going to make an int, and that's going to be the resource ID for that drawable resource. Now remember that with this declaration here, we already get hashcode equals n2string for free. We also get a copy operator, the structuring operator, and all those kinds of things with just this one line of code. And with this, we can already go ahead and implement the method or function called getSampleHabits. That's going to return a list of habit. And for now, we're just going to return some list of example or sample data. So let's say we return a list of, and then let's say habit 1 is going to be go for a walk. And I'm going to say the description is a nice walk in the sun, gets you ready for the day ahead. And I'm going to say that the drawable ID here is going to be our walk picture. And then the second habit I want to go with for now is drink a glass of water. And again, this is going to be a refreshing glass of water, gets you hydrated. And in this case, the drawable ID is going to be our water drawable. And with this, we already have two sample habits. If you want to go for more and add some more pictures to this, you can simply extend this list here, and then accordingly later on the recycler view or the main screen of our app is going to show that number of habits. But in order to get there, we're going to have some more steps to go ahead. So let's end this here for now. We have now defined our basic habit class, which is going to be the foundation for all that we're going to go ahead and do now. So this is our data class that defines all the things we want to store in the habit. And we already have this method here, or this function, which is going to give us a list of test data. So now all that's left to do is to create a habits adapter, which is going to be our implementation of the recycler view. Alright, so we have our recycler view ready to go, and it's just waiting for us to feed it with this data, which is a list of habits, and that's exactly what we're going to have to write the habits adapter for, because each recycler view is only able to read its data from such an adapter. So in this lecture, we're going to go ahead and create our new class. So I'm going to call the file habits adapter, of course. And I should actually just create a new Kotlin class instead of creating a file and then adding a class. But for now, this is also going to work. So let's say we have a class habits adapter, and this is going to take in habits, which is going to be a list of habit. So this is our constructor for this class, which of course is also appropriate for how we want to call this in our main method here. So the argument here, list of habit, is now okay. It's just that the type of our class here is not yet correct for the adapter. Because what we're going to have to do is we're going to have to extend from a class that's part of the recycler view. So we're going to extend recycler view.adapter. And in this case, this is going to be an adapter of habit view holder, which is another class we're going to have to create for this. So this is the kind of pattern you're going to have to use to create an adapter for recycler view. So now the next thing we're going to have to do for now is create this class called habit view holder. And you can see at this point Android Studio will also come up again with the suggestion that what we have in the angle brackets up there should be this new class. So you can use Alt-Enter in order to automatically adjust the type parameter there. So it's now habitAdapter.habitViewHolder. And now we can go on here and say that we want to have a parameter of type view, because we're going to have to again extend recyclerView.viewHolder in this case, and we're going to pass in the view. Now, of course, in order for this to work, we're going to have to import this file. So you can do Control Space in order to show the suggestions and then select the first one here. Or you can also optimize imports using Control Alt O. So there are many ways just to get this import into the file here. So those are the two kind of classes we have to implement. First of all, we have recyclerView.adapter, which we have to implement. And each adapter is going to use a so-called view holder, which is going to, well, be the main part of where the performance comes from, because the view holder is responsible for minimizing the calls to find view by ID, which can be quite an expensive operation. So that's the second class we'll have to implement. But actually we don't need any class body for this. That's all we need for this class for now. And now for the habits adapter main class, you can simply go ahead and press Ctrl I in order to show all the methods that we have to implement. And that is going to be the three methods that I mentioned briefly before: the onBind view holder, onCreate view holder, and getItemCount. Alright, so now we have our overriding code for each of the methods. So let's take a look at what's wrong with this declaration here. So you can see down in the left bottom corner, this actually has a constructor, so we're going to have to call that constructor here by just adding two parentheses. So now we got rid of all the error messages, and now we're ready to implement all of the methods. The easiest of which is getItemCount, which is supposed to return the number of items we want to show in our whole recycler view. So this is just going to return habits.size. And of course, in this case, we're going to remember that a simple function like this we can actually write in Kotlin by just saying is equal to, and then we can also get rid of the return statement. So getItemCount is equal to habits.size. And in this case, we can then also get rid of the return type, because that's going to be clear from, well, the value habits.size. So we can easily define this method here in one line. So very concise again. And now all we have left to do is to create our implementation for onBind view holder and onCreate view holder. And that's exactly what we'll do in the next two lectures. So I hope to see you there. And again, if you have any questions in between, always let me know, and I will then try to get back to you as soon as I can. Alright, let's move on first of all with the onCreateViewHolder method. So this method is going to be called whenever the recycler view has to create a new object of this viewHolder type. And each of those view holders is going to contain the layout for one of the cards. So this is going to create a new viewHolder object, and a viewHolder in this case is going to be for one item, and one item in our case corresponds to one card. So what we're going to have to do, or what we want to do, is we want to return our habit view holder, and for that we're going to have to create some view here that we can pass in, and that view is going to be exactly coming from our card layout. So we're going to create a view object by using the layout inflator. Now in Android, when you go ahead and create or use a layout file and, well, want to use that layout on an item in order to apply the layout, it's called inflating the layout. So we're going to use the layout inflator, and we're going to say from parent.context. And you can see here that the parent is actually marked as a nullable type, which is not actually necessary here in this case, because this parent object here, as far as I'm concerned, will never be null at this point. So we can just call parent.context, and then we can inflate this with our resource ID. So that's going to be r.layout, and we call this single card. So that's our card. So this is our layout for one single card. The next parameters you can see here, you can show this by just pressing Ctrl P, is the view group that's going to be the parent. And that's all we actually need for the call to this method. And then we can simply return our habit view holder and pass in this new view that's going to represent one of the cards, which is going to show our habit. Now all that's left to do is to implement the method onBindViewHolder, which is going to define the contents for this card, because so far we've only used our layout here to inflate the layout. So it now looks like a card. It's using our layout from that we saw before, but we don't actually have any title, description, or image defined. And that's exactly what we can fill in this method onBindViewHolder, because now, well, from this pool of objects, when it's bound to a specific habit or a specific item in general, then at that point, the recycler view wants to just bind all the necessary texts like the title, the description, and so on to that object in order to make it look like for this object has always been for that specific card. But in truth, what's happening is that on the fly, the recycler view is going to reuse some object that may be used for habit 1 before, but habit 1 is not on the screen anymore, so you can just reuse that for, let's say, habit number 10. And so it's just going to go ahead and fill in all the texts for habit 10. It's going to reuse the card, basically the card in our layout from habit 1, because habit 1 is not even on the screen anymore. It's more efficient because you can reuse those items and those objects, and it just fills in all the contents on the fly. So I'm going to stop here at this point, and we're going to implement this method in the next lecture. So see you there. Alright, so now lastly, we want to specify, or let's say this specifies the contents for, let's say, the shown item, or the shown habit in this case. For us, the item is the habit. Let's just do it like this. And we can see that we want to show, let's say, I. So we want to show habit I. Or let's actually call this index. So we want to show habit at the position of index. So that's going to be from our habits list, index. And now from each of those habits, we have the title, the description, and the image. Now what we want to do with this is we want to access our habit view holder object. So that's the view holder that we're currently binding to. And that's just a parameter to this method here, right? So we have holder is a habit view holder, and it's actually nullable here. So let's say save call operator. And then in this view holder object, we can access the view that we're using inside there. So that's going to be our card. So this now just refers to the argument in the constructor here called IV, because we have an object of type habit view holder, and our habit view holder here has this view which is just named IV. You can of course make this a bit clearer by just saying card. That would probably be better. So we say card, because when we return our habit view holder here, what we're doing is we're actually making this view here a card layout. So it's much more readable to say that the view inside our habit view holder is actually just a card. So we can now say holder.card. And then inside here, we should be able again to use the Kotlin Android extensions to access, for instance, TV title. But I noticed that this doesn't seem to work as well. So what we're going to do is we're going to say if holder is not null. So we're going to do this just the traditional way. Then it's going to smart cast the holder to a non-nullable habit view holder. And then we can go ahead and say card.tv title, for instance. So that's our text view for the title. So we want to set the text to our habits list and our habits object at position index and get the title. And of course, we want to do the same thing for the description. So TV description, and then also for the image. So this is just called image. And here we have our image view icon. And here we actually want to set the image, set image resource. And we're going to set that to habits at index.image. So this way now we have again null safe code. What we can also do, because we're using this here 3 times, is we can actually just get rid of this and put that into a variable called habit. And we could do the same for holder.card, but I'm not going to do that for now. But for the index or for the habit, I think it makes sense to just store a variable beforehand. So now with this, let's go ahead and run our app. And well, let's see what's going to go wrong with the implementation and then try to fix that. So I still have my virtual device running. Now we're just going to have to wait for the Gradle build to finish, and then it's going to open up the app automatically. So here we go. You can actually see that everything seems to be working already. So we have our recycler view now with 2 items. We have go for a walk, a nice walk in the sun gets you ready for the day ahead. And we also have our habit, drink a glass of water. But what I don't find too great at the moment is that you can actually really see that these are cards, because there's just some slight problems in the layout. So for one, I want to go into the main file here in our recycler view, and we can actually get rid of some of the lines here and just add some padding to this. So I'm going to set 8 dps of padding. And then in the single card layout, I'm also going to set some margin on each of the cards at the bottom. So here I'm also going to say 8 dp, and then we can simply use this button here to apply these minor changes more quickly, because as long as you only make changes like these to some of the layouts, you can just use this button to really reflect the changes a little faster in your app. So this way now you can see we have some padding here at the sides and at the top in our recycler view. And we also have this gap now between each of the cards, which makes it clearer that they were actually cards and that we have 1 card per habit. Now one more thing you can do if you want to is go into your card view and just increase the elevation a little bit so that it becomes a bit clearer. So this is part of the material design. You can go ahead and set the elevation of a card, which is basically on a conceptual level how far the card should float above the recycler view or above the screen. So it's going to change how far the shadow actually falls from the card. So you can see here that this doesn't really seem to make a lot of a difference if we have 24 dp, but you can just try out and see how the drop shadow here below each of the cards is going to behave with different values for the elevation, just in case you want to go ahead and have a clearer drop shadow for each of the cards. But for now, I'm not going to get too busy with the layout, because here in this course, we really want to focus on Kotlin and how to develop cleaner code. So if you have any questions left about the habits adapter, where we use the recycler view.adapter and implement that, and also use recycler view.viewholder to define our own view holder, which is basically just an object that stores a reference to the view. In this case, each of those views is just going to be a card view, so that we can then reuse them later on and say when this view holder is bound to some specific habit, we're just going to update all the contents of the card in order to quickly show different habits or different cards when the user scrolls to the list. Now, what did we learn from this when compared to Java? So again, we have more concise code because we can use the Kotlin for Android extensions here again. Then next we have null safety, because anytime a type can actually be nullable, and I'm not actually sure the holder here can ever be null, so it might also be that you can get rid of the question mark here. But when interoperating with Java, you can always define whether, well, in this case here, this can actually be null or not. So that's just a decision you're going to have to make as a developer to see whether when using this in Kotlin it's a nullable type or not. And let's say here, when this is a nullable type, then in Kotlin you always have the compiler errors or warnings telling you to check for nullability first. So it's really hard to make a mistake. The only way you could make a mistake is to not check for null and just use the double exclamation mark. So obviously, this is something you shouldn't use in your code ever if possible, and very, very judiciously if it really is necessary. And unfortunately, in other Android or Kotlin for Android courses, you see people using the double exclamation mark all over the place. And really, if you see something like that, just do it better, or really just skip the course, unless it really teaches you something about Android maybe. And really try to think for yourself and see how you can improve the code. Because, I mean, if the holder is null in this case, then checking for null is not really hard to do. And it's also not hard to just use the save call operator here in order to only set the text if there actually is a holder. If there's no holder, of course you can't set the text, so you can just use the save call operator instead of the double exclamation mark. So again, if you see other courses about Kotlin for Android, really just try to think about what they're doing and how you can maybe do it better. And the same also goes for this course. You should always try to see what might be a problem with some of the code and try to see how you can avoid this problem or do it in some better way. But of course, at this point, we're only getting started, so we're going to see other cases where we can improve on Java code. And with this, I hope you will also be able to really recognize some of those situations in which you will actually be able to use Kotlin or use some other concepts in general in order to avoid such problems. So for now, I'm going to leave you with this. If you have any questions left about the code we used here, just let me know in the Q&A. And otherwise, this is our implementation for the recycler view, very common task in Android, and now you know how you can do this in Kotlin. So now let's move on with other fun stuff, and I hope to see you again in the next lecture.
Alright, so the next step in our app is that we want to let users create new habits by themselves. So if a user decides that he wants to eat more fruits, for instance, then they should be able to just add a new habit, and it should then be shown on the app, of course. So this will prepare for us this section also later on how to use SQLite, because we're going to have to store all those new habits that the user creates in a database. And in this section, we're going to prepare for all that by creating a new activity, seeing how to switch between activities, creating a menu, creating the layout for the second activity, and then also seeing how we can let a user choose an image from the gallery and just those kinds of things. So again, very common tasks on Android. And we're going to see how we can do all that using Kotlin. And then, as I mentioned in the next section, we're then ready to include SQLite in our app. And that's going to prove many ways for us to improve the API in our code using extension functions, higher order function, and so on. So that's going to be the main part where we can see how to really improve the code using Kotlin. Now in this section, let's go ahead and move on with how to create new activities, switching between the activities, and all those kinds of common tasks, and how to do this in Kotlin. So with this, I'm going to see you again in the next lecture, where we actually dive into the code.
Alright, so first thing we want to do is create a new menu or add a new menu to our app. So we're going to go into our resources folder here and go ahead and say Alt Insert to then create a new Android resource directory, which will then be very easy in Android Studio. We can just select the resource type here, in this case menu, and then we can just go ahead and let it create that. So now we have this resource directory for all our menus. So we can go ahead, create a new menu resource file, and I'm just going to go ahead and call that main menu. So now we already get all the skeleton code for free. We can simply go ahead and add a new item, give that an ID, for instance, let's say add habit. Then we're going to give this a title, which I'm going to say is begin new habit. Then we can go ahead and first of all extract a string resource, and I'm going to call that begin habit. And we're going to say that it should be shown as an action in the menu only if there's room available. So now we can close this up and we have our menu item defined. Now I want to quickly jump through the string resource that I just created using Control B, and then go and use the suggested characters here, which is going to replace the 3 dots with, well, smaller 3 dots that aren't going to take up as much space. So with this, we already have all our layout code, our resource code for the menu ready. Now we're going to have to again override some methods in our main activity, which will then basically attach that menu to our activity. So I'm going to stop this lecture here, and in the next lecture we're going to override all the necessary methods in order to then attach this menu to our main activity. Alright, so inside our main activity here, the first thing we'll need to do to attach our menu is to override a method called onCreateOptionsMenu. You can simply browse through all these by using just the first letters of all the, well, uppercase letters. So to find onCreateOptionsMenu, it would actually be enough if I were to go ahead and say onCreateOptionsMenu, OCOM, and that's the fastest way to find the method you want to override. Then you just hit enter, and it's going to come back with the default implementation, just calling the super method. Now inside this onCreateOptionsMenu, it's also actually not necessary to assume a nullable type here. And then we can just use the menu inflator and then use inflate. We're going to define which menu we want to use. So again, using the resource ID. So this is what we called it. This is our main menu.xml. And we're going to inflate that into this menu object that we get into the method here. So this is just going to get our layout, and it's going to inflate that into this view here, into this menu object. So now we should return a Boolean that's just going to express whether we were successful. So let's just say return true because we successfully inflated the menu. So with this code, we could already go ahead and restart our app just to see whether the menu is already shown or not. Alright, so now once our app restarts, you can see we now have this menu entry here, begin new habit. So that's what we're going to be able to click later on. For now, when I click this, nothing's happening. That's what we're going to have to do in the next step. But you can see we now have our menu, our layout at least, attached to the main activity. And that's done by onCreateOptionsMenu. So when you're in an activity like this, you can see that you have lots of lifecycle methods. So the activity or the screen goes through lots of lifecycle steps, like onCreate, onStart, onResume, onStop, onDestroy. So onCreate is of course when the activity is created, and that's where we go ahead and define our main layout, our main elements, in this case our recycle view, and set everything up. And onCreateOptionsMenu is the lifecycle method, which is simply called once the menu should be created. And usually there's just nothing done in there, so there's no menu attached by default. But if we override this method and just attach this menu to our class, then as you can see, we have a menu in our activity. And that's also the kind of way you often do this in Android. You have to override lifecycle methods of the activity or listeners of the activity in the next step in order to define the behavior of your app. So now in the next lecture, we're going to actually go ahead and create this new activity, so that we can then also go ahead and switch to that activity or that new screen when the user clicks on Begin New Habit. So I hope you're excited about that, and I'll see you again in the next lecture. Okay, so now it's time to create our second activity for our app. So let's go ahead and go into our package here, in my case, Computism of Habit Trainer. And I'm going to go down here, create a new activity. Again, I'm going to select an empty activity, so I'm going to do everything by myself. And now this one I want to call Create Habit Activity. And again, I'm going to auto-generate a layout file and going to make this backwards compatible. So now this looks very similar to what our main activity looked like in the very beginning. We just basically have an empty activity with a default layout. That's again just a constrained layout that we can of course customize later on. But for now, all I want to do is go into the main activity again and then add the functionality that will allow us to switch to this new activity. So to do this, we're going to have to override a method called onOptionsItemSelected, so OOIS. And this is just basically a listener that's going to be executed once an options item is selected. And an options item is just a menu item on Android. And now in here, the first thing we want to do is we want to check whether the item that we get, and again, it's not necessary to make this a nullable, I believe, because once you do click on an item, there's also going to be a menu item that's associated to the click. So now we can check whether the item ID of the selected item is equal to our r.id, and then I believe we called our menu item at habit. So that's the ID. When you go back to main menu.xml, the ID of this exact menu item. So now what we're doing here is we're checking which menu item was selected. Of course, at the moment we only have one, but later on you want to differentiate between which of the items was checked. So that's how you do this. And now we want to switch activities. And the way you do this in Android is you create an intent. And an intent is just an object of this intent class that we're going to have to import, of course. And then the first parameter here is again just a context. The context is this activity. So an activity is also context, so we can just pass in this. And for the intent, this basically refers to the source of the intent. And now the next thing we want to define is the target of the intent. And that's our new create habit activity. And normally in Java, this is .class. But now .class actually refers to a Kotlin class. So what we want to do here is we want to access the Java class. And the way you do this is you use a double colon and then use class.java. Now again, without .java, this would actually refer to a Kotlin class in the bytecode, but this reference also stores the actual Java class as a property called Java. So we can just access .java in order to get the correct class reference here that we want to use for our intent. So this basically just means that the target or the destination of this intent is the create habit activity. And now we can just go ahead and call start activity and pass in this intent, which is essentially going to switch from this activity to the create habit activity. And again, we should return a Boolean. Let's go ahead and say return true. So now at this point, again, we're ready to restart our application in order to see whether we can actually switch activities on menu click. All right, so back in our app, we can now click on begin new habit. And you can see we actually get into this beautiful new activity with a completely just white screen, but at least we still have our title. And that's just exactly our layout defined in the activity create habit. There's just a constraint layout, so just a container without any actual elements inside it. There's also no hello world. There's just an empty activity for now. But we did reach our goal of switching activities on the menu click. So that's all we wanted to achieve in this lecture. So you can simply go ahead and override onOptionsItemSelected, check for which of the items was actually clicked, and then perform some kind of action you want to do. In this case, we want to send an intent to switch activities to the create habit activity. And then we simply call start activity on this intent. And this is generally how you switch screens on Android. And you could actually also modularize this into your own function, which would just take care of these 2 lines of code. But later on, we'll see that there are also other kinds of intents where this code is a little bit different. So you might want to see whether that's actually useful for you or not. So you could go ahead and just say Ctrl-Alt-M to just extract a method from this. Let's say switch to, or just switching to an activity. For now, we can make this private. And actually, I don't want to have this fixed. Instead, this should be the parameter that we pass in. So switch is just going to switch from the current class to some other class. So let's say we have this parameter C, which just refers to any class. And then we can pass this into the intent. So you can get the signature for the type here. You can actually just look at the signature of the intent constructor. You can see that it's a class of just anything. So the stars, like a wildcard, should just be a reference to some class. And then you could just call switch create habit activity. You could actually also call this, let's say, switch to create habit activity. I'm going to say do refactor. Let's see in comments. This one we don't want to do. And we have this one. So let's now go ahead and say do refactor. So this way you could simply write switch to create habit activity. That's of course a bit more readable. So this could be one kind of utility function you can use, but this is not something that's special for Kotlin. You could do the exact same thing in Java as well. All right, so that's how we can switch between activities. So now let's move on in the next lecture to really finish up our new activity and to add some actual action to it. So let's now move on to the next lecture to actually add some or give some life to our new activity, where the user can then create a new habit by just filling out a form and then submitting that. All right, so let's get started with creating the layout for our create habit activity. So first of all, I'm going to get rid of the constraint layout here. And instead, I'm going to go ahead and use a linear layout that's just going to put all the elements stacked from top to bottom. I'm going to add a bit of padding to this, 8 dp, just to have some white space on the sides. And then let's see what we want to have. So first of all, we want to have an edit text. It's going to be the same width as the parent, and it's only going to be as high as it needs to be. I'm going to give this an ID of edit title. Well, let's keep it consistent with the rest of our code. So et for edit text, and this is going to be for the title. And I'm also going to add a hint to this, which is going to be the default string that's going to be shown. So let's say this should be eat an apple. Then I'm going to go ahead and extract a string resource for this. Next, we want to have an edit text for the description. That's also going to match parent and wrap content. I'm going to give this an ID of, let's say, et, and then description. And I'm going to use the input type property to say this should be multiple lines. So the user should be able to input 2 lines in this case. So I'm going to set this property to 2. And you can see you can make heavy use of the suggestions from Android Studio. The hint here, for instance, I'm going to say an apple a day keeps the doctor away. And again, extract a string resource for this. So apple description. Then next, we wanted to have a button. That's just gonna say this should just be as wide as the rest of the page. And I'm gonna give this an ID, let's say button choose image, because that's what it's for. And we can set the text for the button to be choose image ... Again, we can extract a string resource from this. I'm going to call this choose image. And I'm also going to jump to the declaration here, just in order to replace the 3 dots with this UTF-8 character that we can use instead. Then I'm going to jump back. I'm going to make some space here so you can better see what I'm doing. But this is basically all we need for now for the button. The next thing we wanted to have was a image view that's going to be used just in order to preview the image that the user selected. So I'm going to give this an ID of image view image, just very creatively. And I'm also going to add a gravity to this, which is just in order to center this. So I'm going to center this horizontally just in order to improve the layout a little bit. I'm also going to add some padding to include a bit of white space in our layout. And then I actually want to have the width just to wrap the content, because only then can we center this horizontally. If it takes up all the space, there's nothing to center. Now again, we can set a content description, which in this case would be just selected image. Again, we can extract a resource from this. And then next we want to have a button that's just going to be there in order to save the new habit. So this one I'm going to give the ID button save. I'm going to say the text should be, let me scroll down a bit, just save habit. And that's all we need for now for this button. So now the last thing we wanted to do is want to add a text view, which can be used to show an error message to the user in case he forgets to, for instance, add a title or a description. So I'm just going to call this text view error. And by default, I'm going to make this invisible. We can change that later on when there is actually something to show. And then I also suggested you actually modify the text color. Now the text color we can set to some value we want. We can use a hex color, like red would be something like this. But I actually also wanted to go ahead and let you explore the material design color suggestions. So for this, let's now take a look at the browser. So here you can see I'm on material.io/guidelines/style/color.html. And here you can see all the recommendations about color in the material design specification. And you can also see we have the color palette here, from which we can just choose any color we like. So let's say we want to choose a red color, and let's actually go for this kind of medium red. So that's going to be the code we want to use. That's the hex color definition. So now with this, we can just copy this and go back into the code. And inside here, we can simply use that as our text color for the image text view. So this website here is really a nice way in order to find some colors you can use. It also gives you some recommendations as to which colors to combine and how to combine them. So you can just browse through this a little if you want to. You can see some examples from Google and how they recommend you just combine colors and use colors on your app. But for now, we want to go back to the code. So all we wanted to do here was to add a red color to our error text view. And one thing I was missing here, one of the hints I also gave you, was to use the orientation and set that to vertical. Otherwise, all your elements are just going to be on the horizontal axis, which in this case is really not what you want to do. So with orientation vertical, we're just going to have the edit text at the top, then the next edit text below it, then the button below that, and so on. Alright, so with this, let's actually go ahead and try to use the lightning symbol here in order to quickly adjust our app and see if this is already enough or whether we actually have to restart it. So you can see we're still here in this activity. So if everything goes fine, it should just update the current screen, the current view that we're in with this new layout. Alright, so now you can see it actually restarted the whole app. So now we're back in the main activity. So let's go ahead and click Begin New Habit. And now you can see we actually have our edit text here with the hint, eat an apple. We have our description, which is actually also 2 lines. So you can skip into the next line and type something there. And the hint is an apple a day keeps the doctor away. Then we have our button choose image, which doesn't do anything when we click on it yet. And also we have this button save habit, which also doesn't have a click listener defined yet. So really at this point, we just have our UI without any functionality. And that was exactly our goal with this lecture. We have this image view here that doesn't really show anything yet because there's no drawable assigned to it. And it's only going to show up once you actually choose an image. And we also have a text view for errors down here, which by default is invisible. So that's only going to show up when there's actually something to show to the user. All right, so much for the layout. Now it's time to really jump into some functionality again and to write some Kotlin code. All right, so next thing we want to do is let the user choose an image for the habit that they're creating. So we can go ahead in our XML and actually define an on-click event. And now inside here, we can just put the name of a method that we then have to implement. So I'm going to just call this choose image. And currently this method doesn't exist. So we can go ahead and just say create on-click event handler. And that's going to go ahead and create that in the create habit activity. And unfortunately, That doesn't seem to work. But now when I go ahead and say create choose image of view, so it also should have a parameter here, then hopefully this is going to work in Android Studio. No, it doesn't. So let's just go ahead and create this ourselves. So we're going to go into create habit activity, the activity that's well related to this layout file, and we're going to create a function called choose image, and it should have a parameter of type view. And we're going to import this. So now inside here we can define the code that should run when this button is clicked. And now what we want to do here is we want to tell the Android system that the user should choose an image. So this will normally open up the gallery or maybe the camera or some way that the user can then select an image. So again, what we want to do is we want to create an intent, and this intent is now to actually select an image. So it's a little different from the last intent we had. We can define the type. So this is the type of content we want to have, or the type of content we want to request with our intent. And we're going to put in here image/star, so some kind of image. And also we have to specify the action of the intent, which is just going to be intent.action_get_content. So we want to get some content back from this call. And more specifically, we just want to get back the image. So now we can simply let the Android system decide what kind of, well, app or what kind of chooser should actually be created for this. And we can use intent.createChooser, pass in the intent we just created, and add some title that we want to be shown when this intent is fulfilled or when the app where we get our image from is called. And we're just going to call this choose image for habit. So this way now basically Android goes ahead and tries to find the best app with which it can fulfill this intent, which is to get some image. And well, normally that's just going to open up the gallery or a gallery of some kind that the user has defined as the default app. But really we don't care too much. We just want to, well, get an image back. And we don't really know what kind of app will actually be chosen for that purpose, but it also doesn't really matter for us. So now we could go ahead and use start_activity like we did before, and then pass in the chooser. We're going to see later that we're actually going to do this a bit differently in this case, because we don't just want to start the activity, we actually want to start the activity and get some result back. And that's going to be a little different, but that's what we're going to do in the next lecture. For now, I just want to introduce the concept of logging as well. So in Android, you can simply go ahead and say log, or import the log class from android.util. And then, for instance, for debugging purposes, use D. So that's for debug. There's also E for error. You have W for warning, N for notice. Okay, you don't have notice, but you have E for info. So in this case, I'm just going to go ahead and use debug. Then the first argument is just a tag. That's usually the name of the class. I'm going to store that into a value later on. So tag, that's where I'm going to store it in. And then we can log some message. In this case, I want to log for myself for debugging purposes that an intent to choose an image was sent. And I'm going to go ahead in the class here, define my private tag value. And that's in this case going to be create habit activity dot class dot simple name. So this is always the way you can get the name of the class, and you can, well, put this into a tag value, which is also a good practice, I would say. Okay, it looks like as if we need Kotlin reflect for this, so let's just go ahead and use .java.simplename, because that's going to work without any extra functionality here. So now we have our tag, and whenever we want to log, we just pass in the tag as the first argument and then our actual log message. Alright, so with this we have our intent ready to go, which is going to tell the Android system that we want to select some kind of image, and Android is just going to go ahead then and try to find a way to fulfill that purpose. So let's just go ahead and test whether when we click on the button we're actually being redirected to some app where we can then select an image. And then in the next lecture, we will then go ahead and actually get the image back from the intent. So here we are back in our app. So let's begin a new habit. And I'm going to say choose image. And you can see there's some activity started, which is here the gallery. I have actually used the camera to create one image. So if you go in your virtual device, there won't be any images by default, but you can go ahead and just open up the camera. So slide this one up, open up the camera, and then take a picture, which on the virtual device is going to be a little bit weird. You're just going to have this red box floating on the background. Oh, now it's a green box, so you can take a picture here, and then you can choose from that later on in your app. So here in Habit Trainer, we are redirected, as I would have expected, to a gallery app. Then the user can just select an image here, and then we're going to be back in our app. But as you can see, currently there's nothing happening. We don't even know what kind of image was selected, and we don't get any information or any data back from this call. So now let's go ahead into the next lecture to try to change that. All right, so now let's go ahead and actually get back the data, the image that the user chose, and then show that as a preview in our image view. Now the first change we'll make is we're going to not call start activity, but we're going to call start activity for result. And then we're going to have to pass in some request code, which is just an identifier for us in order to know what kind of request we're currently getting back. And this is going to become clearer in a minute, but for now I'm just going to define a request code up here. I'm going to say val, and let's say we're going to call this choose image request, and just give this a value of 1. This is just for us to know what kind of intent this is. So choose image request is our request code. And then again, we'll have to override a lifecycle method here, in this case called onActivityResult. So result. And here we have it. So just press enter in order to override this. First of all, we can call super.onActivityResult if there's anything to be done. And now we'll have to check whether we're getting back the correct code. So let's say if request code is our initial request code. So it might be some other intent that's coming back to us. When you have multiple intents, you're going to have some way to differentiate between them. And that's exactly what the request codes are for. So we're going to check that this is actually for choosing an image. And next we want to check whether our result code is equal to result OK. So this is just a static constant that's defined in the activity class. And then the last thing we have to check, or the two last things we have to check, is whether data is not null and data.data is not null, in order to check whether there's some real data we want or we can read from. So now we know that the user has chosen an image. So let's log that event. Let's say an image was chosen by the user. And then we can go ahead and try to read the bitmap. So the bitmap of the image is kind of the data that you can then use in order to show it. And I'm going to say I'm going to create a method called try_read_bitmap. I'm going to pass in the data, and then later we can show this bitmap in our image view. For now, let's say we want to have this method. So you can also go here and again let Android Studio create a function called try_read_bitmap. And actually what I want to do is I want to pass in data.data, so that's going to be URI. So let's change this signature here to URI. And what I want to return is a bitmap. So I'm going to import all those classes. And then what we'll have to do in order to get a bitmap from this return value or this data from the intent is we'll have to create a try block in which we can use mediastore.images, because we're trying to read an image, .media.getBitmap. Then the first argument here is a content resolver that's available in the scope here. And the second argument here is a URI, so that's just going to be our data. Now in Java, this here would normally be getContentResolver, which is available in the scope. But in Kotlin, as you know, you can also just directly access the property, which internally is going to call exactly that method. So then in the catch block, we want to catch an IO exception in case we can't actually read from this source. And I'm just going to say I'm going to print the stack trace for now. And then this is actually already the return value. So remember that the try block here is actually an expression in Kotlin. So this line here now defines the return value for the try block, which is exactly a bitmap. In the catch block, I'm going to say that the return value is going to be null. If there's no bitmap that could be read, so if there's an IO exception, this is going to return null. So the return value is now a nullable bitmap, but we can quickly get rid of the null in our code because we get this here. So bitmap is now nullable. And now we can keep the scope of this nullability very small by just using bitmap.let right here. And then only if the bitmap is not null, then this block of code here will be executed. So what we want to do here is we want to access our image view. So IV image, we want to set image bitmap to our bitmap here. And then we can also again log for ourselves that we read the image bitmap and updated the image view. So now with this, we can go ahead and try to run our app again and see what's going to happen. And now what I want to do here as well is to check out the log cat here. So that's going to be where our log messages are going to be printed. So you can just click on this, then select the correct device, select the current process that's running on there, and then you can see all the messages in this screen down here. So now when we go ahead and create a new habit and then click on our choose image button, we can see that here intent to choose an image was sent. That's our log message right here. Then let's say we're going to select this image. And you can see that we actually have our image view updated here. You can also see our log. An image was chosen by the user. And you can see also read image bitmap and updated the image view. So everything's already working as expected. The user can now choose an image. It's going to be shown here as a preview. And then we only need to have a title, a description as well. And then the user can go ahead and just save this habit. Alright, so now we also know how to create an intent for a result. So starting activity for a result, we have to use a request code, then override on activity result, check for that request code so that we know that this intent is now coming back from our choose image request, so that we know that what we can do with our data here is actually try to read a bitmap from it and then update our image view with that bitmap. And again, we always handled null here explicitly. We have data is unequal to null. Then you can see we have a smart cast here because data unequal null is already checked. So it can't be null here anymore. So this is also, again, using Kotlin smart casts. And then we use try read bitmap, where we use the try statement actually as an expression, return a nullable bitmap, and got rid of the nullability here of the bitmap type right away in the next line using bitmap.let, so that the code inside here will only be executed if there is a bitmap that could be read from here. If there's a request coming back and we can't read any data from it, we're just not going to show that image bitmap, and we're not going to be able to save this new habit unless the user chooses a different image. Alright, so that's it for this lecture for the intent to choose an image and then getting the data back. If you have any questions left about this, as always, just let me know in the Q&A, and otherwise I will see you again in the next lecture. Alright, so now we're done with our choose image functionality, which is defined or implemented in this method, choose image. So let's now move on to the next one. In our XML, first of all, we can go ahead to our next button, which is called button save. And again, I'm going to define the onClick property, and I'm going to call the method that I'm going to create store habit. So now again, since this doesn't seem to be working as well, I'm just going to go ahead and do this manually. So let's actually go above choose image, and I'm going to create a method called store habit. Again, this must have a argument of type view to be a click listener for our button. And now inside here, we want to check whether the title, the description, and the image have all been chosen. And only then can we go ahead and actually use an SQLite database to store our habit. And that's going to be the topic of our next section, which is going to be really fun because we're going to have lots of ways to improve the code in Kotlin when compared to Java, because SQLite databases have lots of ceremony around the APIs. But for now, we're going to stick to this one here, and we're actually just going to check or validate the inputs and use our error text view in order to show to the user if there's anything missing. So the way we could do this, first of all, is to go ahead and say edit text title, then get the text from this. We'll actually have to use toString to get the actual contents of this text view, and then call is blank. So if this is blank or the edit text for description is blank, so toString is blank, then first of all, we want to go ahead and log for ourselves that we didn't store any habit, no habit stored. There's a title or description missing. So this way you can always trace nicely in the logcat what's going on and why a habit might be stored or why it might not be stored. So if this is the case, I'm just going to say return. So we're going to end this here, and then else if. And now I want to check whether we already have an image bitmap that has already been chosen. And in order to do that, I'm actually going to have to create on the class level here a new variable called image bitmap. And that's going to be a nullable bitmap. And I'll have to initialize this with null for now, so that down here, when choseImage comes back and we actually are able to read a bitmap here, so this is not null, then I'm going to say this dot image bitmap is equal to this bitmap. So once the user has chosen a valid image, then our class variable here is not null anymore. And from that time on, we actually also know now that it's not going to be null anymore, because we don't ever set the variable image bitmap to null except for the initializer here. So now let's say else if bitmap is null, then this is very similar. We can log for ourselves that again no habit was stored, and in this case the image was missing. Alright, so far so good. What we're not doing yet is we're not displaying an error. So let's create a function called display error message. And I'm going to put this into a function because we're going to use this very similar kind of code in both cases here. So in this case, let's say we want the user, or we want to tell the user that your habit needs an engaging title and description. So that way the user knows why the habit can't be created. And then in this case here, we're going to tell the user, add a motivating picture to your habit. So now I can go ahead and create this function here called display error message. It's going to take in a string, and then we want to just access our error. So that's text view error, set the text to be the string that we get in, and I'm actually going to refactor this and call this message. And then remember that this is invisible, so we're going to have to say TV error dot visibility equals view dot visible. All right, so this way we're avoiding to duplicate code because we're using the function display error message, and we're not actually working with the error text view in this case and then again in this case. Now, if all is fine and we come into this part of the code, then we want to store the habit. So this is going to be what we're doing in the next section, where we're going to use SQLite databases and see how to use them in Kotlin. But for now, let's just go ahead again and test what we've done so far by seeing what's going to happen when we click on the save button, but we don't actually define a title or a description. So you can see it's going to come up here again with the app. It's going to restart. So let's say begin new habit. We can also again open up the logcat to see what's happening. So let's first of all just try to save without doing anything. So it's going to come back with your habit needs an engaging title and description. So let's go ahead and say eat. And I believe I was able to actually use my computer keyboard to do this at some point in the past, but I can't seem to do this right now. So I'm just going to use the virtual device keyboard here. So now we have a title, but we still don't have a description. So that's correct that this is shown. So I'm just going to put ABC here for now, save habit. Now it's going to come back with add a motivating picture to your habit. So let's go ahead and choose an image. And I'm going to use this one this time. So now let's try to save the habit. And we can see that it didn't change anything because we're not going back to setting the error text view to be invisible again. Because later on it's not going to be necessary because, well, when we store it, the whole activity is going to finish and we just get back to the main activity. But you could go ahead and just say TV error dot visibility down here should now be invisible. So view.invisible, and then you should get rid of this bug. But for now, I'm not going to worry too much about this because in the next section, we're going to go ahead and implement this functionality anyway in order to just store the whole habit and go back to the main activity. And before we move on to that next section, there's only one thing I want to improve in our code by using one of the many features of Kotlin. So let's go ahead and do that in the next lecture. All right, so just one small improvement, or one thing I don't really like about this code is that when we have an edit text here, we have to call .text, .toString, .isBlank just to check whether there's some text in the edit text or not. So what I want to do here is I want to use the concept of extension functions in order to make this code a little more concise. And to be honest, also to prepare you a little bit more for the next section where we're going to make heavy use of extension functions. So I just want to also reiterate the concept and see how you can apply this. So also one mini challenge in between, if you can, try to create an extension function on the edit text class by yourself so that you can simply go ahead and say et title, for instance, .isBlank without actually referring to .text, .toString. So please pause this video here if you want to do this by yourself. It's really just one line of code. And if you can remember how to create extension functions, I don't think you're going to have a problem. So now I'm going to go ahead and create this extension function myself. So I'm going to go ahead and say function, and we can actually also make this private for now. We just want to use this in here. Although you could also make this a general utility for edit text. In that case, you might want to make this public. So now I'm going to say private fun edit text dot is blank. So this is going to return a boolean, but I'm not going to have to write this out myself. I'm just going to use the shorthand syntax. I'm going to say is equal to this.text.toString.isBlank. So very simple extension function. Can actually also go ahead and put this out of the class. Just put it at the very bottom. So it's now on file level. And then we can just go ahead and use it inside this file here. And go into our et title and et description validation and just call edit text.isBlank. So this is, I think, a lot more readable, or at least a lot more concise. You just want to know whether the edit text is blank or not. All right, so just again, to create an extension function, just use the function keyword like always, then prepend the class that you want to attach the function to, and then it's just the normal function syntax basically. You could also go ahead and define the return type, like Boolean in this case, but of course the compiler can just infer the type here, and then just define your function as usual. All right, so that's just a quick recap and also makes our code a little bit more readable. So this was just a quick recap of extension functions, which, as I mentioned, are probably the most important feature or concept for Android app development, because you can make heavy use of those in order to avoid all the ceremony around many of the Android APIs. And we're going to see that much more in the next section when we actually use SQLite databases. So I hope you're excited about that. It's definitely going to make your code much more easy to read, much cleaner, and also more robust. So I hope to see you again in the next section and in the next lecture.
All right, great. So at this point, we are finally ready to include SQLite databases in our app. And that's going to be a very nice task. We're going to see how to do all that in Kotlin. And we're especially then going to take some time to improve many of the parts in the code that really should be much simpler than they are, unfortunately, using the Android APIs. So there's a lot of ceremony around database transactions. There's also a lot of ceremony around getting the data from a cursor to the database. And I'm sure you're familiar with those things if you've used this before in Java. So we're going to take quite a few lectures here to then really improve on the code and see how we can apply extension functions, higher order functions, and those kinds of concepts in order to really make our code much more readable and much more concise. So I hope you're going to learn a lot from this section. If you have any questions along the way, please let me know anytime in the Q&A. And otherwise, without further ado, let's now dive into the code and implement our SQLite database.
We are now at the point where we want to actually store a habit to a database once the user has entered all the info for the habit. So now in this section, we're going to create an SQLite database, which is a standard database for Android, which is just going to store the database in a file on the local file system on the device. And we can then write entries to the database and we can read from it. So what we'll do in this section is we're going to define the schema and the contracts for the database, which is of course going to be just a very simple database with just a title, a description, and an image. And then we'll really go into the details of how to use SQLite databases in Android. And we'll see a great way, or many great ways, to really make the code much more concise and also more readable, and just writing cleaner code when using Kotlin. And in order to do that, we'll make heavy use of extension functions and of higher order functions in Kotlin. So it's going to be a great section to really see how we can apply all those features to really improve the code in our app. And along the way, we're also going to see how we can write stuff to the database, how we can read stuff, and just general concepts around databases. All right, so without further ado, let's go ahead into the next lecture to start actually coding. All right, so the first thing I want to do in this lecture is to define the contracts for the database, which is just a good practice in order to really have all the schema for the database, so all the fields you want to store defined in one place. So I'm going to go ahead and inside this package, I'm actually going to create a sub package for this called db. And inside this, I'm going to put all the files that are related to the database. And the first one, I'm just going to call contracts. And inside this file, I'm just going to define on the file level some of the constants and objects revolving around our database and how we're going to use it. So the first thing you want to define for a database is a database name. So I'm going to say here that our database should be stored in a file called habittrainer.db. So just our app name, and you're going to have the .db as the file name, or rather file extension, I should say. And then you have a database version, which you're going to start at 1 or 1.0, which is then usually written as 10. So you just imagine that there was a dot here in between. You could also go ahead and just use it 1. And later on, we'll see that when we make changes to the database, we'll have to update this database version, which is then gonna actually trigger our database to re-implement or recreate itself. But for now, those are just the two basic values you want to have. And now let's go ahead and actually define what kind of fields we want to have for our habits. So I'm going to make use of objects in Kotlin. I'm going to create an object called habit entry. And this should extend from the base columns interface in Android, which is just an interface you can inherit from when you're defining a schema or all the fields of a table in your database like this. So a habit entry is just the definition of an entry in the database. And for a habit, of course, we want to store first of all, well, generally we want to first have the table name. So the table name for this should just be habit. And then we define the names of all the columns in that table. So for instance, the title column should be just called title. Then we want to have a description column and we'll call that description. And then last we want to have an image column and that's going to be called image. So the columns in the database just refer to what kinds of fields or what kinds of info you want to store for each entry. Now an entry here is a habit. So again, those are just the three kind of attributes that you already know that we have for all the habits. So with this, we've now defined our database name, our initial database version, and we've also defined our only table we're going to have. So this is the habit entry. It's going to be in the table called habits. And inside this table, we have three columns which will store the title, the description, and the image for each of the habits. So this contracts file here is basically just a list or a set of info or data of names we want to use inside the rest of our code that we're going to use in the next couple lectures. So if you had multiple tables in your database, you could simply go ahead and add something like user entry and then just define all the columns you want to have in that kind of table. But we only have one for now that's going to store the entries. And now in the next coming lectures, we're going to implement the rest. And in the next lecture, we'll start off by creating our SQLite database helper, which will then more clearly define the schema of the database using actual SQL syntax. So let's go ahead and move on to the next lecture. All right, so as I promised now in this lecture, we'll go ahead, create a new file. Of course, we're going to make this a Kotlin file, and I'm going to call this habit trainer DB, which is going to be our database helper object or class, which will be used to actually create and then also destroy or recreate the database. Now, the first thing we'll need is inside our constructor, we want to get a context because that's going to allow us to actually have access to some of the Android system context so that we're going to be able to actually store stuff to the file system. And then we want to extend this class called SQLite Open Helper. We're going to pass in all of the constructor parameters. So first of all, it's going to need the context that we have. Then the name here is going to be the database name, which comes from the contracts file. The factory we don't need. And then we have our database version. And with this, we can now open up this class to define all the implementation. And as you can already see, there are some methods we're going to have to implement. That's why we have the red squiggly lines here. So let's just use Control-I in order to see what those methods are. So we have onCreate and onUpgrade, which is going to define what should happen when the database is first created, and also what should happen when the database version is actually increased. So that means onUpgrade. This will be executed automatically, for instance, when you upgrade the database version from 1.0 to 1.1, so from 10 to 11. Now, in order to implement these two methods, we'll actually have to create the SQL queries. So first of all, I'm going to create the SQL create queries. So to create all the entries. So I'm going to assume you have some basic SQL knowledge here. What we want to do is we want to create a new table, and the name comes from our habit entry object that's defined in the table name. So whenever we want to define the table name, we now just refer to this property here, to this constant so that we can just reuse this. And if the table name ever changes, we only then have to make that change in one place, and all the other places, like here for instance, just refer to this constant. So this is also good practice. If anything does change, we only have to change that in one position. So now let's go ahead and see what kind of columns we want to have. So we want to create the table, and inside the parentheses I just opened, we want to first of all have our habit entry dot title column. So we first want to have, of course, some ID column. So let's go ahead and actually add another ID column, which should actually come from the base columns, but I can't really find this now. So let's just do it like this. We add our ID column, and that should be of type integer, and is also the primary key for this table. So every habit has a unique ID by which we can reference it. And then we just go through each of the entries. So we want to have a title column, and that should be of type text, very simply in SQLite. Then we can actually copy this. We want to have our description column. That's also going to be of type text. And then lastly, we want to have our image. And in SQLite, that's going to be the type blob, which stands for a binary large object. So this is now exactly the kind of query that we want to run when the database is created. So inside here, we can simply go ahead and let's actually call this parameter DB. And it's also not necessary to assume nullability here. Then we can simply call execute SQL and pass in our SQL create entries. And that's going to execute our SQL code here to create this table with all the columns we need. So now all that's left to do is create another query for the other case on upgrade, where we actually want to first delete all the tables that we currently have, so just our habit table, and then just recreate everything. So I'm going to call this SQL delete entries. And this is going to be drop table if exists, and then just pass in the table name. So this is basically just going to remove the table along with all its data. And then down here, we can say DB. And again, I'm not going to assume nullability of this here. And also we don't actually need to consider the old and the new version here. We're just going to say execute SQL. And first of all, delete all the entries, and then just call on create in order to recreate the whole database. All right, so that's already our whole database helper. We just need to override the onCreate and onUpgrade methods, one of which is just gonna create the database schema, and one of which is gonna drop the table and then just recreate by referring again back to our onCreate method. All right, so once we make an instance of this class, we're going to have our database ready to go. It's going to create a new file called habittrainer.db, and inside there we can then store all our habits and also read from it. But that's all for this lecture. You can see we made great use of string interpolation in Kotlin so that we can just put in all the elements or all the variables here inside the string, which I think is also a lot more readable than having to concatenate strings all the time. So also again, one way that Kotlin makes the code a little bit more readable. All right, that's all for now. So I'm gonna see you again in the next lecture. All right, so now we have our database ready to go. So what did we actually want to do? Inside our create habit activity, we want to store a new habit to this database. But so far we don't have any method or functionality implemented to really store a new habit to the database. So let's go ahead in this lecture and modularize this into its own class. So I'm going to create a new class. I'm going to call this, let's say, habitdb table. So that's the table in our database that's for all the habits. And inside this class, I just want to implement all the functionality to read and write to and from the database. And for this, we're actually going to again need a context, which you need most of the time in Android in order to have access to the databases. So we want to have a function called store, and we want to be able to just pass it one of the habits that we have. And well, it should then of course store that habit to the database. And the return value is going to be of type long, because that's going to be the ID in the database of this new object. So what we can do now is we can first of all make use of our own habit, habit trainer DB. So I'm going to call this DB helper and assign habit trainer DB of the context that we have. And then we can get an instance of the DB by calling DB helper. And in this case, we want to write to the database. So we're going to access get writable database, or in Kotlin, just the property DB helper.writable database. So now what we're going to have to do, or what we want to do, is we want to call eventually db.insert to insert a new record into the database. But it's actually a bit more complicated than that, and we're going to see that later on. But for now, I'm just going to go ahead and say we want to have our table name. For the null column hack argument, I'm just going to pass a null. So that means that when we have any null value in this new habit we want to store, it's just not going to be stored. And then as the last argument, we need so-called content values. So those we're going to have to set up first. So I'm going to create a new variable called values. I'm going to say content values, import this class. And then you can simply call values.put, and then you can put each of the entries you want to have. So we have, of course, habit entry dot title, so the title column, and that's going to be habit.title, which is the argument that we got into our method. Similarly, we can set the description column to the description, and then lastly set the image column to habit.image. Well, this isn't quite correct because we want to have a byte array in order to store it to the database and not a bitmap. So we're going to say to byte array, and we're going to implement that later on. So this way now we can pass this into the insert method, and this content values here is just how we have to, well, wrap our data in order to pass it to the insert statement in the database. So you're going to have to reference each of the columns in your table, in this case title, description, and image, and then pass in the values for each of those columns. Now the insert statement here will actually come back with the ID. In the end, we should always remember to close the database. We're going to see how to improve this all later on. And I want to again just use log in order to store, or in order to log that we stored a new habit to the database, and then just output the habit here. Remember, we can simply use habit because this is a data class, and the data class already comes with a useful toString implementation. So we can just output it inside a string. And then next, just create the tag here as always. So in this case, habit db table class.java.simpleName. And that's just going to make it clear in the log from which class this is actually coming. And now the last thing is to just return this ID of the new entry in the database. Now the one thing that's left to do is to implement toByte array. So we're going to create this function down there, and I'm actually going to add some empty lines here in order to make this more centered here. So this should take in first of all a bitmap. So import the bitmap, and then it should return an object of the class byte array. Now the way we can do this here on Android and with the APIs we have is to use first of all the byte array output stream, and then on the bitmap we can actually call a method called compress, and I want to call this parameter here bitmap. So then I can call compress. And first of all, we can put in a compress format .png, let's say. For the quality, I'm going to put in 0. And then we need some output stream that this is going to be written to. In this case, just our byte array output stream. And then we can return stream.toByte array, which is going to return the image, the original bitmap, in this byte array format that we wanted. And this format can then also be stored to the database. Now, one thing we're going to have to change here is our habit data class, because currently we're still just storing an integer as our image, which was supposed to refer to the resource file. But now we want to actually store this in a database. So we're going to make this a bitmap and then just get rid of our sample habits here for now. So then we should also go into our main activity and just remove this call here for now, so we don't have this error in the code. And later on, we're going to fix everything again by really reading from the database all the habits that we're then also going to show on our main activity. But conceptually, this is now the way that you store an element to the database. So you get the writable database instance that will allow you, well, to write to the database. Then you're going to represent the data you want to store in these content values. And you're going to have to define a value for each of the columns in your table, unless you want them to be null, which most of the time you don't want. And then for now, we're just calling db.insert, which is the part of the code that we're going to look at in the next lecture, because it's not the way you should do this by just calling db.insert. There's actually more that you have to do around this statement in order to really perform a secure database insertion. And this will then also be exactly the point where we can make major use of Kotlin in order to improve the code a lot. So I hope you're excited about that, and I'm going to see you again in the next lecture. All right, so it's now time to transform our db insert into an actual robust database transaction, because there are many steps involved in this, and it's therefore a prime example of, well, some of those Android APIs that really require a lot of boilerplate code just in order to eventually make an insertion like this. So the way you're going to do this, or you should do this in order to make it a secure transaction, is to first call begin transaction. Then next you should use a try catch block, or in this case at least a try, in order to insert the actual value. And for this I'm actually going to move this out again. So I'm going to use this try block again as an expression, and I'm going to store this in some value called return value, let's say. Then the next thing you're going to have to remember is that after you have db.insert, delete, or all your methods you want to call in the database, you should always call db.setTransactionSuccessful. And then here in this case, the catch block, in the catch block we couldn't really do anything, but we can use a finally block, which will always be executed before moving on. So you can always be sure that the finally block here will always be executed. So it's a great way to call end transaction, or rather db.end transaction, because this should always be called once you're finished with your whole transaction. So basically the sequence is to call db.begin transaction, then call all your actual database operations like deleting from a database or inserting new records, then setting db.setTransactionSuccessful, and then calling db.end transaction. And if this wasn't enough yet, you also have to remember to always close the database at the end in order to free the resources and to avoid leaking the database. So now one last thing I wanted to do here was to actually use the return value as the return value of the try block. So I'm going to put this into the last line, and this way now we still get our ID so that we can return it. But you can see that this requires quite a lot of code just in order to actually perform just this one statement that we had in the beginning. And it's also very error prone, because you might forget to call setTransactionSuccessful, or you might forget to call end transaction. You might also forget to close the database at the end. And generally it's just repetition of code. So it's just a lot of code duplication you have whenever you want to perform a database transaction. So what we'll do now in the next couple lectures is we're going to take a moment here to really dive into how to make this better in Kotlin and how to make use of higher order functions and extension functions in order to avoid all those sources of error and also to avoid duplicating this code, avoiding this lengthy boilerplate, making our code much more concise and much cleaner so that we'll be able to also maintain the app much better than before. So this is going to be one of the main points here in this course where we're going to see how to actually improve when compared to Java. So this is basically again like the traditional way to do things, to call all these methods and to have all this boilerplate around a database transaction. But we'll take our time now to really improve on this, and it's going to require some steps. We can improve and improve. We're going to see that. And in the end, we're going to be very satisfied with the kind of code that's going to result from this. So let's end this here and then move on to our first improvement in the next lecture. Now, I already mentioned that we're going to improve this part of the code here. And when we look at this very closely, we can see that basically this is all going to be the same kind of skeleton code, except for this one line, which is actually going to be different for different kinds of invocations or different transactions. So how about we go ahead and modularize all this code around this actual statement into its own extension function on the database object. So I'm going to go down here and I'm going to create a new, for now private, or actually let me again go out of the class here, down to the very bottom of the file, and for now create a private function because we only actually need this here on the database, the SQLite database class, and I'm going to call this transaction. Now this transaction here is now supposed to be a higher order function which is going to take in a set of statements. So that's going to be where we perform the actual insert or delete. So this should be just some block of code. So for now I'm going to say it's just some function that doesn't return any result. Now inside this extension function, we can now begin to put in all the boilerplate, all the ceremony code, like begin transaction. Then for now in this iteration, we won't have any return values because this just returns unit, which is like a void type. So I'm just going to say try. Then we're going to call our actual function. Then we're going to set the transaction successful. And then we can use again a finally block, which we can then end the transaction. And at the end, we can close up the database. So this way now we have all the ceremony inside our extension function. So when we actually want to store a value now, we can now simply go ahead and call db.transaction and now put in what we actually want to do. So in this case, db.insert, and I should probably have copied this. So we want to store into our table name the values that we created. So you can see this is much more concise. We say we have a database transaction and we only have the relevant part of the actual transaction here. So when someone reads your code like this, it's very obvious on first glance what you're doing. You have a transaction with an insert, and that's all. That's all you really need to know at this point. And it's not really that important what kind of ceremony you have to perform around this actual statement with beginning transactions, ending transactions, closing the database, and all those kinds of things. So this is not only more concise, but also more readable. We just have one problem at the moment, which is we don't get the ID, but we're not going to worry too much about this. We're going to do this at the very end, but for now we're just going to keep improving on our extension function here in order to make this even better. So now the first thing we can do is we can say that this extension or this function that we pass in into our higher order function should actually have a parameter of SQLite database so that we can then call this function on this. And this will then avoid to ever run into the problem of running our transaction, our function here, on the wrong database. Because then we can go up in our code and just call inside our transaction, always refer to it. And this will then always refer to the correct database that we passed in inside our extension function. Now in the next step, I want to actually remove the it here just in order to save 3 more characters per operation. And the way we can do this is we can go ahead and say that our function that we pass into our extension function is actually itself an extension function of the SQLite database. And we do it this way. We again prefix, just like when you write an extension function, prefix with the class name dot, and then just define your function signature. So in this case, there are no more arguments, and then you just return unit for now. So now, since we have an extension function of SQLite database as our argument, we can now basically call this dot function because we are inside a extension function on the SQLite database here. So just like we can call begin transaction without any prefix, which is a method on the SQLite database, we can also call this new extension function on the SQLite database class from here. So now we can also get rid of the this dot prefix just as well and just call this function like we did before. But now we can also get rid of it here because our function that we pass in here, in this case this part, is now itself an extension function on the SQLite database. So again, we have access to all the methods here directly, which are defined in SQLite database. Just like, for instance, begin transaction or end transaction. These are all now available inside here because we have now made our argument an extension function by itself on the SQLite database. So we're now really using an extension function inside another extension function, and this is really a powerful way in order to really make your code very concise and also very robust. You absolutely don't need to do this. You can also just leave it at the step before and then just use it.insert here. But I think this is a nice way to handle this and to make the code just a little bit more concise. So I think I'm going to leave it at this for this lecture. And in the next one, we're going to see how we can get back our ID. So add a return value to our extension function here. And then also how we can greatly increase the performance of such higher order functions in Kotlin. So as always, I look forward to seeing you again in the next lecture. All right, so we're still in our amazing extension function here in which we want to actually extract all this boilerplate around SQLite transactions. And there are 2 more steps with which I want to improve this. Now the first one is that I want to actually get a return value. But I don't know what the return value could be. It could be a string, it could be a long foreign ID, it might be any kind of return value, and I don't really want to restrict what kind of return value it could be. So I'm going to make this actually a generic extension function, and I'm going to say that the function that I pass in is going to return some type t. This could be any type now because it's generic. And in many cases, of course, t might just be unit because, for instance, if you go and just delete a row from the database, you might not want to return anything from that. And in those cases, it's just not going to return anything. So it's going to return unit, so to say. It's going to be void. So now what we can do is we can go back to the same kind of structure we had before. We can now store the return value of the function call, which is now going to return t, and then define that as the return value of our try block. So this means we now want to store this as the value of the try block. And then at the very end, we can just return the result. So what we want to do, of course, is we want to return at the end a value of type t. which is just going to be the return value of the function that's passed in. So in our example here, it's just going to call insert, and insert actually has a return value, and that return value is of type long. So this means now that if the function here that we pass in is this block of code, then t in this case will be assigned the type long, so that we know that the return type here of our whole extension function called transaction is then also going to be long. So we can simply go ahead and just say the ID should now be the return value of db.transaction. And as you can see, when you specify the type explicitly, the type is now long because it's just going to be the return type of the statement that you have inside here. So whatever the return value is of the statements inside here is just basically going to go up to the db.transaction call, so that you can then simply save that to some variable in your scope. So with this, we also have back our ID of the newly inserted habit, but without having all the ceremony around the transaction in our actual code up here. And now there's only one last thing to do, which is to mark this function here as an inline function. And most of the time actually, when you have a function, a higher order function like this, which takes in another function, then many times you're going to want to inline that function, which basically means that wherever the transaction function here is called, this block of code inside here will basically be copied to the call side. So for instance, when we call transaction here above, then now, since this is an inline function, you can imagine the compiler will just replace this call with the exact kind of code that we put in here, and it's just going to insert at the position where we call our function here. It's just going to insert the statement we have in here. And this will just go back or give us back the original code that we wrote before we actually modularized this into its own function. And this means that we keep our modularity, we keep our readable code, but we don't lose any performance. It's just going to inline all the statements to the call side so that the performance is just like it was before. Now without the inline modifier here, it's actually going to go ahead and create a new anonymous object for the lambda expression here, because it needs to create an object for the function. So that's the same as anonymous inner classes in Java. For instance, when you create a click listener in Java, and especially before Java 8, you would normally create an anonymous inner class in order to override some onClick method. And that's the same kind of thing that's going to happen here, which eventually means that for every invocation, it's going to create a new object. And in some cases where you call this higher order function many times, that's going to be a lot of overhead, especially when you're on Android. So what you want to do is you want to avoid all those object creations. And to do that, you can simply use the inline modifier in Kotlin, which by the way is only useful if you have a higher order function. So if there's some function in the parameter that can actually be inlined by the compiler. And this way now we avoid all those object creations with anonymous inner classes and instead inline all this code. It's going to be essentially the same as before, but of course our code still looks very different, because at this point here where you actually want to look at, you have very concise code that everyone can understand quite easily and fast, which will eventually just make it more maintainable. Alright, so with this we're now ready to move on. We are now finished with our extension function for SQLite transactions, which I think was a very nice example of how we can use Kotlin to really improve our code when compared to Java. Alright, so that's it for now. In the next lecture, we're going to see one more improvement in the code, and we're also going to see how we can then finally store a new habit to the database. Alright, so for this lecture, I first promised one slight improvement. And this is going to be right up here, because notice that we're calling values.put 3 times. And for more complex data structures, you might actually call this here 10 times or even more often. Now what we can do instead, we can also use with. So with values, and then we only have to use, okay, let me just do it like this. And then we just have to call put in order to put a new entry into this values variable. And with this, we naturally have a kind of scoping which defines in which kind of area in the code our values are edited. And it can also, again, make your code a bit more concise. Of course, the name values isn't too long, so it doesn't clutter up the code too much, but still it's oftentimes worth it to use with when you have some object on which you're calling many methods in a row. And then the next thing for this lecture is to actually integrate our store method now finally in order to really store habits into the database. So let's go back to our create habit activity, and inside here we now wanted to actually store the habit. So what we're going to do is we're going to create a new. So first of all, we'll have to read all the necessary data from our input elements. So for instance, the title is going to be from our text view title, the text.toString. And similarly, we have a description, which comes from our text view description. Just get the text.toString. And then finally our bitmap. Well, that's just going to be the image bitmap, so we don't really have to store this again. And then we can create our habit object. That's going to be a habit of title, description, and the image bitmap. And now remember that this is our class variable, our class member that is actually nullable. And now this is one of the few instances where the double exclamation mark is actually the right thing to use. Because we're not calling a method on this, so we can't use some kind of save call operator here. We really just want to ensure to the compiler that this is not going to be null. And we know this because we're checking for nullability up here. But when we don't do this, the Kotlin compiler is going to come back to us and say that it cannot smart cast this because it's a mutable property and it might have been changed. Well, it might have been changed back to null at this point in time. But we know that we have a private member of our class and we never assign null to it. So if it isn't null up here, it also cannot become null on its way or on the way of the code down here. So we can actually use the double exclamation mark because we really do know that down here, the image bitmap will never be null. But make sure, honestly, when you can't come up with an explanation for this, for why this can never be null, then you probably shouldn't use the double exclamation marks unless you really just don't want to use the null safety that Kotlin actually provides for you. All right, so now we have our habit object. So now we can create a new instance of our habitDB table. Just pass in this as the context and then call the store method. And remember that this actually returns back the ID, so we can also get the ID from it if we want to. And by the way, the insert statement will return an ID of -1 if something went wrong. So we can say that if ID is 1L, -1L, so it's going to return -1 if something went wrong. We can again, let's say, display error message. Let's say habit could not be stored. Let's not make this a habit. All right. And otherwise, so if the habit was stored correctly, we can go back to the main activity. So we can create an intent from this, and in this case to main activity class.java. And then we can start the activity by passing in this intent to go back to the main activity. So let's now go ahead and run our app again to see how everything's working. And you can see we get a compile error in our habits adapter, because we changed the image property in the habit class from an int for the resource to a bitmap. So when binding the view holder here, we can now instead call setImageBitmap and then simply pass in the bitmap here. So that's not much of a difficult change. And now we can go ahead and try to run this again. And also let's go ahead and open up the logcat again in order to follow along all the log messages that we included in our code. Alright, so with the app started up, you can see we don't have any of the sample habits anymore because those were just static examples. And now we actually want to read those from the database, which is going to be what we're going to do in the next couple lectures. For now, we just want to check whether we can store a new habit. So let's say eat and just put in healthy. Then next we're going to have to choose an image. So I'm just going to choose the one with the red square. And now let's follow along our log when I click on Save Habit. You can see we get an error there and it says attempt to invoke virtual method char sequence text_view.getText on a null object reference. And we can go back up to see how this error went through the code. And we can also see which links are blue, which are the links that link to actually a class in our project. So this brings us to line 40 in create habit activity, which is just a closing curly brace. So maybe something changed about the number of lines here, I'm not sure. But since it tries to tell us that we're trying to read a text from something that we shouldn't read from, it's probably one of these where we try to get the text of our input elements. And that's because I'm actually trying to refer to TV title, which is actually part of our card layout. What we actually want to refer to is the edit text for the title element, and similarly the edit text for the description, because those are also the only ones that are actually available inside this activity here in our create habit activity. So those were just wrong imports here from the wrong layout file, in this case from our single card layout. So let's just get rid of this and try to be more careful next time which kinds of elements we're actually importing from our Kotlin Android extensions. Of course, we should here only refer to those elements from the UI which are actually available in the current activity. Alright, so let's now try to rerun our app in our Android virtual device to see if this is now working or whether we have some other mistakes or bugs in our code. Alright, so now we're back in main activity. Let's just quickly try to create a new habit. And again, I'm going to open up the logcat to see what's happening when I click on Save Habit. And you can see there was the message, I believe, that it stored a new element to the database. So let's see, create habit activity. So that's where I selected an image. And here habit DB table, stored a new habit to the DB, and the habit has title A, description B, and some image. So this looks good. So with this, we now have the possibility, or the user can now create new habits that they wish to follow. And we can see that we also get back already to the main activity. So now what we'll have to do is to actually show all the habits that we have in our database inside our main activity here. So this has been quite a long video, so let's stop this here and then go ahead and implement this functionality in the next lecture. At this point, we seem to be able to store new habits to the database, but unfortunately, we don't yet have any way to access them. So in this lecture, we're going to create a function here that's going to read all habits from the database. So I'm going to call this read all habits, and this is going to return a list of our habit type. Now, in order to read elements from the SQLite database, we will again want to use DB helper, and in this case, a readable database. We don't need a writable database, we just want to read from it. So it's enough to just use a readable database. And then what we eventually want to do is we want to, well, first of all, store that into a variable and then call db.query. And now in order to perform this query, we're going to have to set some things up. So the first thing is going to be the table. So that's just going to be, again, habit entry.table name, which is just habit. So that's the table we want to read from. Then next we have an array of columns, so an array of strings. So let's go ahead and create this beforehand. So I'm going to say val columns equals array of, and then first of all we have habit entry.id. Basically we want to select all the entries we have. So we want to get the title, we want to get habit entry.description, and last but not least we want to get the image. So now we can simply pass in columns here, and then we have lots of parameters for the selection. That's going to be null for now. Selection arguments are going to be null. We don't want to group by anything, and we also don't want to use having in our SQL statement. And our order by I'm actually going to use, so let's say val order should be equal to our habit entry.id. So I'm going to sort by the ID and ascending. So now I'm going to pass this into the last parameter here. So this really is just kind of like a builder for our SQL query. If you're familiar with SQL, you know what group by and having and so on do. But for now, it's just important to know that we're selecting all the columns here from our table name, so from our habits table, and we're ordering them by their ID in ascending order. Now this function call here is actually going to return a cursor, and a cursor is what allows you to really go through your database and select all the elements you want, which you can imagine kind of like a cursor in a file like this, which also allows you to go through the file step by step and to read all the, well, characters in this case, which are inside the file. Now the cursor in a database is going to go through each of the rows in the database and allow you to read all the entries or all the values from each row in your database. And each row here in our case, of course, corresponds to one habit of the user. So now we can read all the habits from this. So let's say habits is a mutable list of our habit class. And then we're going to go through our cursor in a while loop. So while cursor dot move to next. So that's going to return false once there are no more entries for the cursor to read from. And then inside here, we can use some of the methods on the cursor object to get some of the values in the current row. So for instance, there's getString, and getString takes an integer, which is the index of the column we want to read from. So again, we're going to have to call another method on the cursor called getColumnIndex. Or you could use getColumnIndex or throw. I'm going to say getColumnIndex. And then we're going to have to reference the name of the column. In this case, it's the title column. So let's say here our title column is actually the second column in the row or in the table. Then getColumnIndex here is going to return exactly that column. And then the cursor can read a string from this. So we have to tell the cursor that it's going to be a string that it can read from this, well, location, because we know that the title here is actually a string. So we can do again the same thing for the description, and we actually want to store this into some variables. So title and description. And then for the bitmap, we're actually going to first get a byte array. So the byte array is cursor.getBlob, and then just the same thing, cursor getColumnIndex of the image column. And then we can store the actual bitmap by using the bitmap factory from Android, and then decoding the bitmap here from a byte array. And we can just pass in our byte array here. And we actually need to define where to start and where to end. So it's going to start at 0 at the very beginning, and it should end at the end. So just byte array.size. So this will essentially bring back our original bitmap, our original image, from the byte array that we can read from the database. So now at this point we have all the data we need, so we can say habits.add and create a new habit with title, description and bitmap. And that's going to be part of all the habits we can read from the database. And then we can eventually return the habits. Now, similarly as for databases, always remember to close a cursor so that you can free the resources and you don't run into any trouble with open cursors to your database. Alright, so this should be all we have to do, and I hope you might already see some things we might be able to write in a better way by applying again some of the awesomeness of Kotlin. This is kind of like, again, the Java way to do things. But maybe you can already imagine some improvements. You might also maybe want to try some out for yourself and see what you can improve by using extension functions, for instance, in order to make this code more concise and more readable. But for now, I'm just going to go back to the main activity and then replace this line that we had before by replacing our sample habits with actually reading the habits from the database. So I'm going to want to create a new habit db table object with this context and read all the habits from the database. So this is now going to be the list of habits or the data that we want to feed into our recycler view by using our habits adapter, which again is the source where the recycler view takes all its data from. So now all our data for the recycler view is actually coming from the database. So let's see if this is already all working fine by restarting our app again. And you can see in our app we now have actually the habit that we stored just in the previous lecture with a very useful title and description, also a very useful image. But you can see we can now read everything from the database, the title, the description. We have also reconstructed our image correctly from the byte array or the blob that was stored in the database. But one thing that's still missing, I believe, is that when we create a new habit here, let's say B, D, choose an image. I'm going to choose the other one this time and then save this. Then we get back to our main activity and we actually do already show the new item. So that's very nice. So it looks like we might actually be calling the onCreate method. And I actually would have expected that we'll have to override another method in order to achieve this behavior that a new habit is directly shown on the main activity. And we'll have to see if this is really working or it's just working for this example now. But let's just keep this for an upcoming lecture for now. I want to focus more on the actual code that we wrote here, which I wouldn't say is very clean code so far, especially the part where we use the cursor here. That's really something I want to improve on. So let's do that again in the next lecture. Alright, let's see how we can improve this call to db.query using an appropriate extension function. Now the problem I see with this is that we have to pass in lots of null values for something that we just don't want to specify here, or rather for which we just want to use actually just some default value. And that's exactly what we can do in Kotlin. We can make use of default values for parameters. So let's go ahead and basically create an extension function that's kind of like a copy of the query function, but it's just going to make use of the fact that we can use default values for parameters in Kotlin. So let's go down here and create a new, well for now, private extension function on the SQLite database. So fun SQLite database. And I'm going to call this doQuery because if I call this query, this might actually lead to trouble with the original method, which will always overshadow any extension function if they use the same kind of parameters. So just to make sure, I'm just going to use the function name doQuery, and then essentially I'm going to copy all the parameters of the query method. So we have a table name that's a string, we have columns, which is an array of string. Then we have, let's see, we have when we call query, we can just take a look with Control P. We have columns, we have selection, selection args, group by, and so on. So selection was also an array of string, I believe. So that's basically just a lot of typing at the moment. And we have selection args. So selection is just a string, but selection args is actually an array of string. But once you're finished typing all this down, you're going to have much more concise code in your, well, the code you actually want to read and others want to read. So let's go through this for now. We have group by, having, and order by. Group by string, having is string, order by is string. And now, of course, I forgot the most important part, which are the default values. So as you can see in our call to query, if you don't want to have actually anything in there, you should just pass in the parameter null. So these should all be nullable, and their default value is just going to be null, because that's how the query method is implemented in Android, unfortunately. So here we're actually going to make heavy use of null, because that's just what we have to live with when working with this API. And then we can simply call query. So what we want to return here again is a cursor, and that's just going to be the return value of query applied to all the methods or all the arguments we get into our extension function. So group by, having, and order by. Import the cursor. And now with this, we can finally go ahead and replace our call to query up here to a do query call. And with this, we can get rid of all the nulls that we didn't really want to have in here, and instead just call the table name, the columns, and the order this should be. But be aware that the third parameter here is actually a selection. So what we want to do is we want to say that this should actually be the order, or rather the order by parameter. So we can simply specify that by using explicit parameter names here in Kotlin, so that we don't actually need to define all the other values. We can basically drag this one into the third position and just keep the default values for all the other arguments. Alright, so this is already a lot more concise. So this was just one quick way to improve this. And now we're going to move on to improving our cursor calls here. Alright, so now let's see how we can improve using extension functions these parts of the code right here where we use the cursor in order to get a value from the row. Because what we actually want to do is we just want to get whatever is in the title column, but it's really lengthy code just in order to get a value from the database. So this is one of the points where you should probably be thinking about, well, writing this in a better way, maybe using extension functions. So that's what we're going to do now again in this lecture. And I hope you've already tried to figure this out for yourself, and now you're just trying to see how I would do this to see whether there are any differences and maybe there is something left to learn. So let's for now just make this private again because we only need it in this file. This time it's an extension function on the cursor interface, and I'm going to call the first one getString, and I want to pass in directly a column name. So that's also going to be a string instead of an integer with the index. And then all I want to return is just this dot getString, and I'm going to call this dot getColumnIndex of the column name. So for this, of course, the return type should be string. And you could also go ahead and just make this into a one-liner again. So calling getString of getColumnIndex. But of course, you don't have to do this. You're just going to have to see what's more readable for you. I think this is actually quite a long line, so you might want to go with just a normal function syntax instead. So let me actually, well, we can actually get rid of the string here. So let's just leave this as one example of how to do this. And now with this, we can already replace our calls to getString up here to just pass in simply the column name without having to call the getColumnIndex ourselves. So now we can just say cursor.getString for the title column and the description column. That's already a lot better than before. And now let's go ahead and do the same thing again for cursor.getBitmap actually. So we're just gonna specify a column name, and we're gonna assume that the column name that we get actually stores a blob that we can then convert into a bitmap. So let's go ahead and first of all, again, just read the blob. So let's say val bytes equals get blob of get column index of the specified column name. So that's going to read the byte array from the database. And then we can just make use of the bitmap factory again, just like we did before, to decode our byte array back into a bitmap. And of course, the return type should now be bitmap. So now we can go ahead in the code above and again get rid of the lengthy call to cursor.getBlob and instead use cursor.getBitmap from the image column. This also means we don't need this line of code anymore, and we can directly call this one here bitmap. So that's also now more straightforward. We read the title, the description, the bitmap, and we add this to our list. Now, one more thing I would suggest you do in order to further increase readability of your code is to modularize this part of your code into its own method. You can simply call this something like parse habit from cursor. Well, the cursor is already the parameter, so we can just call it parse habit from, and then the parameter is going to read cursor anyway. And this should actually, if we do one method that reads all the habits, should be called parse habits from the cursor. And then we can also, if you want to, go ahead and inline this variable to just return parse habits from cursor. But of course, you don't have to do this. But now we have this modularized into its own function. And now read all habits is just going to define the columns, the order. It's going to open up a database. It's going to execute the query on the table name. And then it's just going to return the habits from the cursor. So this is now very readable with just a few lines of code. And it's quite clear from just these 5 lines of code how this method actually works and what it does. So this is always something you should strive for, to make your code really nice also for others to read and to understand very quickly. Alright, now one last thing you could do in this class, since we're using the habit entry class very often here in this case, you could go ahead and add an import for the ID, the title column, the description, and so on individually. So this way you don't have to prefix the class habit entry each and every time, which of course will also help to make your code more concise. But you're going to have to be aware of the fact that this might actually also harm readability if it's not clear what these actually refer to. Now in this case, it's still okay, I would say, because we have the name col, so it still indicates that it actually refers to database columns. You might also want to go ahead and use that for the table name. So just import table name. And for some reason it doesn't want to import that, so let's go ahead and do that ourselves. So we're going to import the table name, and now we don't have to prefix this anymore. So let's get rid of those. And of course, whenever someone wants to look up where they actually come from, there's always the possibility to just go to the declaration, and then they can see right away that it's in this object habit entry, which is part of the contracts for the database. So it just defines the table name for this specific table, which I think is also clear in this case from the variable name. But in some cases, you're going to have to be careful about importing such constants into your code just in order to get rid of the prefix and really make sure it's still readable. I think in this case it's still okay because as I mentioned, we have the column. So it's a title column, description column, and image column. And since we're in the context of reading from a database anyway, it's quite clear what they refer to. But those are just some of the things to think about when you decide whether to make such changes to your code or not. And it's just something I want to prioritize here in this course because there are many courses about Android, but not many courses that also show how to actually write good code or clean code, also in the context of Android, but also in pretty much any other field. And it's just something we can achieve very well with Kotlin. So that's also just my goal with introducing extension functions, using higher order functions, using data classes, and so on. Those are all concepts that really improve the quality of your code because they make it more concise and because they make it just more readable. So I hope that you can see the benefits of this. And of course, let me know in the Q&A if there's anything you disagree with maybe, or just if you have any questions or any suggestions for me for this course. So thanks a lot, and I will see you again in the next lecture. This is just a quick lecture in between. For those of you who, like me, don't really like looking at an app like this all the time, where you just have some very stupid sample content and image like this. So I just want to quickly mention how you can actually transfer the resources, the images here, to your virtual device, so that when creating a new habit, you can then actually choose that as an image. Now, it took me a while to figure this out, and there are many complicated ways to do this, but it turns out you can simply select the files and drag and drop them into the virtual device, and they will then just be copied, as it says in the tooltip, to the downloads folder. So you can just do it like that, and then when you go and begin a new habit, you can type something here, and then when you want to choose an image, you can actually go here, you're going to come into recent, you can go into the downloads folder, and then you can select one of the images you want. And this way, of course, you can also add many more images than just the ones that came with this course. And it's just a super simple way to do this, and it gives you a much nicer app to look at when you are developing on your local device. So that's just for those of you who want to have some more beautiful test data, so that you can look at real cards that actually look nice, like this one, where you can have the habit of drinking water and not one like this. And that's already all for this quick bonus lecture, so to speak, just so you know how you can easily transfer any images to the virtual device. In this lecture, we'll finally see one of the powerful ways that Kotlin can improve your code when compared to Java. Now, normally we don't actually want to have a fixed text for our card layout here. So let's say we just remove this description, and we want to actually set that description programmatically in our main activity. So first of all, we're going to have to get a reference to that text view just to then set the text. And as I mentioned, oftentimes I'm just going to go for the Java way to do things, and then I'm going to improve on that by using it the Kotlin way, or using some of Kotlin's features in order to improve the code. Now, unfortunately, many other courses on this topic actually stop at the point where they just use Kotlin completely like Java, and they don't actually make any use of the benefits of Kotlin when compared to the Java language. So we're going to do this better in this course. So you're going to see how you can actually write cleaner code with Kotlin. Now, the Java way to do this would be to create first a private member variable in our activity. And we can call this, for instance, text view description. And actually, we can't even make this a val. We're going to have to make this a var, because we'll have to initialize this with some value now. And then later on, we're going to have to assign the actual text view. So this should be of type text view, but we have to initialize this with some value now. So we can only go for null at this point. So we have a nullable type, and we also have a mutable variable instead of a val. And this is exactly what you'll see normally in Java code, and it's pretty much also the only way you can do this. And then inside here, you can go ahead and say TV description equals find view by ID. You can get the ID from this R file using r.id, and then we call this TV description. So this find view by ID here is going to be used in Java code all the time to get all the elements from the layout that you need, and then to put this into this variable here. And in Java code, you'll actually also have to cast the result of find view by ID normally. Here, this is going to refer to find view by ID of a text view, because that's the type of our member variable, TV description. So in Kotlin, we don't need to explicitly define this. And now we can go ahead and say TV description.text and set this to, well, I should probably have copied the value or the string here. So I'm going to do this now. Switch back to main activity. So here you can see that with Kotlin, we also run into trouble again because this is a nullable field. So whenever we want to actually access this, we're going to have to use the save call operator. So only if this is not null, then we're going to set the text. Now in other courses, you often see the double exclamation mark used very often. That's already a warning signal, or should be a warning signal for you that they just don't really understand how to work with nullables in Kotlin, and also just don't know how to avoid nulls in the first place. So here you can simply use the save call operator because, well, this of course shouldn't be null at this point. We have just set it to the view, but it's just not necessary to go for the double exclamation mark, because if this is null, then, well, you just don't want to set the text. You just want to set the text here if it's not null. So remember that if this property here is actually null, then this line will just not be executed. And that's of course the safe way to do this. Alright, so that's completely the Java way to do this. So now let's go ahead and improve this one step by using Kotlin's late init modifier. So this means that this variable here doesn't need to be initialized at this point in time already. So this means we can now get rid of the nullability here, and instead we can still use our code as before. We just have to make sure to actually set a value to our member variable before using it. So with late init, we basically say that we're going to initialize this before use. If we don't, we of course run into trouble because, well, we can't use a non-initialized variable. But this is just a nice way in this case to get rid of null. But we still have a var, we can still use a val because we do still set TV description only here in this line. And it's actually not possible with the combination of late init. So this is already a lot better than before because we got rid of null in our code. But now in Kotlin there's actually a very nice way to do this even more simply. So when you go back to the build.gradle file for the project, you can see we have this plugin here called Kotlin Android Extensions. And that's gonna automatically go ahead and create member variables that we can simply access in our code without actually doing this ourselves. So the way this was called in our layout XML was TV_description. So you can see that's actually available here in our code already. So there's no need for us to actually create a member variable and to clutter our code with, well, when you have 10 properties, so you're going to have all those up here, then you're going to have to initialize all of them in the onCreate method. So it's going to really clutter up the code with just very simple initialization. And this way here, you can simply go ahead and use all the elements from the layout right away. So you could also see we have TV title. That's also available. We could set some text there. And of course, you can also access the image view and then use this in the same way you would with any other image view in Android. For instance, setting the image bitmap. So this is a really nice way to get rid of some of the clutter and boilerplate in your code. And it's also a very safe way to do this. You don't have any trouble with null. You don't have any mutable member variables in your class. And you just got rid of lots of lines of code. But there are also some drawbacks to this approach because first of all, this is a little bit of magic. So for many people who aren't used to this, it's going to be unclear where this variable suddenly comes from. Of course, you can always in IntelliJ or Android Studio just use Control-B to go through the declaration and they're going to see, oh, it's just the ID of the element in the layout. So that's where it comes from. So they're also going to be able to know how to access other elements like this one, for instance, and it's not going to be so magic anymore. But at first glance, it's going to be, well, a little different than what people are used to from the Java world. And also you should of course make sure to use good names in the layout XML. You can also go ahead, of course, in your layout now and actually use names that follow the coding conventions for Kotlin or Java, so that in your code you have a member variable called TV description with camel case so that it fits better into the rest of the code. But you may also want to actually stay with the normal XML kind of naming things, because that way it's also clearer that this is again one of those variables that comes actually from the layout. So here in this course, I'm actually going to stick to the XML naming so that when you see a variable with an underscore, for instance, you know immediately that this is coming from the layout. And also I'm going to make use of Kotlin Android extensions in general in order to get rid of all the initialization code just to access all the elements from the XML layout. Alright, so again, we made our code much more concise with this. We also made it much safer. We don't have to use null. We don't have to use mutable member variables. And it's just very easy and concise and, well, nice to use. So I hope you like this approach using the Kotlin Android extensions. And of course, in the coming lectures, we're going to see many more instances of how we can make our code cleaner with Kotlin. So I hope you're excited, and I'm going to see you again in the next lecture.